Here you are close to big business, both Polish and international. Contacts with various industries are within your grasp. Nearby, professional research laboratories are growing. Here, science supports development of the newest technologies. Well-educated specialists are easily available. All that in one region. Come and invest here. Świętokrzyskie, close by.
Ladies and gentlemen, it's my great pleasure to welcome you on the second day of the European Rover Challenge 2022. The biggest robotics and space event in Europe addressed to the world of science and business as well as the general public is held in Kielce, Poland, and broadcasted live. Let's welcome participants of the Rover competition, space experts present with us, and broad audience joining us here, and those who watch the broadcast live. The Moon Day, so today, is supported by the Polish Space Agency. Co-organizers of this year's edition are the European Space Foundation, Kielce University of Technology, and Świętokrzyskie Voivodeship. The role of the host city of the event belongs to the city of Kielce. The event is held under the honorary patronage of the European Space Agency, International Astronautical Federation, and Polish Space Industry Association. Partners of the event are Polish Space Agency, European Union Agency for the Space Programme, International Space University, MathWorks, Polish Space Professional Association, Mars Society Polska, Poznań University of Technology, Kiel Ideas, Koźmiński University, and Freedom Robotics. Supporting partners are the US Consulate General in Krakow, United Nations Vienna, Pokojowy Patrol, and Pyramid Games. Award sponsors are Sener, MasterCard, Mastercam, and Occupy Mars The Game. The event is supported by media patrons: RMF, Polish Press Agency, My Company Polska, Space24, Kosmonauta.net, Spacewatch Global, Astrofaza, Polish Science Fiction Foundation, Naukowo TV, Crazy Nauka. The project is partially financed by the Social Responsibility of Science program of the Ministry of Education and Science. This year, a record number of participants entered the European Rover Challenge 2022 competition. Nearly 100 teams from several continents take part in the Rover competition. Let's learn about the insights of this year's competition and welcome the representatives of the jury here. Let's welcome Dr. Anna Łosiak, responsible for the science task, Szymon Dzwończyk, head of ERC remote jury, and Jakub Muszyński, who is responsible for maintenance remote task. Please. Good to see you. Good morning. So I guess you had a tough night, because I saw you were working actually yesterday even till after midnight. So because of the weather forecast and rains on Mars Yard that we have here, could you comment on that? That was not planned as far as I remember and know.
No, usually we don't do that. Usually we try to run the competition during the day when the lightning conditions are much better. However, because of the amazing space technologies, namely the satellites, weather satellites that are providing us with quite good weather forecasting, we were able to figure out that today it will be raining, and it is. So we were trying to just pack as many rides as possible during the yesterday's night. But again, thanks to the space technologies, Earth-based space technologies, we were able to avoid the worst, which is flooding the rover. So yay.
So, but the competition is now taking place also during the light rain, or is it somehow stopped? How does it look right now?
So, so actually, maybe works. So actually, they moved us to the rain. Does it work? Yeah, maybe no.
Maybe, yeah, it should work, but maybe the volume is lower.
So actually, they moved ERC remote to the raining conditions. So yeah, we are now waiting for the worst, like for the bigger rain, to perform our version of the competition. So yeah, it doesn't really touch the maintenance because you are under the roof, right?
Yeah, I think it's the only competition that's not affected by any weather. The only thing is that when the sun moves towards the windows and it falls in a steep angle, we try to cover the windows in order to provide the same lighting conditions for every team, because it's for the cameras, in order to detect all the markers, the lighting conditions needs to be very in steep. When there's a light coming in the center angle, it's impossible to detect all the modules. So that's the only thing that the weather affects us.
So they actually act as like typical geeks, right? So when you see the light actually coming from the from the clouds, you just close the windows because yeah, it shines into your computer. So like this on-site competition is still taking place in this mild rain because that's like by the rules it can happen, and that's something that happens now. The teams actually take like umbrellas and other like covers and then just like walk behind the rover with those umbrellas to somehow make it safer. And but yeah, in this bigger rain, actually we moved in the schedule, we moved the remote competition because actually we can perform this competition like even the navigation task in the rain, because like that's how the rover itself is designed. Yeah.
Okay, because it's the same rover for everyone, right? So then well, no one can complain that the weather condition affected that. So
yes, right? Yes. So that's one of the things. Second thing is that we have enough spare parts that we can actually change. Like if we can fix the rovers. Yeah. So in case of the teams, you have one rover and you have spare parts, right? But you don't want to really. You don't want to really drive in those really dangerous conditions because that's the only child that you have, right? And in case of remote navigation, navigation and science, so this task, we have enough rovers, enough spare parts that we could fix that. The rovers are waterproofed, and we have special coverings on that, so we are not so afraid of the rain. Like the worst part would be actually that we need to walk there, like in this muddy, muddy Mars Earth now.
It will get very dirty very soon because when our Mars yard will get a little bit of water, there will be a lot of mud being formed because of amazing amount of clay minerals that are within our Mars yard. So yes, we will all be covered with reddish mud. Yay.
So talking about the on-site part of the competition, which tasks have been already completed? So is that is the same number of the task that was completed for every single team, or is it just like a mix? So they have a given time to carry out the task, or this is, or you say now it's time for a science task, or now it's time for, I don't know, given team. Rover.
Yeah. So you have the schedule, right? And the teams actually they need to fit into the schedule. The schedule is super tight, and so it depends actually how do you find into the schedule. So it's not the way that, for example, maintenance task is done and every team does the maintenance task and then like science and then collection, probing, etc. It's that like every team has their own place in the schedule and they need to fit into that. So they need to actually prepare the rover for the task because they can actually have different setups for different tasks. They need to prepare the rover, come to the competition place and perform the task. And yeah, so I wouldn't say that something is already done. Like, we're still in the process, and we need to. They need to actually, like, we just sit there and see and watch the on-site version, but they need to actually yeah, do everything at once, really. So we have several times where we have like 2 rovers at once in on Mars Yard. Sometimes 3 rovers because of some other like scheduling issues or something like that, and yeah, it's still ongoing.
And actually setting up a schedule for the competition is extremely complicated task. I have no idea how much he does it, because it requires him to put together like a 3-dimensional puzzle where a lot of teams, like the schedules of different teams cannot overlap, and there are a couple of different tasks. They need to have enough time between different time slots. As Szymon just said, to rebuild their rovers a little bit, and also then everything just breaks down sometimes, or including the problems with weather, which requires us to change everything. After all this very careful consideration, everything needs to be reconsidered on average every 2 hours. So it's like, I'm really happy I'm not responsible for that.
So let's talk a bit about the maintenance task. So we already mentioned that the remote one is held indoors, right? And the on-site one is held outside. How does it look?
Yes.
Okay, so there are 2 like separate things for that, right? But is the task the same, or?
Basically, it's the same. It requires operations. I wouldn't say manual operations, but it requires to use a mechanical arm to do like manual tasks. So in the remote formula, teams control a arm from every corner of the world by connecting by the internet. And with the on-site formula, teams control arms that they build, and they are on-site controlling them also remotely, but from the tent just behind the panel. The main difference is that in the remote formula, we provide the arm. It's a industrial robot. And with the on-site formula, teams build their own robotic arms. So this on-site formula, beside the controlling part, requires also the hardware engineering part. So it's really like harder. But in the remote formula, we don't leave teams with easy task. We make this actual task really harder than the on-site task to push teams to their like imaginative limits, so they can try as hard as they can.
And I saw several drones being set to the air yesterday. Is it part of the competition, or that was just filming, or?
It can be part of the competition. When I was competing during my student times, we used a drone on our rover. It was actually the first ever time that one of the teams actually used a rover. It was kind of new back then, 11 years ago. And it helped a lot. It really helped. Actually, we won the competition because of that. Like having support from aerial view of the terrain of the competition site. It changes the way the navigation is done like radically. We in about a third of given time we achieved like all of the task objectives. So it was like huge improvement, and it's no wonder drones are gaining so popularity, because they are so useful.
And after that, they actually banned the drones in the competition, right?
I don't know if they banned or just made rules so hard that actually it's made impossible.
It's actually too efficient.
Ah, really? That is it work this way?
Yeah, because like part of
But
the
can I ask one more thing? The current Mars mission had like a copter on board, so it's a technology that is being tried on Mars to improve. It's so efficient that we actually as a humans, as a scientists, as a engineers, we would like this efficiency on Mars, because rovers are quite slow machines. And this first rover copter on Mars, it was like more like testing the technology than actually using it as a scientific tool. It made some flies, so it proved the concept. So I believe next Mars missions will certainly somebody will like to have drones on Mars.
Well, you initiated that 11 years ago, right? So
Yeah.
can feel like fathers of the concept. So
I can share my idea.
So are there any unexpected things or plot twists that happened during this competition? Some last-minute changes, some problems or issues that are kind of unexpected that you could share with us? Because I assume there are also some of them that you shouldn't share to the public. So
yeah, so the rain. Yeah, the rain is something that really
It never happened?
It It happened once a lot of years ago, I think, right?
I think 15, 14 or 15,
Yeah.
just in the very beginning.
I was there. So but then ERC was so lucky to never had those problems, and so unexpected was that it's now raining. Like it wasn't supposed to rain now, right? It was supposed to rain in the afternoon. That's why like the schedule, like it was rescheduled. So like the on-site teams would be able to drive now, but so maybe it's not raining. It's like this mild rain still. But unexpected things in ERC remote was that Anya and her team built the terrain so tough that the teams are always rolling over. Like the rover that our little rover that we use in ERC is only one team. So we had like 8 teams yesterday. Only one team didn't roll over.
Wow.
There was one team who rolled over 5 times during the same like 30 minutes.
And we were really afraid that we'll make it like this year. It will be too easy. So
it's not. It's not. Yeah.
So sometimes it's hard to guess which part will be the most challenging, and we still haven't figured out what is the most what is the exact problem with the increased level of complexity.
Yeah. It's still unknown. I tried the rover yesterday, and I drove overnight, like during the night. And so I actually drove on the volcano as well. It went there, and I rolled over only once. So yay, not 5 times, but it's super tough.
But I believe it's good that it's so tough. I strongly believe our Martian should be like unforgiven, because it's actually the reality of outer space missions, right? If your hardware, if your stuff just broke on the surface of asteroid or on the surface of Mars, it's like game over, right? So be prepared for the most difficult, for the most challenging.
So next year even more complicated. Yes? No?
We will make we'll make 1/3 of the gravity somehow.
We can roll over.
And it's really, sometimes it can be seen that because of so hard task, because the teams should done so much to accomplish this task, there can be seen the satisfaction they have. Because if it would be easy, if they just run through, it would be like, okay, done. But the struggle makes the victory worth it. And it's beautiful.
Yeah. So actually when the team gets full points, it's our failure. Because it wasn't advanced enough that we could actually then measure the thing, right? They get full because they knew what how to do that. Like the best part is when they actually like the level of the competition, the advancedness, right, of the rules is the way that they are in some kind of middle or something like that, right? And yeah, so that team actually got -100 penalty points, and
So
maybe it was better not to drive than drive.
So is there any killer task? I mean, something that, okay, we know that the Mars yard this year is pretty tough, but is there any task that you already know that none of the teams or a very few teams completed?
In road maintenance, there is no specific task that's very tough to do. But the thing is that we have limited time, so the real struggle is to do all the objectives in a set amount of time. And so far, no team has ever done that. Just an hour ago, we've had a team who was really close, but they lacked like 5 more minutes and they would have done it. But I remember two years ago where we've had Ethernet cable, and the teams were supposed to plug the Ethernet cable in. And the Ethernet cable is very specific, like the cable used to connect your laptop to the internet, because you can only use one orientation, and it has to click in the socket in order to work properly. So I don't think there was any team who did that, or maybe they were really close, but it didn't click in. So that's the thing that I remember was very difficult 2 years ago.
So do they know the tasks, let's say, in that maintenance thing? They know it before, right? And then and they know the position of the things. They
know how for example, with the Ethernet cable, they know how the socket's going to look like, but they don't know where exactly it's going to be. That's why we have the markers, and we were covering the windows in order to provide them the correct lighting conditions to detect them.
Ah.
And so
can I ask about the level of hardness of this task? It's like it's quite easy to ride a car, right? This is the steering wheel, this is the gear shift, but try ride the car remotely with your mouse by looking at your screen. Yeah, it's exactly the level of hardness of this task.
yeah, and like in my opinion, the biggest part is that the teams need to be aware what they can do, because of the limited time. They can actually, for example, like omit some of the objectives, for example. Yeah, they don't need to do everything. They need to be aware that they can, like, physically, like they are able to do some stuff, and they aren't able because they were not prepared, or it's too tough or something like that. Like, honestly, I would just not like wouldn't do the stuff like with the socket, with the Ethernet cable. Just yeah, forget about it.
Yeah, many teams left it as a last objective. If they have time, they attempt it, but it's not the first thing they would do.
Yeah, so a good strategy, like putting things in time, right, is also an issue. So
It same rule applies to trying to do science. So in the science task, the teams are supposed to set up their own goals, scientific goals for exploration, figure out what needs to be investigated on the Mars yard, and then perform it. However, some of them really understand that they need to, one of the very important things to take into account is their own rover. So how good are their cameras? Can they, for example, see something from quite a far distance, so that when they are planning their scientific exploration, they do not need to go very close to the spot? Is it possible for their particular design, or it's better to drive closer to do that? Or do they have any spectrometers that they can use to solve their hypothesis, or maybe not? In addition to asking if the question that they are trying to solve is actually important or not. So again, this kind of strategic approach towards not only the competition, but also, real life. Is it worth risking rover life to get to the high mountain where there's amazing outcrop, but it can potentially end the mission? Sometimes it's worth it, and sometimes it's really not. So this is one of the most complicated questions that real scientists working on other planetary bodies also need to answer to themselves.
so that's Yeah, I think pretty responsible thing, right? So, just to sum up, are the scores already know? So, do the teams, they know how many points they get after completing every single task?
Yes, after each run, a team knows how many points they got, and we summarize them, and I think tomorrow we will know all the team scores.
Okay. So do you know, well, or it's not secret, I guess, or like the top 3 teams, or
It
maybe
is secret.
it is?
You can't ask that that question here. Yeah.
Okay, but they know how many points they get. So if they ask around and
guess
the others share these things, they can assume.
So
that-
it depends on the task. Like in maintenance, they know. In science, it's still too early because like those are these reports that need to be checked. In navigation, I don't share the points as well.
okay, so it depends.
So
on
yeah,
the task.
So I cannot say.
You know it all though.
Yeah,
so-
but there are two things, like being like the winner of like first, second, and third prize, and second thing is that you can get a jury reward,
Okay.
and there are rewards for each task, for like the best performing teams, which doesn't necessarily mean that the team got the best points in the task. It's pretty much how the jury felt about that team, like that team, and for example, if in navigation we see that there was the best like autonomy drive in the thing, like doesn't matter really how much they roll over and so on, they can still get this additional reward for that. So that's something that we already, let's say, no, but we still didn't have like all the teams, like all the drives. So we still
Yeah,
need to
so
check.
just to clarify, it's not about like how jury feels about some teams. It's more about if the team, sometimes the teams are taking high risks in order to do something new and something exciting, and because of that, maybe they are not optimizing their points, but they are definitely getting new interesting approaches out, and you know, sometimes even if you are not getting the max points, you are actually pushing the task, the boundary, the you know, what you can achieve more than if you would, you know, follow the procedure. So that's what we are trying to reward in this those additional points. Yes, awards. Yes, thank you.
Okay, well, thank you, and good luck with the rain, or hopefully not rain, and good luck to the teams, both in a remote and on-site mode. And thank you for sharing your insights with us. And talk to you tomorrow, I guess. So, thanks.
Here is a place where you can start your company. Here you will also establish professional contacts and develop your business. Attractive conditions await your business. Land for investment and infrastructure offer unlimited possibilities. Here, business meets the world of science and technology. Young inventors conduct projects on a cosmic scale. All that in one region. Come and invest here. Świętokrzyskie, close by.
We are Sapienza Technology Team. We come from Rome, Italy, and our team is composed of students from Sapienza University of Rome. After 3 years of developing small rover prototypes, we decided to test our skills with a more complex project, ERA, and face our greatest challenge yet. We then decided to participate in this edition of the European Rover Challenge, to apply in a practical project the knowledge acquired during our studies and learn new skills along the way. Our team is branched into three main divisions: hardware, software, and electronics. Every division is composed of different subsystems, and each one focuses on a different area of development.
The hardware division develops everything that is related to the physical realization of the rover. Our division creates the main structure, based on all the requirements provided by the other subsystems. We use a rocker buggy suspension system, firstly designed in a CAD environment and then improved using a dynamic simulator, getting as a result a stable platform for the robotic arm, capable of overcoming high obstacles. At the same time, we choose an airless tire design in order to reduce vibration and simplify the navigation through difficult terrain.
The software division develops the algorithms for manual and autonomous navigation using a visual odometry system and the control system for the robotic arm, which involves manual control, autonomous operations, and trajectory generation. Our solutions are first tested in a simulated environment, using the components provided by the hardware division, and only after they are tuned and finally used on the physical rover.
The electronics division is responsible for designing and making our custom mainboard, which powers the entire rover and reads all the sensors, and choosing the right components for each subsystem. It is also in charge of developing the embedded firmware, thus connecting hardware and software.
The area of Mars we selected has some interesting properties. In fact, here different terrains and deposits from different geological ages meet. In our mission, we are going to sample and analyze terrain from this area. By analyzing the interactions between water and lava in the past, it's possible to potentially find some traces of the development of life.
Hi, I am Darina Butiakivska, leader of the Sirius program. We are members of Student Space Association at Warsaw University of Technology. Our association is based at the Faculty of Power and Aeronautical Engineering, where we have 2 rooms, one for meetings, programming and planning, while the other one for performing manual works, with the usage of such applications like SolidWorks, ANSYS Mechanical, GitLab and many others. We are designing our rovers since 2009. Currently, we are developing the Sirius second rover. It is a part of Sirius project in which we are planning to create rovers that will have similar sizes and high degree of interchangeability of the parts. When we were designing the first iteration of Sirius rover, we have decided that it should suit most of the challenges and events, which is why its mass aims below 50 kilograms and has not more than 0.8 meters in any of the dimensions. The most important system of the second iteration of the Sirius rover is the new suspension. Application of the copper beryllium and complex geometry optimized with finite element method analysis allowed us to create suspension that is effective yet has no kinematic pairs. Optimization of geometry ensured merely 8 kilograms of weight despite used materials. The material ensures high tensile strength combined with appropriate elasticity. It allows us to join wheels with the mobile platform, successfully attenuate the vibrations and absorb shocks. 4 in-wheel BLDC motors not only ensure motion of the rover, but also help to lower the center of mass and improve the stability of the structure. The new design of the mobile platform ensures the robustness and low mass of the rover. Key electronic components, including onboard computer and lithium-ion batteries, are mounted inside the platform. Division into 3 sections of summarized volume of 11 liters guarantees reasonable separation of the components. Transparent materials ensure permanent control over electronic components that are placed inside.
The main features of the robotic arm are precisely controlled movements, achieved with the implementation of absolute and incremental encoders. The use of simulations shall give the team an opportunity to finalize and implement the inverse kinematics solution. The maximum height reached by the arm is approximately 1.5 meter, while the maximum weight of the lifted object is 5 kilograms. At the same time, Rover is capable of pulling the masses over 60 kilograms with nominal speed, whilst weighing 13 kilograms by itself. Safety and reliability are the key features that guide the communication. Our team is highly flexible in the usage of different communication channels. At any time, it is possible to switch from 2.4 GHz to 5 GHz frequency band and in reverse. The communication systems have been tested in the field and industrial regions. By placing the antennas on a different height, we can still control the rover from 100 meters on flat terrain and at least 50 meters whilst being hidden behind buildings. The 7 kg science module consists of a spectroscope and a module used for probing and investigating the substrate for the existence of life. Usage of 4 chemical reagents enables detection of extinct and extant life. A drill shall allow us to safely gather the ground probes, which will be stored and analyzed in an onboard wet laboratory for the presence of calcium carbonate, proteins, ammonium cations, and phosphorus. High safety and leak resistance of the system are ensured and have been tested multiple times. As mentioned, module is capable of performing onboard analysis with the help of a live view camera, but it is also able to transport extracted samples and can be equipped with sealable containers. To facilitate the operation and make the control of the rover user-friendly, the interface systems have been developed. One of them allows the manipulation of the movement of the rover and its systems, like the manipulator or the science module. The second one provides real-time visual information from the rover's cameras. The autonomous movement of the rover searches for the shortest path and recognizes the artifacts with the usage of ROS, the Robot Operating System.
The Space Concordia Robotics Division is a multidisciplinary group of undergraduate and graduate students from Concordia University in Montreal, Canada. Within our team, we have sub-teams that handle different responsibilities for each aspect of the project. The following image shows our team structure. In addition, we are participating in the European Rover Challenge because we believe there is valuable experience and knowledge to gain within each respective sub-team. Competing with others puts the team in an environment that forces us to ensure our systems meet requirements and are reliable enough to complete the tasks within the scope of the competition. The Rover uses a custom-made power distribution system that interfaces with the batteries and distributes power to the rest of the system. It has firmware that actively monitors and can cut power to components with irregular behavior. The Rover is also coupled with high-level operator software that displays electrical status for each motor and overall system, with a soft emergency stop for cutting power to motors and other electrical components. Within this high-level software, there are video feeds and sensor feedback to assist the operators. This allows for manual control of the Rover, either with PlayStation 4 controllers or keyboard controls. A big aspect of the safety system is the inclusion of a physical hard emergency stop that instantly cuts power to the Rover in its entirety. The electrical system of the Rover is designed to safely deliver power to actuators and obtain sensor values, and consists of the batteries, 2 PDS power distribution system devices, the main board, motor drivers, and the arm sensors.
The Rover's triple bogey suspension has proven effective in the past, and has been enhanced this year with CNC machined links to increase its stability. The mobile platform's height has also been further reduced to lower the center of gravity of the Rover, increasing its stability over steep terrain. The manipulator has 5 degrees of freedom with compliant digits that allow it to grip around objects, improving its grip strength without causing damage or marring the items. The arm has also undergone a complete redesign, with new gearboxes and arm pivots that were designed to reduce backlash and improve maintenance. The new arm is also considerably more modular, allowing us to change out the gearboxes under a minute if needed, and allowing for more devices to be added, such as our absolute encoders, the DLP Near Scan Nano, or our upcoming LIBS fiber mount. The arm is also optimized to reduce weight with topologically optimized plates, and better use of material netting a 1.2 kilogram reduction in weight. The absolute encoders allowed us to implement inverse kinematics, which considerably improved the dexterity of our arm and allows us to perform complicated manipulation of equipment. This is in addition to our more powerful motors, which allow the arm to move faster while lifting the same load.
The Rover makes use of an Oster 3D LiDAR and Z2 depth sensing camera in order to map terrain and localize itself within its environment. Water cooling was also added to the LiDAR base to improve thermals, increasing its accuracy. The rover is also coupled with AR tag detection for helping operators and our autonomous navigation system navigate the competition grounds.
To test the hypothesis, Beep will navigate the Mars yard with a webcam, allowing the team to monitor the site for interesting geological features. During this process, the images are compared to the created Excel database of physical and chemical characteristics of various known rock and mineral samples for identification. In addition, Beep will measure the levels of nitrogen and phosphorus in soil with the NPK test and will analyze the water content of the rocks with the near-infrared spectrometer mounted on the arm of the rover. The level of acidity and alkalinity of the soil will get determined with a pH probe. The consistency of these results will lead to an evaluation of the hypothesis.
The Space Concordia Robotics Division is a multidisciplinary group of undergraduate and graduate students from Concordia University in Montreal, Canada. Within our team, we have sub-teams that handle different responsibilities for each aspect of the project. The following image shows our team structure.
Since the main topic of the second day of European Rover Challenge 2022 is the Moon, it's time to learn a bit more about the lunar exploration. Let's welcome Maria Antonietta Perino from Thales Alenia Space, who will join us online for the presentation about that topic. Maria Antonietta, can you hear us?
I can hear you fine, and you can hear me?
Yeah, we can hear you well. We can also see your presentation, so I would say the virtual stage is yours. Thank you.
Thanks a lot. It was not that easy this morning to establish the connection between Italy and Poland, but we made it. And in a similar way, for sure, we'll carry on the connection between our beautiful planet and the Moon as soon as we manage to send again representative of the humankind back on our satellite. So let me start to share with you the main reason why it makes sense to go back to the Moon and this time to stay without stopping there, because we have Mars as the next place we want to be with people. So why we explore space? There are many different reasons. First of all, there is an important scientific push. As much as more as we explore, as more as we have options to find answer to the big whys. Where did we come from? Are we alone? Are there other places where we could learn where to live and work? For sure, there are political interest, leadership, national prestige, Exploration is a push to develop new technologies, new business opportunity, international cooperation. We cannot do Moon and Mars by ourselves. It's not a matter of a single nation. It's a matter of humankind. So we go there together. And there is a big plus related to stimulate in the new generation interest in science, technology, engineering, mathematics. You can perceive that there, this very moment, around you, you have so many crew of students that are trying to solve the locomotion aspect, the communication aspect between the rover and the base and so on. And for sure there is a good reason to try and explore, because we are looking also for a second place where we could live. The starting point is very close to us, 400 kilometers above us, around us I should say, the International Space Station. This beautiful piece of engineering, we are a little bit late, so I cannot go into the details, but it's a summa of collaboration. So all the major space agencies have contributed to offer, to develop the possibility to have an orbiting laboratory where anybody can work in peace. And then what? And then for sure we want to export our capability to live how can I say, in space further, around the moon first and on the lunar surface. So we are talking about the Gateway that is currently in development, and then the lunar surface infrastructure. New players, for sure the whole story started a few years ago with a strong commitment by the American president to bring people back to the moon. To do that, we started together, NASA and ESA, to develop a new transportation system, Orion. We are all waiting these very days to see the first unmanned launch to try and verify the capability of this new piece of beautiful infrastructure. I already mentioned the Gateway, so Orion will bring the first astronauts in orbit around the moon. Beside the American, for sure, also China is developing a very interesting capability with the Chinese space station. The Emirates, among the new players, for sure, space is changing quickly because we have the private sector that came into the loop with a big step. So Blue Origin, Sierra Nevada, SpaceX, Virgin, and so on. And not only companies, but also governments. Just to mention one, Luxembourg, few years ago, already started to support, to really to devote resources for the development of capabilities focused to reach, for example, asteroids and mine the many resources that we can find there. So the NASA vision is really now become an international vision to go back to the moon and to bring finally the first human on the lunar surface. So I already touched upon the need to develop a new transportation vehicle, Orion, for which Europe is really contributing heavily. So NASA is providing the pressurized capsule, but the service module, the European service module, is provided by ESA, and there is an industrial consortium led by Airbus with our company responsible to provide propulsion, electrical power, thermal control, and consumables. The schedule of the flights we all know. Hopefully before end September we'll have the first flyby without the crew, followed by a crewed flyby in 2024, and finally the moon landing in 25. So why the moon? Many reasons. For sure, the moon is very close, so is a possible destination for humankind. Moon is a very stable and interesting, let me call it planet. Is a satellite, but indeed there is a common story with our planet. So if we go there, we can learn and discover what happened to our planet centuries ago. There are many resources on the moon. In the next view graph, I will point the most interesting ones. And the moon is a possible place where to validate the technologies that will be needed to move further toward Mars. Is the moon very benign? Not at all. The moon is tricky, and this is why we love it, because we believe that we have the capability to, how can I say, to protect ourselves from this very harsh environment. There is no atmosphere, so that implies that all the radiation, the galactic radiation, make to the surface. So we will need, for example, to protect our habitat, our outpost, by using the local regolith. Talking about the regolith is a very interesting bunch of possible resources, interesting materials that if we learn how to, separate them, can turn into resources. So we have a lot of oxygen in the regolith, link tied to silicon, iron, calcium, aluminium, magnesium. So by splitting this material, we can use the oxygen for the base itself, but also as propellant. We can use the silicon to produce solar cells and so on. Why it makes sense to start with the Gateway? Because from there, again, we can validate the technologies before using them toward Mars. We can also study how can I say, the challenges are not only technological ones, but also psychological and physiological ones. So the Gateway will offer us the possibility to check how people react to long duration mission far away from our planet. We will also have the possibility to check and validate long-term autonomous system and to teleoperate from lunar orbit the rovers, like the rovers that you guys are building now. So the idea is that from the Gateway we can teleoperate the robotic system that can prepare the outpost development, and then for sure it's an additional laboratory. So we have a laboratory in orbit around our planet. It makes sense to build one in orbit around our satellite. How is coming together the Gateway? As for the space station, for the International Space Station, we plan to assemble together different modules. And I'm very proud to share with you this morning that our company, Thales Alenia Space, in Torino, we are welding the modules. So the design is already completed. We are really manufacturing the modules. So starting with the Halo, that is an American module, our company will provide the structure. The Halo will be the first seed, the first element of this infrastructure that will be visited. So for, at least at the beginning, it will not be, we won't have a permanent occupation of this base. Few years after, we will connect Halo with this international habitat for which we are prime contractor, and we will provide the Esprit module for which our company in France is a prime contractor, and Esprit will provide the communication, life support capability, and refueling capability. and this picture speaks by itself. This will be the view that the astronaut will enjoy approaching for docking the Gateway before entering the lander to land on the moon. It's not easy to plan for the surface infrastructure, but we are working in collaboration across the borders. We have been working for many years. You see in this picture the key building block. So we will need for sure a lunar lander to develop, to deliver the different elements to the lunar surface, and for sure we will need an ascent vehicle for people to be able to go back to the Gateway first and to Earth for sure. As I mentioned before, the different elements of the base will need to be protected against radiation and also for thermal control. And the logical idea is to use the local regolith to do so. We are currently working at the design and development of greenhouses to complement the diet of the astronauts. A few years ago, we sent to Antarctic an experiment of a small greenhouse that worked beautifully. We will need a robust telecommunication and navigation architectural link around the moon, both to provide the link between ourselves, ground support on Earth, but also among the different elements moving on the lunar surface. Talking about the moving elements, so rovers, in addition to the unpressurized rover, we are designing also pressurized rover that will allow the crew members to explore without the need to wear a spacesuit. Well, I need to go quickly, but I cannot avoid saying that yes, we master the capability to design a pressurized module for the International Space Station, but to design modules for deep space is different. We will need to provide a better radiation protection, small autonomous capability. So we are currently working at these new modules that we will start validating with the Gateway, but that will soon become the modules planned for the spacecraft to Mars. And just let me close by saying that we didn't start only yesterday, but many years ago we presented the first concept for a moon base. You see, beginning of 2000, and our concept is still there in the Museum of Science and Industry of Chicago. So we do believe and hope that in the near future this type of capability will be finally exported to the surface of our satellite. Thanks for your attention, and I'm there with you to share, to comments, to get any curiosity, any question you might have. Thanks a lot.
Jutta, for sharing your thoughts with us. Your thoughts about lunar exploration. And it was a great introduction to the debate that we are starting right now, the debate entitled Moon from Survival to Living. And let me welcome on the stage our fantastic experts, Dr. Gianfranco Vissenin from European Space Agency and Per Aspera, Professor Grzegorz Wrochna, the president of the Polish Space Agency, Dr. Ruth Sorek-Abramowicz from My Society Israel and Ben-Gurion University, Igor Kolek from Neurospace, Javier Rodriguez-Gonzalez from CDTI and Peraspera. And we will have also two experts, two guests online. Maria Antonietta Perino, who already joined us for a talk, and also Carlos Espeil from iSpace. Okay, so we won't have guests online. So, okay, just Maria. Thank you. Thank you. So, Maria, can you hear us?
I can hear you. Can you hear me?
Yeah, we can hear you. Good.
Very good.
Is it morning? Morning, still morning. Pleasure to have a very, really very fantastic experts today during our debate about the moon. So yesterday we talked a bit about Mars. Today we are a bit closer. We're gonna talk about moon exploration, and from survival to living. That's our title of our debate. It's since we have quite a lot of us here, it would be very good if you could shortly introduce yourself, since maybe not everyone knows you, and also say a bit more about your connection to moon and to space. How are you connected, and what you can contribute also to the debate. So maybe we can start with Ruth, right? Yes.
Hello, can you hear me, everybody? Yeah, cool, okay. So nice, I'm very happy to be here today. I'm a bit excited. So my connection to the moon, I'm an astrobiologist. I look for life in extreme environments. At the moment, I'm working at the Arava and Dead Sea Science Center under the auspices of the Ben-Gurion University, and we're looking into extremophiles. And I would say my connection to the moon is looking for life. In an extreme environment, of course, you have to test your methodologies very well in order to make sure that you are finding life, and it's not just an artifact of your methodologies. My connection to the moon is also because we all have evolved on planet Earth, which has a massive moon, and the moon affects us biologically, just as the sun. So I'm very excited that we go to the moon, hopefully in this decade. Yeah, thank you.
Thank you.
Me? Okay. I'm Javier Rodriguez from CDTI. CDTI is like kind of the Spanish space agency. I don't know if there is a little bit of echo or it's okay. And how I begin to be related with the moon, I will say that my first job was already with Gianfranco Vicenti, that everybody know, in the space agency, and I was working in the lunar rover mockup in the LRM. And since then, I have been in contact with the space and the moon. And now I'm working in Peraspera, that is a project of the European Commission that is dealing with one part is in orbit servicing, but other part is related to exploration. And there we have a few projects, one that is more related with how to build a moon base, from the preparation to the building to also the manufacturing of the bricks that you are going to use, and also for exploring the lunar lava tubes that could be some important part from the scientific point of view, and also probably some kind of habitat that we can use there. Mm-hmm.
Okay, I try.
Yeah, it works.
So my name is Gianfranco Vicenti. I've been working in the European Space Agency for the last 31 years, and from the very beginning I started to work on the subject of robotics for the moon. Why is that? It's because it's the only way that one can make exploration sustainable is by massive use of robots. So with robots you will be able to explore, but also exploit the resources, because it's clear we won't be able to transfer our technology to the moon as we do nowadays on ground, where there is a massive network of transportation. When you go to the moon, you will be bringing few tools, a few materials, and then you will have to leave from the ground, from what it offers the environment of the moon. And to do this, somehow you have bootstrapped the process. you start with very little, and with that little you build more, and you enhance until finally it's ready to go there. So that's the role of robots. That's why we've been working on robots, rovers, everything for the moon for quite a long time.
My name is Grzegorz Wrochna. I'm the president of Polish Space Agency, and my connection to the moon started more than 50 years ago. When I was 7 years old, I watched very carefully Apollo 11 landing, Apollo 13 story, and then with the first telescope, the moon was very attractive object. I mean, to see all the craters there, all the surfaces, all the mountains. This was really very attractive. But now, as the president of Polish Space Agency, I had the pleasure to sign the Artemis Accords in presence of NASA Deputy Administrator Pam Melroy, and in this way we have opened the door for Poland to join the Artemis program, the Moon to Mars program, as it is called now. And Polish Space Agency is also working on our national mission to the moon. We think of a small robot equipped with some robotic arm to take samples, apparatus to study the samples. So we have asked our space sector to contribute with some ideas, and we've got more than 25 proposals of different solutions, different ideas, how to go to the moon and what to do there. So my connection is very long and in fact very intense.
Hello everyone, I'm Igor Kolek from Berlin, and I am an engineer for electronics and also for software, and I was working several years at a company called German Orbital Systems that is based in Berlin. There I was developing a system that is in charge for deploying masses of CubeSats into the low Earth orbit, and the system was always successfully used on the Soyuz rockets. Nowadays not anymore, but now it's used in the Falcon 9 to deploy CubeSats. And now I'm working as a project leader and chief engineer at Neurospace, also a Berlin-based space company. And there we're developing the new miniaturized rover that I hope will change a little bit the space industry and will lead to new space coming and arriving to moon. Thank you.
Thank you. And to Maria Antonietta, we already heard your presentation. Would you like to add something or introduce your connection to the moon?
My connection to the moon is very similar to one of the last ones. As the director, the head of the Polish Space Agency, I had the same memory. I was watching the black and white television with the first landing on the moon, and I remember that I saw these people jumping. And I thought, wow, must be beautiful there because they seem to be very happy. And I want to do the same. And so that has been my little girl dream. And I was lucky enough that turned into be my daily professional activity. And Gianfranco is taking care of the robotic systems that for sure are needed to open the path. And on our end, we try to do our best, Gianfranco, to complement the robotic system with elements where people can live. Because I truly believe that exploration will be performed by people supported, heavily supported by robotic means.
Thank you. So, since all of you, since our speakers, our members of our debate really represent a very broad, very wide range of competencies and what you do with the things related to space exploration, especially related to the moon exploration. So from your perspective, from your job perspective, let's say, if we take into account these three aspects, getting to the moon, surviving on the moon, and living on the moon, what is the biggest challenge from, like a very, on the one side, general question, but on the other side, I guess every of you can pick one or two things that are the most challenging. Please? Yeah.
So first and foremost, surviving on the moon for humans, not for robotics. Robotics, we're okay, I think, there. But for humans, it's a really, really tough issue. If you want to have scientific work as well, and you need the lab, and you need the equipment, and you need to do what you're doing, then it's kind of tough.
We need to work and research really well how is the better use to transfer of this, because we cannot rely on Earth. We need to try to produce as maximum possible there in the moon if we want to have this permanent presence in the moon.
I'm an engineer, so my my looking at the issue of the moon is simply very first survival, and the main problem of surviving there is thermal. Actually, all space is about thermal. The main problem that somebody solves in space is thermal survival. You see the cartoons, these movies with spacecraft going here and there. The reality, guys, is that if you have a satellite in orbit, the satellite can only survive if it is permanently oriented in a certain position which is thermally stable. You rotate the satellite 90 degrees, it will die. So this is the reality of space, extreme temperature. The moon, like Maria Antonietta, it's a pity that you are not here like the other times. But it would be interesting if you put back the slide about the environment of Mars, and and the environment. Yes. And guys, you have to realize that we have there, look at the temperature, from 80K to 370. So we're going to extreme cold, which is already difficult to handle, to extreme hot. You have seen missions to the moon, the Americans with Apollo, the Russians with Lunokhod. Well, those guys were in the mild time of the day. So when you land on the moon, you have a day of 15 days, Earth days, and they were in the first maybe 7 days, where temperature are mild. Mid of the day, temperature on the equator is 120 degrees. We're talking about 120 degrees. So you can cook pasta. I'm Italian. So it means, you know, and it would be very, very well cooked, well, 120. That's
crucial for survival, right? So pasta.
Maybe that's a good thing. On the other hand, at night, it drops at 180 below. So you have two extreme temperatures, and the equation for an engineer to make something that can work in very hot and very cold is a very, very difficult element. So this is really the main challenge, how to cope with these extreme temperatures. And I would like to point out also what is the temperature of 1 meter depth. It's almost constant. So if you look at it, the future for survival is being moles. So dig down in the earth and try to protect yourself from the worst of the thermal environment. So
this is why I mentioned before that covering the base with regolith, it provides radiation protection, but also thermal control.
It's the main challenge which we will have to work. So already establishing systems that will last multiple lunar days will be a difficult course of development, and will also be not about the technology itself, but also the strategy. So being able to establish very quickly some sort of shelter, because it's the only recipe that will allow you to survive. And this brings actually the continuity element, because survivability will be also living. The only way to survive is also to create immediately a shelter.
We are working on that.
Okay. Well, indeed, surviving on a moon is very difficult, but it's possible. And I believe that sooner or later we will have permanent stations there, like we have on Earth poles, for example. The temperature is also a challenge there, but of course, the challenge of the temperature on the moon, yeah, is order of magnitude more difficult. And remember, we still have International Space Station, also with permanent presence in space already. So it is possible, and going there is a piece of cake compared to that. But living there, I mean, running families, growing children, it's a different story. I think it is just impractical. And this is like in the case of the planet Earth. I mean, we have stations at the pole. We go there. We go there to make some science, but nobody is willing to run the family there, right? The same with the ocean. Again, we go there. We even have some hotels underwater. Okay. But nobody is going to live there because it's too expensive, it's inconvenient, and there is simply no point to live there. So, surviving, yes. Going there, no problem. Living there, unpractical.
So
I disagree. No, I mean I won't be the person. Too old to go there, but I know many people that would buy a ticket for the moon, for Mars, to stay there. There are people that are going to be explorers, and there are people that live close to the poles. I think that the human being has a huge flexibility to adapt to the environment. So it's a challenge for sure, but some of us would be brave enough and crazy enough, maybe, to do that. My opinion.
Okay. So also as an engineer, my biggest challenge that I'm currently facing is the regolith itself. Of course, it's a huge benefit to have it and to use it, to exploit it, but it's also very aggressive and a threat to our systems. It's so sharp and it's so dangerous to the systems that especially the wheels that we are having to create for that are under so much stress that that we have to put a lot of effort into finding the right system for that. It can destroy our PCBs, our electronics. It was even a danger to the Apollo astronauts. It's so small that it goes into every hole, into every gap. Yeah, it's really a challenge to design systems for such an environment with such a soil, such a dust. Yeah, so this is for sure my biggest problem that I'm seeing now. And of course, the temperature is also a big problem, but I think the regolith has to be mentioned as well.
So actually staying with that topic, since we are here part of European Rover Challenge competition, talking about rovers, so I understand the main difference between moon rovers and Mars rovers is the regoliths and what shall we add to that? So is the construction of the rovers more or less the same, or we should really be careful with some things?
So the regolith on the Mars is a little bit different than to the moon one because of the gravity and the environment there. but also the rovers on the Mars had to face the problems of the regolith, and they were the Perseverance rover has learned from the failures of Curiosity, and they have changed the wheels to adjust them to the environment, to the ground there. So both both environments have to be considered when a rover is built for that environment.
Well, so actually, can we use, or how many of the resources that are on site on the moon of surface on the moon, can be used to set up, well, let's say, kind of shelter or even a small colony there? Do we really have to bring everything with us, or is there some stuff that we could use there? And well, at some point we'll have to, right? But as a first step, how much can we actually well, rely on ourselves, let's say, in that sense?
The lunar regolith is in very fine dust on the top layer. Of course, it has more components, and it tends to increase with depth in terms of sizes. It's all about dust. So what can you do with dust? There are processes in which you can try to extract some components, but they also require technology. I have written a little paper in the part about how do we start with the moon. And I think in a way in the moon we will have to go for a new Stone Age. Essentially, what can you do with an environment which is only made of dust and stone? Well, it's exactly the problem our ancestors had. There was no technology to do anything, so they started up piling dust and piling stones to build shelters. This is really what we will be doing at the beginning, because the technology that you can bring from Earth will be limited by the cost of transportation. There is a limit of how much you can land each time, and it's extremely expensive to fly stuff in space, and even more to fly to the moon. So I trusted at the very beginning. You will see what happened with the early explorations. You see these caravels moving across the ocean. What did they bring? Obviously, they didn't bring a lot of stuff. They brought a lot of tools to be able to use the materials that were there, that were expected to be there, in order to build stuff. And so created this bootstrapping process. Because as I said, the environment is so tough that you can't take the idea that you will build a shelter at a later stage. If you do that, you won't survive even a couple of nights on the surface. You really need to start your sheltering process already at the very beginning.
I totally agree with Gianfranco, if I may say. For sure, we will make a big use of the regolith to produce bricks. We have the 3D printing capability. So my suggestion would be we use the regolith as it is at the very beginning. And then if we have enough power, and I'm afraid that the photovoltaic system won't be enough, precisely for what you said before, we have a huge variation. We have a continuity of 14 days of light followed by 14 days of night. So how can you deal with just solar cells? You need too many batteries. So we will need a nuclear plant, a small nuclear plant. And once we have that, then we will have enough power to play with the regolith, to work with the anorthite, with the almenite, that are these two important families of oxides that are in the regolith, and we will extract what needed.
I think, Maria Antonietta, I think we need to even reconsider in a way this idea of a 3D printing from dust, because in the end you still need energy. Energy means solar arrays, which means extra mass. I am really thinking that, why do you need to take dust to make bricks, which are like stones, when in reality you can use stones? So, but even I mean, in Italy we have, or even in the south of Europe, we have structures that are built out of dry stone, which have been there for the last 4,000 years. So you can do very durable structure just by dry stone. And I'm sure, in Israel as well, there are very, very many of those structures.
4,000, 6,000, 12,000. Yes, I'm very familiar.
So you can actually build. That's what I was meaning. We need to have a new Stone Age in the moon, because that's where you start again.
Yes, and I also believe, and please correct me if I'm wrong, that you can use the regolith with like a high beam at high temperature, and it becomes sort of like really opaque, and it becomes a bit of a glass. So you can make that one as well, and make perhaps like sort of like not concrete, but sort of like really flat areas. If you need the rovers to go on, if you need things to like roads and stuff like that, you can basically melt it and make it plaque. Is that correct?
But you need energy. I mean, it's
of course.
It's a bit. Look.
We will
you have
have
a microwave
solar.
at home,
We'll put lens, and we'll just burn it.
It doesn't work that way. I mean, you need really. It's a bit like some of the concepts are using microwaves, but.
Right.
You have a microwave oven at home, huh?
Yeah, 800 watts.
But you put your cup of coffee and you get it warm. Now the problem is actually you want to melt the cup. So just imagine how much more energy you need.
For sure. But we do have the sunlight and we have the temperatures already. So we might be able to pitch it a bit to the right direction without putting a lot of energy in.
Yes.
Just an idea, yeah.
It's a totally valid idea, but what I want to say is that if we start with these grandiose ideas, it might be that we will take a long more to do this type of exploration, because it will require a lot of infrastructure to start. And instead, I think we need to start simpler. We need to start with a smaller picture, day by day, constructing things. And in mathematics, the process is called the bootstrapping. You start with an assumption and you build on it, and you enlarge your project.
Do you think? Sorry.
The lava tubes is an interesting option. It was mentioned by the Spanish colleague.
Yeah, we're working on that, but you need to go there.
How do you feel about Starship? Like, do you think Starship would be? First of all, it will lower the cost of bringing stuff to the moon, right? And then some aspects of it suggest that part of the Starship would be the first initial building on the moon. Do you think that's possible? That's okay? That looks sensible to you?
I think that is for you, Gianfranco.
I don't know how much economical the thing can be done. I think the costs of getting to the moon are always very high. And one has to ponder what is worth doing. I mean, there is a limit of the resources you can put on this type of endeavor. As humanity, we have a lot bigger problems coming up, which will require quite a lot of effort. So I think affordability in space exploration is important.
So we've mentioned that going to the moon, in comparison to surviving on the moon surface, it's a piece of cake, right? Is landing on the moon something that is a piece of cake as well? Maybe it's two pieces of cake. So landing on the moon and also sending something back from the moon to either the orbiter or to the Earth. Is that a challenge? Open question. If anyone wants to answer, I would be very happy.
Well, I think landing on the moon, it's a different type of cake. It's a very hard type of cake. You know, those ones made with almonds, a lot of sugar, very tough to bite. It's difficult because essentially it's actually even much more difficult than landing on Mars, because Mars, even if has very thin atmosphere, still has an atmosphere, so you can use aerodynamic drag to decelerate your spacecraft. The moon doesn't have that, so you have to use a lot of fuel to slow down the speed you have by orbiting or even coming into the moon from interspace, and decelerate it to a speed in which will not be, destroying your spacecraft. So there is a lot of energy required to do that, and this is the main problem of the moon. Getting there is a bit more difficult than sending a spacecraft in orbit, but you can get there. Landing is this very tough piece of cake.
And this is proven by history. I mean, if you remember the first attempts of NASA to land on the moon with the Ranger spacecrafts, I think only the seventh one finally landed successfully. And even today, they don't know the reason why the seventh was successful and the sixth one was not. The only difference they identify is that the chief of the mission was eating some peanuts during the mission start. Okay.
Maybe that's the thing. So let's assume, okay, we overcome all those challenges, which is obviously pretty tough and not easy, and we have to deal with setting a lunar base or a small colony there. And we have to deal with these things like we produced waste, right? And we have to somehow either at some point get rid of them or trying to making this zero waste lifestyle, lunar lifestyle. So it doesn't sound like a first challenge that comes to your mind when you think about going and surviving there, but it may be a problem. So could you either comment on that? How can we deal with this kind of problems, or maybe add another types of problem that we maybe don't think about, but some of you already did, and which may somehow affect our living there? So, would anyone want to comment? So.
It's true that if we have like something permanent in the moon, the wastes are going to be a problem. Now, we don't do anything with the waste that we have in the International Space Station. We pack it in a capsule and we send to destroy in the atmosphere. We cannot do that in the moon. And of course, we cannot have all the waste around. So we need to think a little bit how we will handle all of this. But I can say, for example, that for other type of waste, there is already project. For example, in ESA, we have the MELISA project, that is coordinated by ESA and I think that 50 more entities, that they are already dealing with how to reuse all this waste to produce food, to regenerate the atmosphere with oxygen, to produce water. So there are already some projects that are dealing with this, already planning of how we are going, when we will go to the moon or to Mars, how to deal with all these things. It's true that still is preliminary, is all these things that for regenerating the atmosphere, producing food are like in a separate stage, but now they are trying to merge and close all the cycle with all the thing that can be done to have at least the maximum efficiency for all this waste.
Well, in fact, already on the Earth, we learned that what we called yesterday garbage today could be a very valuable resource. And well, this discussion is in the framework of European Rover Challenge, and one of the competitions was to build a rover out of garbage. I don't know if you have seen those rovers. 7 rovers have been presented. I mean, it is really garbage, but they work. I mean, they were able to move, to do some tasks on the Mars yard. I mean, it is really wonderful. So the garbage is a valuable resource for the future.
Two items on this really interesting topic is one, it's probably what ESA is doing today when they ask that if you're sending a satellite to space, you need to say when you're going to deorbit it. They have so from the beginning you say we don't want to have waste. If you are producing waste, what are you going to do with it? Show us our plan, what's happening after 5, 10 years, and so on and so forth. So putting a plan before what you're going to do with the waste and then authorizing that plan, that's a good idea. And the second thing is that one of my research projects is actually about reusing fuel tanks. So basically, I'm looking now at doing a bioreactor, which is a combination of an algae and an extremophile bacteria from the Dead Sea area, and they know how to eat, for instance, hydrazine, apparently. So when you come and you use, and hydrazine is only one of the fuels used in space, you know, and so on and so forth. There's other types of fuels going on. But it's very interesting to see that you can take those fuels, you can use the tanks perhaps, and then you can reuse the tanks. You can use these type of, you know, biological way of dealing with fuels, and afterwards, if you have algae, if you have good stuff, you can make them produce for you nutrients, you can make them produce for you oxygen. So that's one thing I'm working on for basically reusing and taking care of waste. Hello. There you are. We can see you now. Hello.
That is only because my son came and I just wanted to say how it is.
Okay, so well, we have a nice human reaction here, and just like obviously we cannot say nothing about the human factor of being on the moon from actually three sides. So we have physiology and physiognomy and also psychology. But also we have to deal with the human robotics somehow connections. So these are things that we partially work on the stations like polar stations, but also in this analog missions. And any highlights that you would like to share with us on that aspect? We obviously are aware of the biological, all the challenges that we already mentioned, also during yesterday's debate about Mars. But what about the moon? And maybe some of you has some special thoughts to share with us on that aspect, the human aspect.
Well, we just had an illustration that what could be difficult for our generation could be very easy for the next generation, right? For our children. So I believe the same with robotics. I mean, we observe that with, you know, computers, mobile phones, and so on. I mean, for older generation, I mean, it's sometimes difficult. We have to learn, we have to get accustomed. Whereas the new generation, I mean, they learn to operate the mobile phone at the same time that they start learning walking and talking. Okay, so for them it's so natural. I believe the same will be with using robotics. I mean, for us, robot is a kind of tool. We are very careful. We need to somehow learn how to work together. For the next generation, it would be very natural.
The aspect of human-robot interaction is actually one of the main reasons why moon rovers will be rather different than Mars rovers. And this even without having humans on the surface. You see, a lot of the reasons are related to the distance of the moon from the Earth and the distance of Mars from the Earth. So the only way we can operate rovers on Mars is by essentially embedding some form of intelligence and hoping they will do something on their end, because you cannot telecommand them, you cannot teleoperate them on real time. So which means that Martian rovers are relatively slow because they need time to reason around the environment, interpret it, navigate, do things there at a slow pace. On the moon, we have the opportunity, the possibility to teleoperate rovers from ground. In the end, the round trip delay is about a couple of seconds. So you can actually have a man in the loop driving a rover, and you can't have a slow rover with somebody who's driving. It's a bit like you driving a car that only goes 5 kilometers an hour. Just think of it. Already, staying in the limits of 50 kilometers per hour on your car is difficult. Think of moving 5 kilometers an hour. It would be extremely consuming in terms of energy. So the rovers we're thinking about for the moon will be much faster, will allow to explore larger swath of terrains. And by going faster also, they need to have a completely different suspension system. And so these are the type of complexities that will be there already in the fact that you need to build in the ability of the rover to be compatible with humans in a different level. And that's without talking of what will happen when humans and robots will be in the same environment. So they'll need to talk together. It's another chapter, deserves maybe an entire conference.
But we could already witness this at the Mars Yard here, because there was an artificial delay introduced for the teams operating the rovers to make it more realistic. So sometimes the competition looks like a chess match, you know. So the robot moves, nothing happened. After some time, another small move, and nothing happened, just like that.
Go as you prefer.
I think that when it comes to the point that we have human beings again on the moon, then it is necessary to reduce the amount of EVAs as much as possible, and for that reason it is, in my opinion, necessary to set up a huge robotic environment on the moon that is that the astronauts then can remotely control to reduce the EVAs for themselves. Because every step on the lunar surface, when they are hiding themselves from the radiations, and is one too much. And to reduce that, I think it's important that there will be the possibility to have some robotics to do the test that astronauts could also do, but yeah, as a support.
Yeah, this is why I'm showing right now the pressurized rover. I agree with you. We will need the robotic system to sustain exploration performed by people.
I will change a little bit the topic, because at the beginning you was speaking in the question the effect that we can have in the biological, in the psychological, and was, okay, we can say quite funny, because the debate that we have later, that is arts and living in space, I was speaking with my brother that is psychologist, and I understand when I was speaking about harsh environment in the moon, I was speaking about radiation, temperature, but for him was only psychological. Is the human is a social being, so we are going to be in isolation. That's produced like insomnia, depression, lack of. We lose part of the reasoning capabilities, so are going to be really hard. Now, the most similar thing that we have is the International Space Station, but there we are able to communicate really well. We can have teleconferences similar like we have Maria Antonietta now here. So in some way, we are not losing the contact with the society. And also, we are able to see the Earth. That is really important. From the moon, we are going to have something similar. But we need to try to investigate a little bit more what could be the long-term effect in the psychology of the astronaut. But when we arrive to Mars, we are not going to be able to have like this communication that we have that make us close to other human beings. And also we are not going to be able to see the Earth. So we are going to be totally disconnected, and we don't know anything about the psychological effect that we can have. And it's really difficult to model that. So we need to really begin to think what could happen when we arrive to Mars, that luckily are not going to be that far in time.
So, well, obviously we cannot not mention Artemis, and we all, I believe, keeping fingers crossed for the project. But my last question, and partially was already answered by you, but when will we be walking on the moon, back walking on the moon? 2025, 26, or later?
I'm really happy about the Artemis Accord. They put a lot of emphasis of diversity into the program, not only for the composition of the group of the astronauts that's going to be on the moon, but the entire process and the management process and the logistical process. So they're really putting their foot down regarding the value of showcasing diversity of the human species in this process in getting back to the moon, and it's very important to me personally. I would really like to see 2026 happening with SpaceX happening, and not necessarily with SLS systems. But so I would go for 2026, and I'm an optimistic. So that's my side of the story. Please.
So I think everything will go according to the schedule, and in 2025 we will have the first astronauts on the moon. But I hope some years later we'll have also a Polish astronaut there.
Yeah. Any more guesses?
No,
predictions.
2048. No. No. It's true that the thing is that now we say 25. I also believe that if we are lucky, it will be 26. But one thing that we have been waiting a lot to return to the moon. So we don't need to hurry. We need to be prepared to arrive in the best condition. We cannot fail this time. So
better later
we need to be passing. Is this 25 perfect? Is this 26 perfect? And is this 27? It's okay. But we need to be sure that all are going to be right and are not going to be any problem. So
I'm agreeing with that. I think we don't have to rush things, and if it's not happening 25, 26, we will still experience a lot of very impressive steps to the moon, and there will be a lot of missions that will go there and set up everything that is necessary for our astronauts.
So actually we could ask the organizers for organizing this kind of debate in 2000, let's say 25, 6 or 7, and see what are our answers to those questions after the landing on the moon again. So thank you, Maria Antonietta, for joining us online. Thank you all of the distinguished guests that we have here. So it was a great pleasure to talk to you, and I'm really sorry that we cannot make it longer, but we are running out of time. So thanks a lot. Thank you.
Here you're close to modern resorts where you can take care of your health. All around you can find professional care and restore your vital powers. You're one step away from active recreation, surrounded by beautiful nature. All that in one region. Come and see. Świętokrzyskie, close by.
Good afternoon, everyone, and welcome back to, well, not really the Mars Yard, because we went indoors for the weather, but in an intermezzo where we'll talk to a specialist and expert here on the scene of the very first moon landing. We have the replica suit of Neil Armstrong behind us. We're going to talk about the moon today, about moon exploration, building on what we heard in the panel with Milena in the main conference hall just now. So our first guest, we have Dr. Red Baumgar of Parametry.ai. Welcome, Red, to the show.
Hi,
you
thank you,
are a specialist in robotics, aren't you?
Yeah, you could say that. Let's try. I'm PhD in robotics, so I had my PhD in south of France in the lab called LAS. It's one of the biggest robotic lab in France, and I had the chance to do learn robotics. So with a heavy, I would say, which I would call a heavy buggy robot, 120 kilograms, and I see all the students here. It feels like so much fun, and it makes me revive this vibe, I had like when we were getting out.
So what is new in robotics? We talk a lot about robotic exploration on Mars and today on the moon. What is the latest and greatest in rover and robotics technology in relation to lunar exploration?
It's complicated. There are so many amazing projects, but all the projects that actually make it to outside, to space is very thin. But I remember super interesting lunar rovers from the Canadian Space Agency, which were grasshoppers. So they can roll, they can ride, but they also have those leg system that can jump because they wanted to take advantage of the low gravity on the moon, and that was great. On Mars, you cannot do the same thing. You have a bit more gravity, but still you can still play with those differences with the places.
Interesting. So today we learned a very valuable lesson that rovers do not deal with rain very well. But we also heard in the panel that rovers don't deal with lunar regolith. What is the story there?
Oh, yeah. So when I was doing my PhD, I met Rodney Brook, who was talking about, this is the former CEO of iRobots. He was talking about the dust in the desert. And dust is worse than rain, actually. So I remember we had the challenge, we were in Belgium, so it was raining. But we covered the robot. Rain is always possible. If you can't make it with rain, you can't make it anywhere. So
okay, well, that's a good statement. I might quote you on that later on social media. Right now, you are the founder and CEO of Parametry. Is that correct?
Yes, correct. So we are developing AI solutions to do health monitoring of spacecraft and hopefully in the future of rovers. We want to give the operators the explanation of what's happening on the rover, what's the health status of the rover, and explain that to them.
Okay, real quick, we only have a few minutes, but what is the role of artificial intelligence in spacecraft health monitoring and ultimately in rovers?
It has many roles. One is that you can never know what you're going to face when you're going to the moon or to Mars, so you need to have something that can learn. So learn different modes of navigation, adapt to the terrain. A crater is very complex. When you want to go around, you will find very different terrains around, and that's you have to learn. So machine learning and in those situations is very welcome.
Okay, very good. Where can people learn more about what you're doing in Parametry?
Parametry.ai, that's the website. I guess, we update that there. Find me on LinkedIn. I'm happy to talk always.
Excellent. Social media, always good. And for those of you online and you want to see what's happening in the online discussion, #ERC2021, you will find Red, you will find the Rover Challenge, and you will find many of the teams. So please follow on social media. Thank you very much, Red, for your explanation.
Go teams. Ciao.
Thank you. So now we would like to
Good to meet you.
Hello, good to meet you, and thank you for joining me here together with our friend Neil Armstrong.
Hey, hi Neil.
We just heard you in the panel. You are one of the robotics specialists in lunar and probably Martian exploration for the European Space Agency.
I would say I'm one of the old ones.
You have the history and you know what has been developed and what will be developed in the future. Now, the one question, because you have been in this business for so long, the ultimate question that we always ask, and we saw the debate on Twitter, is human versus robotics exploration. What is your position on that?
I think this is a question that will always be raised. I think it's a bit of a question that has a different answers. Depends where you want to play the focus. If the focus is in promoting exploration, nothing beats humans. You want to see humans in space because every person can be inspired by a human in space, because you can see yourself into the place of the astronaut. You cannot see yourself in the place of a robot. Another thing is about efficiency. Obviously, we can do a lot more things with robots that astronauts will take a lot more resources to do at the same level. The two elements have to live together. We cannot do without human space flight and human exploration, because it really brings the support for the subject that you wouldn't have otherwise. But we also need robots because they bring the affordability to exploration.
Yeah, that makes sense. Well, thank you very much. That's a very clear explanation.
Yes.
It often seems to be sort of a fight, and the real answer is we need both.
We need both. We need both. There is no point in fighting. There's no fight.
Exactly.
Everybody knows that this is it's a draw.
Exactly. Now, in contrast to what Neil and Buzz and their successors were doing on the moon, we're going back to the moon, but this time to stay much longer and for exploitation rather than just exploration. What will the steps be once Artemis 1 launches its first mission? What are the steps going to be to make the moon more livable for the astronauts that will follow?
Okay, the very first thing to understand is that the moon provides an environment which is extremely tough, but much tougher than anybody can think of. Because I was just mentioning now at the conference, the principal problem is thermal, for example. In the moon, you have, in the matter of 1 month, most extreme temperature. You go at the level of the equatorial sites, you can have as hot as 120 degrees and as cold as minus 180 degrees.
Wow.
Now, there is no environment on Earth in which you live very cold and very hot temperature at the same time. So this will be the first challenge. And the solution in the challenge is already found at the level of investigation of the moon surface. We know that, for example, 1 meter under the surface, the temperature is already very stable. So the future will be immediately, if you want to establish a long-term duration on the surface, it's not about living in the open, it's about digging, making holes where you can find a lasting environment to live in.
Okay, so that will be step one, is to prepare for the arrival of humans. Is that how I should see it?
Yeah, it's about building a shelter as soon as you can.
Okay, and then going into this exploitation phase, because we go to the moon for a reason. We go to the moon as a jumping board, if you like, to Mars, and we need to prepare resources. Now, we always think that we found water sources on the moon. How easy will it be to start extracting ore and materials and water?
Well, the reality is that we don't know that. In fact, some of the missions ESA is studying at the moment are really to grow into the knowledge of making things out of the lunar environment, of the things that we find on the moon. So we will have the so-called ISRO, so in situ resource utilization missions that are dealing with experiments on how to extract raw materials. We will see how this is done, how efficient it will be. The reality is that you have to do these things to learn how they are done.
Yeah, of course. Now, one last question, because we do have limited time, but a question that many people have in their minds is timing. When will we see the first humans on the moon? And as it is a jumping board, when might we see the first humans on Mars, in your opinion?
I can only tell you that I'm sure it will be after I go on pension. Okay. I'm sorry about that. About the future. Future is always uncertain. I mean, who would have said that we are running now in a deep economic crisis out of sudden events that were not expected by anybody. It's hard to say about the future, but it's good to keep the momentum. I think despite what is happening, the agencies are trying to get things done.
Exactly, exactly. Well, thank you very much for your time right now,
Most
and
welcome.
we'll move on to our next guest.
Okay.
And if you can hand the microphone, thank you. It should be on already, so if you could stand.
Over here.
Perfect. So, hi. Can you introduce yourself real quickly to our audience?
Yes, hello. My name is Michał Zachara and I'm COO of KP Labs, a company from Poland. And as a company, we are hiring about 80 people here in Poland on Silesian region in Gliwice. And we are responsible for some projects for ESA, for NASA, and for our own products, which are products for onboard data processing. So we are specializing in products that helps to the community and the people to move the data processing from the ground to the satellite or to the rover, after all.
Okay, yeah, I was just going to ask, what is the relation between KP Labs and lunar exploration and rover exploration?
Yeah, so our company is about 6 years old now, and when we started the journey with space, the idea for the company was to bring autonomy into the lunar exploration and to the low Earth orbit. However, after a couple of years, we found out that it's not so easy to do something in deep space. So we focus more on the LEO, on the small satellites.
Okay.
And right now we are delivering the computers for small satellites, medium class satellites, for ESA class 3 and 4 satellites. However, the things that we are doing for the satellites can be easily reproducible on the lunar surface. So, for example, when we are taking our computers for onboard data processing is because of the fact that we don't want to send all the data to the ground, to the Earth. And the same problem happens on the lunar surface, on the Martian surface, etc. So we believe that farther from the Earth we will be, the bigger concern would be with the data processing. And this is why we started this year, just 1 week ago, a project with ESA about the onboard data processing on the lunar surface. And for that reason, we are delivering some AI algorithms for object detection to process those algorithms on board of the rover.
Okay, so that's very similar to what we see here, what the teams are trying to do. Some of the teams build high levels of autonomy into their rovers. Is that similar to what you do? You mentioned object detection.
Yes, this is something similar, but we at the end would like to focus on hyperspectral data analysis on lunar surface, because this is something that we are doing here on Earth, because we are creating the satellite called Intuition 1, that is a hyperspectral satellite. And we are going to move the technology that we created for the satellite to the rover itself, because the problem is quite similar. We'd like to analyze the minerals and analyze the surface of the moon. So we will use our convolutional networks to analyze the dust on the moon.
Okay.
With hyperspectral data.
Okay. Now, this is getting a little bit technical, but in simple layman's terms, could you explain a little bit what hyperspectral monitoring means? I know it's used in Earth observation, it's used for mineral detection, but what exactly is it?
So basically, when you are looking at any object with your eye, you are just looking at the visible range of the light. And what we are doing, we are analyzing the whole spectrum. Well, not the whole, visible light and near infrared, so we can detect more value from the thing that we are observing. So when the light is being absorbed by any object, we are receiving some information from the object. So what is the absorption level? And by that knowledge, we can finally understand at what we are looking at the end. So we can easily detect if the object that we are trying to analyze is a rock, and what is the consistency of the rock, what kind of minerals are there. So with the hyperspectral data, we can, just slice the light into the very small pieces and analyze each piece to get very detailed information about the object itself.
Okay. That's very cool, and and that has applications in many different areas. As I said, Earth observation is probably the biggest one. Let me ask you a little bit about that. You are a commercial company.
Yes.
Where is the market for you? I mean, we talk about lunar exploration, but at the moment there is no lunar exploration. How do you make your money? Where's the money in space?
So basically, right now the money in the company is mostly from selling the computers for onboard data processing.
Okay.
And when we were setting up the company back in 2016, I believe we were the first company in the world who were into the moving AI to the onboard data computers.
Okay.
Because it was such a crazy idea that everyone told us that it's just impossible or it's stupid. And right now we are seeing that more and more companies would like to process some of the data on board of the satellite, just to avoid sending all the information. So, for example, for the next year, we've got 70 computers in a selling pipeline to be delivered to different companies from US, from Europe, from different agencies. So this is the most income of the company. But also we are doing some projects for ESA and for NASA. So this is the second branch of the economy.
Okay, excellent. Well, it's really good to hear because you're 6 years old, your company, and you're making good money already. And we know space is of long timelines. So
Exactly.
this is really good to hear that there are opportunities out there for any aspiring entrepreneurs in AI, in software development, and you're a good example of that. So thank you very much for your time,
Thank you so
Mikhail.
much.
And we'll move over to our next guest. So, Christoph.
Yeah, it's me.
Yes. Well, welcome to our little intermezzo from the alternative Mars yard right now. You have
almost behind us.
Exactly. You have multiple roles. I mean, tell us a little bit about well, the uniform that you're wearing today.
Okay. Today I have a hat of the member of the jury. Together with my team from Poznan University of Technology, we are preparing the remote maintenance whole competition part on this side, and we also do the judging for that. And we do this, it's like third year in a row, so we improving the system as well for the teams each year. I think the teams are happy with how everything is going right now, and it's like fun for them to be connected from around the world and try to how they can remotely do the things. And I think it's even closer to what we want to do, the analog mission, because you have all those communication issues. So it's closer that you, for example, are doing something at the space station because you are like, for example, 10,000 kilometers away because, for example, we are from South America or something like that.
Yeah, exactly. Now, in addition to being a member of the jury, you're also a researcher in AI and robotics at the University of Poznan.
That's true.
So can you tell us a little bit about the role of AI in lunar exploration, and especially the robotics part of that?
Okay, so together with my colleague Michał, who was previously here, we are now working on things related to autonomy of moon rovers. I think it's a crucial role because there are some problems with teleoperation of the robots. You have communication issues, there are delays. For Moon it's not that crucial, but for Mars it's way more difficult to have direct connection with the rover, and all the latencies. So if the rover might do autonomous ride, it's very preferable because then you can make a lot of more science and traversing of the moon.
Okay, that's on Mars, you said initially, also on the moon, of course. What is the difference? Is it just a latency issue that's the biggest difference between lunar and Martian rovers?
So it's one of the differences. And also, there's if we stay still with the communication side, the problem is that with the moon you have more or less direct communication. And with Mars you need some relays. You have, for example, you need a satellite around, something like a satellite around Mars, so you can relay the communication. And of course there's like way longer waiting time. But for example, the crucial part and the crucial difference between lunar and Mars rovers, I mean, in terms of robotics, is the lunar day and night. So it's way different than to Mars. Mars is closer, I mean, the day and night is closer to Earth. Okay. It's almost like 24 hours and I think half an hour. So it's quite close to Earth. And on the moon, you have 14 days to do your mission. So there are companies which are doing like that. So you just send a really cheap, let's say cheap, in terms of space, it's cheap, cheap rover, which just lasts 14 days, and you just say, okay, it's gonna froze, and that's it. But if you want it to work longer, there's an issue to have enough energy, enough power to make the to survive those 14 days of total darkness and total freezing.
I see. Okay, that's really interesting. Now going back to the autonomy element of it, that is an important part here in the competition as well. Whether rovers are operated autonomously or through some kind of manual remote control. Can you tell us a little bit about that?
Yeah, that's true. So of course we are promoting autonomy. So we give way more points for doing things autonomously. And I need to say that the teams are improving every year. You can see
I was just going to ask that. How is that changing year over year?
I think they are switching from, because the rovers are more mature, so they can focus on software more. Because previously they were like focused on building stuff. So it is also fun because you do some kind of hardware stuff.
Of course.
And you see the effects like immediately. That the robot is growing, you have wheels which are turning, you have an arm which is moving and everything like that. But then you didn't have time to write the software because software is like the last one which could be tested because you don't have Rover. But I think the teams now have like Rover, which was last year here. So then now so through this year, of course they do some improvements in hardware, but they are spending more time on software. And of course, if you want to do autonomy, you have to have reliable hardware. So this is the crucial issue to do the good autonomy.
Yeah, exactly. Okay. I'm looking if our next guest is already here, but in the meantime, I will.
I think we have.
I will ask you. I will ask you the next question. So this is again about the regolith on the moon. We heard in the panel that regolith is an issue. Is that simulated here on the yard as well?
On the yard we have Mars, and also there's a difference between, because we have vacuum on the moon, and then we have some thin atmosphere on the Mars. So let's say when we are on the moon, it's more aggressive. So the grains are coarser. So they are causing a lot of more harm to the rovers, and also the problems with the power. So there's no winds which can, for example, blow away the dust from your solar panels, for example.
Okay. Well, thank you very much. I think our next guest has arrived. So thank you very much, Christoph,
for your
it was
a pleasure.
Explanation. And we'll hand it over to Professor Rochna. If you could stand there, thank you. So welcome very much, Professor Rochna of the Polish Space Agency Polsa. We saw you in the panel. The topic for the day is lunar exploration, and we're standing here in front of one of the pioneers. I saw, and you mentioned it in your speech, that Polsa signed the Artemis Agreement. It's one of the signatories of the Artemis Agreements, the Artemis Accords with NASA. Can you tell us a little bit about that?
Indeed, I had a pleasure to sign the Artemis Accords declaration in presence of Pamela Roy, Deputy Administrator of NASA. And this was an opening of the door to Artemis program, to Moon to Mars program. We are discussing now with NASA our possible participation. Already on Artemis 1, there are some Polish items. There are some radiation detectors produced by Institute of Nuclear Physics, Polish Academy of Sciences from Krakow. There are some infrared sensors to monitor the atmosphere in the Orion module. From Vigo company, but this is only the start. I mean, we really believe that we can provide important instruments, components, and we are about to talk to NASA about our participation. And of course, I hope that in some future, we will also have Polish astronauts on the moon.
Okay, well, you mentioned it now live for everyone to see.
Absolutely.
So that's a great ambition to have. But looking at the subsequent missions to the moon and later to Mars, what is the position that you think, the specialization, if you like, that the Polish industry can really contribute to that evolution?
Well, in fact, Polish companies, many of them, they emerge from scientific institutes, universities. So they start from building scientific instrument, some measuring apparatus and so on. But then they develop the capabilities in robotics, automatics, and now adding on top of that artificial intelligence, it gives an added value which is valuable even for US. I mean, we visited JPL, Jet Propulsion Laboratory, responsible for organizing exploratory NASA missions, and they told us that they really desperately need artificial intelligence experts, and we have really great experts in Poland. So this is emerging specialization of us. So instruments, robotics, automatics, artificial intelligence, but also other things like electronics, like composite structures and so on. The possibilities are very, very wide, and I hope we will discuss with NASA and we will get a lot of our stuff on the moon.
Excellent. Well, that's really good to hear. That's a good perspective for students, like the students that we're seeing here at the ERC. So you are here, you are present with different booths here at the European Rover Challenge. What is the relevance of the European Rover Challenge for the future workforce, if you like, here in Poland, but possibly also beyond?
Well, when I ask Polish companies what is the barrier for your growth, I mean, they always say people. I mean, they need educated, well-prepared people, and there is no better education, no better preparation for this kind of a job, like, you know, experience by doing something with your hands-on experience. So building the robots, I mean, the people, they learn not only about the moon, the environment, or the Mars, the environment, about the technology, about you know, mechanics, IT, electronics, and so on. But they also learn how to work in a team, how to run the projects, how to set up milestones, how to organize a budget. I mean, those are capabilities which are very important, which are very much needed for the space sector. So I cannot imagine a better way of preparing people for our future projects than you know, competitions like this.
Okay, well, you all heard it. For the competition, this is not the last edition, of course. If you have ideas, then make sure you follow ERC 2023, 2024, and I really hope that the Polish Space Agency will stay involved. So I'm really looking forward to seeing you here many more times in the future.
Of course, we will be there. We hope to engage even more because this is our future indeed.
Exactly. Well, thank you very much, Professor Rochner, for being with us here.
Thank you.
Okay, so now we will talk again about this topic of the Moon versus Mars with our chief scientist here at ERC, Anna Wozniak. So thank you for joining me again.
No problem. Always a pleasure to talk to you.
So first of all, this weather. What's the issue?
Well, you know, it's maybe it's unplanned, but it's a very good opportunity to see how Mars looked like about 4 billion years ago. So right now, Mars is a very, very dry place. It's much drier than anything we can see on Earth, all because it lost its atmosphere and water is no longer stable on the surface of Mars. But we know for sure that many, many, many years ago, 4.5 billion of them, or 4 billion years ago, the Mars was much more wet and looked more or less as what we can see right now on our Mars yard. So
a lot of mud.
A lot of mud, a lot of water flowing through the landscape and eroding channels. Depositing the sediments within the low-lying areas, for example, impact craters. Right now, our delta is becoming more and more realistic, so that's also very nice. Not very good for driving there at the moment, but it will definitely look amazing in about 3 days when it all dries out.
I really like your positive attitude towards this horrible weather, but I didn't even think about it. This is brilliant. Now, moving that into the future, is this what terraforming would look like?
I don't think we'll be ever able to turn back the clock and make Mars wet again.
Okay.
This will not happen, at least not without crossing some kind of technological boundary that equals magic. Unfortunately, Mars is way too small to sustain its atmosphere, so the gases are just running away. So we would have to constantly add new air, new atoms of air to make it properly pressurized to do the thing. In the same way, no terraforming of the moon. That's even worse.
Well, yeah, I don't think anyone has plans for that yet.
There are some crazy suggestions.
Well, there are science fiction authors as well, but okay. Let's have a quick look at the theme of today versus what's going on here. The theme of today is lunar exploration. The Rover Challenge is all about Martian exploration. What is the key difference in your view?
Mars is much easier than the moon. The rovers for the moon are much more complex, especially from the point of view of mechanical design, because maybe it's easier from the software design. Mars is much further away than the moon from the Earth, which means that the signal that we send to the rover, for example, turn left, turn right, will travel for at least, up to 20 minutes in one way, which means that if we try to drive it just, like on the stick, our rover may be already in the ditch somewhere dead before we even know it. So we cannot do that. That's the largest challenge when driving on Mars. However, on the moon, the delay is only about a couple of seconds, so it's not a problem. However, the environment is much more harsh. There is a lot of change in temperature, very large variations depending on if it's the day or the night. The days or the length of time where the particular location on the moon gets sunlight is pretty long. It's about 14 days, which means that during this time it's nice and warm, and you can have enough energy produced from the solar sources. However, during the night, for 14 days, you need to survive in very cold environment without any additional source of energy. Additionally, there's a lot of dust that is extremely abrasive because it was formed by the billions of years of small asteroids or small even pieces of sun-sized pieces of extraterrestrial material smashing into the surface of the moon, which makes it as abrasive as the most abrasive sandpaper.
Yeah, we heard that. And there was also an issue in the spacesuits with the Apollo astronauts. Well, thank you, Anna, for your contribution. Again, we will see you again later. And thank you very much for taking us back 4 billion years. I had not thought about that when I saw the clouds coming in. That's an amazing story.
Only at the European Rover Challenge come.
Excellent.
Space machine.
Well, very well. We're going to switch over and go visit a few of the exhibitors and to show you what's going on in the Inspiration Zone right now. So we'll show you a few videos and we'll be back with you in a few minutes.
Here you're close to the most interesting tourist attractions. The land where Polish rulers and their families lived, and which 6,000 years ago was mined for precious flint. Today the mines are a UNESCO site. Wild nature is within your grasp, and active recreation routes stretch to the horizon. Nearby is a gem of Renaissance architecture. All that in one region. Come and see. Świętokrzyskie, close by.
We are Team Interplanetary, an undergraduate student team from Bangladesh University of Engineering and Technology, presenting the latest iteration of our rover, Renaissance, for European Rover Challenge 2022. Our team is divided into 4 sub-teams: mechanical, electronics, software, and science planning. Our team lead is Khondokar Shihabul Haq, who oversees and guides our team and is responsible for collaboration among all the sub-teams. Each sub-team leader is also shown here. Nafis is responsible for mechanical design and assembly of the rover. Samir designs the circuit boards and any other electrical components. I am Saleh. I manage the software and based tasks as well as the user interface of the rover. And Fahad is in charge of science planning and related soil collection and probing tasks. Participating in this competition will promote teamwork and collaboration among the students. We will acquire hands-on experience on designing and implementing a complex electromechanical system. We'll get to know the hazards faced while implementing such a project and avoid them accordingly. We'll gather experience of formal report writing and documentation techniques and getting feedback from international judges. By participating, we'll promote constructive competition between different international universities from all over the world. We are also honored to represent our country and university in an international setting.
This year we made a completely new rover from scratch. The chassis body has been redesigned completely, which allows better housing for electrical component and science payloads. We used a rocker bogie suspension with bar differential. The bar differential keeps the rover body balanced at an average angle between the two rocker suspension. This minimizes the jerking of the body and protects the electrical component inside. Our rover easily traverses over extreme rocky terrain, climbs steep slopes, withstands vertical drops and drive over sand dunes.
We are using a 4-wheel instead of a 6-wheel configuration in order to reduce weight. A planetary gear DC motor has been housed inside the wheel to protect it while traversing over extreme terrain. The tires have large treads in order to get better traction while traversing.
We use 12 mm tube and 2 mm MS sheet for our rover body. All the parts are made with laser cut and electric welding. For the design, we get enough space for our electric part, especially the body is fully detachable from suspension, wheel and science tool.
Our arm has 6 degrees of freedom. We have used a DC motor and an cyclic gear system to attain a 360-degree base rotation and have used linear actuators for shoulder joint. Using the combination of two 100mm and 200mm stroke linear actuators, the arm will be able to reach ground and 900mm from the ground to perform the required rear seat tasks. The arm of previous version of Renaissance used to vibrate a lot while running over tough terrain. So this time around we redesigned the arm to make it lightweight, and the base plate is supported by ball casters, which stabilizes the whole setup.
We have developed a completely new end effector based on the tasks of ERC and the experience that we have gathered from previous year's competitions. With our new 2-claw linear gripper system, we have maximized the uses of space by using a left hand and a right hand lead screw motors which drive the claws. By achieving proper gripping force, our end effector can turn a knob, flip a switch, put a plug in a socket and measure the voltage, take probes from one place to another place, and place electromagnetic plates in proper places.
We have set up a 2.4 GHz communication link between the base station and the rover using 2 rocket M2s. The base station uses a 15 dBi 120 degree sector antenna, whereas an omnidirectional 13 dBi antenna is mounted on the rover. This ensures non-line of sight communication over a distance of 1 km from the base station. Our rover utilizes a real-sense depth camera for obstacle avoidance and air-tight detection for the navigation task. A Jetson Xavier NX is used as the rover's onboard computer. It processes the 3D point cloud data and odometry information from the camera's IMU and generates a 3D map of the surrounding environment. From this, a 2D map is generated where the obstacles are marked in black. Path planning algorithm uses this map to set the suitable path and avoids obstacles. The entire process is visualized in RVs. We have implemented a ROS-connected custom user interface that integrates all the manual functionalities of rover operation for efficient handling of tasks. Our rover operators can easily control the rover's movement using various buttons on the user interface as well as the keyboard. Also, ROS integration allows sensor information and camera feed to be streamed back to the operator for situational awareness.
Electrical system of our rover is divided into 4 separate boards.
For powering the rover, we are using lithium polymer batteries, and our power module has two separate power rails, 24 volt and 12 volts for powering the rover.
Also, power consumption of the rover is always monitored. For the wheel control board, we are using high current HV motor drivers along with an Arduino to control it over ROS serial. We have redesigned our ARM control board to take advantage of the full 6 degrees of freedom and kept options for rotary encoders to precisely control the arm location and implement inverse kinematics. Whole wiring of the arm is newly done to ensure free movement. Our science control board is using stepper driver and servo driver for driving the scooper mechanism. Also, for analyzing the sample, we are using Wheatstone bridge load cell and an HD camera. Safety of the crews and the rover is our first priority, so we have implemented overcurrent protection and an industry standard kill switch to isolate batteries in case of an emergency.
For science planning, we have to study on plausible geological features of Mars terrain. We also analyze different relative age of the aeolian features, and for scientific exploration, we studied on different types of rock. For the additional science task, we used Google Earth Pro to detect suitable landing site and the place of interest within Utopia Planitia and Elysium region. For collection task, we have implemented scooper mechanism. The scooper is attached with a platform which gain vertical motion from two different 300 mm and 100 mm linear actuator. We used a servo motor to rotate the scooper from 0 to 270 degree. After raising up to a certain height, the soil load is dropped off into the container. We designed 3 different containers on a rotating disc to collect soil from 3 different locations. We will use HX711 load sensor to measure the weight of the soil. For probing task, we have designed an effective probe container to hold and carry the probe efficiently. We will conduct the probing task using the rover arm.
We are conducting our branding and outreach programs in our social media pages and conducting various educational and technical sessions, both online and offline. Wish us luck and see you in ERC.
Hi, we are the Rover team of the student initiative ERIC, which is affiliated to the Technische Universität Braunschweig in Germany. Our team consists of 12 members from different courses of study and is divided into 3 sub-teams: mechanical engineering, software and electronic engineering, and science. With the participation in the European Rover Challenge, we aim to expand our initiative's research areas, which mainly comprise rocket science and high-altitude research by the versatile field of rover technology. Furthermore, we appreciate the international character of the event and the opportunity to get in contact with space experts from all over the world.
But first, let's take a look at our rover authors. Our Ackerman steering enables us to maneuver through tight turns. Our rocker bogie suspension can also handle slopes and different undergrounds. When moving forward is not an option, moving backwards is not a problem at all. Our science payload can suck in different kinds of soil and detect ATP with the help of luciferase and an avalanche photodiode.
In our scientific experiment, we aim to detect traces of life in surface samples of the Mars yard. Our experiment is based on the detection of adenosine triphosphate, short ATP. ATP is a chemical compound that can be found in every known form of life. When ATP is mixed with luciferase, which is a special group of enzymes, the two chemicals react with each other. During the reaction, light is emitted through bioluminescence, which is an effect well known in nature. The emitted light is detected by our experiment through an avalanche photodiode. In this picture, a schematic overview of our science payload can be seen. A mechanism called sniffer sucks in loose material from the ground into the payload. The material is collected in a cyclone separator and subsequently stored in a light-sealed container. In the container, the sample is mixed with the luciferase and observed by the avalanche photodiode. Here you can see the design of the payload, with the sniffer on the bottom, the cyclone separator on the top, and the light-sealed container in the middle.
Our specially designed gripper can handle round objects like rocks, but also pick flowers. For testing purposes, we use an Xbox 360 controller to operate the rover remotely. Safety is important to avoid unexpected accidents. To avoid this, we installed an industrial emergency switch which cuts down the power immediately. We hope you enjoyed this little insight in our rover project and hope to see you on the Mars yard.
Hi, we are Yıldız Rover team and welcome to Yıldız Technical University, Istanbul. Today, we will introduce you our first generation rover, Sparkle. We currently have 36 members from several engineering and science departments who vary in grades, skill sets, and some with a background of robotics. Knowing how far teamwork can get us, we have a team-based structure consisting of 4 technical and 3 organizational sub-teams with a flexible learning environment. As Yıldız Rover, and even ambitious team, we always have wanted to achieve success that will best represent our university and country. The team, which contributes to and follows the space studies with great interest, is very excited for such competitions. For this, Europe's largest rover competition, ERC, is a great opportunity. We share common values with ERC that we want to inspire people about space and contribute to local space research just as them. To achieve this and bring together students from different disciplines, we participate in rover competitions.
Our rover's modular chassis is made of T-strut aluminum, which is durable, reliable, and allows us to make configurations between missions. The differential bar mechanism was designed so that at least one wheel on both sides of the rover is constantly in contact with the ground on rough terrain condition. The specially designed tire, which was inspired by current airless tire studies in the automotive industry, was produced with a TPU filament. Horizontal threads were formed on the tire surface to keep the traction at the optimum level in rough terrain conditions. Vertical threads were added to the right and left ends of the tire to prevent the rover from spinning off the soil was moist. Thus, it's ensured that the rover can move smoothly against slopes up to 45 degrees without tipping over.
We designed battery management system, power distribution, sensor peripheral, motor driver, encoder and hub PCBs to be used in the rover. The rechargeable 24-volt, 22 Ah lithium polymer battery was preferred as main power source, considering electric equipment that require high current. The energy taken from the battery is transferred to relevant electric equipment by adjusting the appropriate voltage values by dint of power distribution PCB. Rover's internal communication consists of especially CAN bus and UART protocols. The external communication between the rover and ground station is based on 5.8 GHz access point and omnidirectional antenna. The lithium polymer battery used in the rover needs a protective circuit. For this purpose, a battery management PCB that provides passive balance has been designed by our team based on the rover operating conditions and the system requirements. A high current fuse is also used to protect battery from dangerous shorts or sudden high currents. In-vehicle locations of PCBs and other electric equipments were designed by considering emergency scenarios. In addition, easily accessible an emergency stop button was placed on the rover that will shut it down under any circumstances.
For the autonomous task, we use various sensors on the rover, such as 3D LiDAR, magnetic encoder, and cameras. We obtained an odometer data by using these sensors data. Using these data in the move-based package we modified, we let the rover know its position and enable to reach the desired location precisely. Decisions for the rover's movement are made by the information from 2D map and image processing algorithms responses. While reaching the given destination point, the rover avoids all obstacles and creates possible path. Then it chooses the least costly path. 4 cameras are located on the rover to observe as much as we can. 2 of them were aimed at the manipulator to become faultless in action, and the other 2 are looking around the rover. While the rover navigates, it also searches for markers. According to the count and distance of markers, it plans and executes motion. Detected markers were passed through algorithms to obtain a distance. After the object to be reached by the manipulator is determined, the manipulator approaches and interferes with the target object with kinematics. We use absolute encoders to retrieve joint data to match with kinematics data. Also, PID is added to all axes of the manipulator, so it can maintain its position despite all external factors.
The manipulator features 6 axes to perform the task at the optimum level. In order to reduce the rover's overall weight, the manipulator's joint parts were made of aluminum, while the link parts were made of carbon fiber composite tubes. Second, third and fourth axes are powered with linear actuators that provide the desired lifting, pulling capability and high precision. By simply changing to fingers and scoops, we get 2 different anti-effector designs. Inspired by the human hand, the anti-effector has 2 fingers moving parallel to each other. The scoop design is made of PLA for the probing and collection task. The container mechanism was designed to easily demount the containers at any time. A component is produced from a 3D printer between the container and the tail slot aluminum profile. A load cell has been added to the bottom of each container to weigh collected samples.
As a science team, we carried out our studies on sedimentological and geological formations on Utopia planitia and Elysium planitia, such as fluvial and volcanic activities, ice law interactions, and crater formations. With all these studies, our team planned our scientific hypothesis. In order to determine the landing site, we examined the area from a geological and mineralogical perspective. Reviews were done on JMars. We analyzed the environment's temperature, humidity, pressure, and several gas levels such as carbon dioxide, methane, nitrogen dioxide, and carbon monoxide to observe the suitability of the environment for extant life. We also used NPK sensor to detect nitrogen, phosphorus, and potassium in the soil. Possible scenarios were identified by analyzing the soil structure and geological history of the region. Image processing is used to determining geological features and considering the minerals in the soil, and in interaction of ice lava, inferences were made on organism-based life and fossil traces that could be potentially preserved. Besides, our mechanism can recognize unexpected objects in the given area. In the search for possible primal habitability on Mars, we have designed and built a visible near-infrared surfactance spectrometer specifically to investigate biosignature molecules on the rock and soil samples. With image processing, spectra can be converted to wavelength graphs and geological features can be determined. A unique end effector is designed for surface sampling. 3 samples will be collected and transferred to the container mechanism.
Hello everyone, this is Team DJS Antriksh participating in the remote edition of European Rover Challenge 2022. We are the official Martian rover team of Dwarkadaas Desangvi College of Engineering, Mumbai, India.
Team DJS Antriksh comprises 48 undergraduate students from different branches of engineering working in 5 sub-departments. The mechanical department works on designing, manufacturing and testing the structure of the rover. The electronics department is responsible for the development and integration of electronic systems. The coding department handles algorithms for efficient object detection and overall rover operations. The science department studies the geological history of Mars to draft hypotheses that can be tested on the landing site. The marketing department focuses on the finances, outreach, and complete team management.
We are a team of students with profound interest in the field of space and robotics. Our aim is to become the next generation engineers who would contribute to space exploration missions carried out by esteemed space organizations. ERC presents a unique opportunity for us to showcase our skills at a global platform. Participating in a competition like ERC would mean competing against some of the best teams in the world and would serve as a chance to promote overall improvement of the team in terms of knowledge and experience.
While preparing for ERC 2022, we encountered numerous difficulties, but we overcame them all with unwavering commitment and determination. During the preliminary phase, a proper work timeline was modeled that was followed strictly to ensure that the tasks were completed well before the deadlines. Regular meetings with clear agendas were scheduled in order to maintain smooth operations within the team. Tasks with maximum interdepartmental dependencies were prioritized and taken up first. A proper routine was followed to prepare for the test drives, analyze the outcomes, and debug the errors faced. We also consulted team mentors who were active participants of the previous ERC editions to gain the best insights about the competition.
For the science task, the team has been working on the previous model of the Mars yard, identifying the distinct geological features on it and trying to develop hypotheses about the Martian surface based on parallels between the Mars yard and Mars, specifically near Utopia. This research is being assisted by the extensive use of softwares like HiRISE and JMars to easily comprehend and collect all available data and use it for developing a science mission.
The preparation for the navigation task begins with the planning of the traversal path, either autonomously or manually or through a blend of these modes. We have used the ROS navigation stack with a few modifications for Path Planner. An RTM mapping approach suitable for the onboard Z2 camera is utilized for obstacle detection. We have also implemented AR tag detection, which facilitates localization of the landmarks. The move-based package is used for path planning. The map generated by SLAM helps to create global and local cost maps. When given a goal, the software plans a path and mobilizes the rover.
For the manipulation of the arm, we have used the MoveIt framework provided by ROS. Using the AR tracking library in conjunction with the camera input, Aruko markers along with environment variables will be localized with respect to the robot base frame. This data will be processed and set as a goal for the MoveIt planner so that the motion plan can be executed autonomously. Using the Aruko tag to differentiate space position and important features of the panel to construct a collision map and a collision-free solution is then found for grasping and attaching objects using a more precise plan.
Team Infinity is a group of 26 highly passionate undergraduate students of different engineering backgrounds from Delhi Technological University, India, working together for prestigious European Rover Challenge Remote Edition 2022. For better workflow, our team is divided into 6 sub-departments, namely Electrical, Mechanical, Software, Embedded, Corpo, and Science.
Effective work, our software department has been divided into 3 sub-teams: the autonomous team, the robotic arm team, and the GUI team.
The autonomous team is responsible for the development of navigation stack for the autonomous traversal of rover in the Mars yard. The ARTA map and AR track Alva package were used to create visual odometry and deliver velocity command to the move base node and to locate the rover on the Mars yard. For navigating the rover using the move base, a custom waypoint file is created. After a wait of 5 seconds, the rover begins the navigation, deploys the probe after reaching the waypoint, and only provides the next waypoint when the probe is deployed with a 5-second wait in each waypoint. In order to avoid the obstructions dynamically, local cost maps and global cost maps were developed, and a 3D cost map is updated continuously using Octomaps. For the maintenance task, both the robotic arm and the autonomous sub-team work together so that the arm can be operated manually and autonomously. The manual operation of ARM is done using the Xbox controller, and the autonomous operation is achieved by the custom designed Python files. These codes have been designed in order to detect and manipulate the objects, buttons, and the Aruko markers. All these have been incorporated into a single launch file to operate them simultaneously without any hassle.
The science and research team consists of 8 dedicated members who are looking into various aspects of the competition. For this year's competition, the team is divided into 2 subparts. Half the members are looking for geology-related research and half selecting the best possible landing site.
In order to decide which landing site would be feasible, a study was done on Martian missions for understanding the basics of selection of landing site, Martian geology, and its surface properties. Considering the requirements of the competition, extensive analysis was conducted. JMAR software is used for mission planning, which contains remote sensing data from various instruments. Layers of different surface properties, such as albedo, thermal inertia, and rock abundance, were used in conjunction with layers related to composition of the surface to study the presence of important minerals or rocks like andesite, basalt, carbonates, and so on. A comprehensive study of prescribed Mars yard is done by drawing profiles and analyzing the variation in graphs of the layers.
We are IoT Mars Rover team Obijatrik from Islamic University of Technology, Bangladesh, participating in the European Rover Challenge 2022 Remote Edition. This year, we are also participating in the on-site edition. For the remote edition, we have divided our team into 4 sub-teams: navigation, maintenance, science, documentation, and presentation. Muhammad Ashraful Haq is the team lead and Mohammad Sabbir Rahman is the technical director and software lead. We have performed well in various rover competitions in the previous years, but this is our first time participating in ERC Remote Edition, which focuses much on the software architecture rather than the hardware systems. As software automation is a crucial part of robotics, ERC Remote is a great chance for our software and automation subteam to work on a rover system without worrying much about the hardware side implementations.
For this science task, we will use Google Earth Pro to find as many high-resolution imagery of the predefined region as possible to carve out the best landing site for the rover. To develop the scientific reasoning behind the chosen spot, we will put the data visualization and analytic features of JMARS, which has proven to be a significant tool for space mission operations. With the chunks of datasets available on Mars's geographic morphology in JMARS, we will develop the geographical history of the area. Along with that, we will use the geographic data from previous Mars rover expeditions on the predefined region available on the web.
Currently, we are able to perform our navigation task manually using teleportations with the help from the landmarks, and we are able to use AirTrack Alvar to detect the air tags in RVs for the localization purpose. We are able to connect to the Freedom Robotics agent with our local simulation and control and practice driving our rover from the web page. For the third test drive, we plan to drive manually using Freedom Robotics. We used the 2021 Mars yard and previous year's waypoints, and we created a path observing the terrain of the Mars yard, which will traverse all 4 of the waypoints required. We plan to further improve our ability before the final drive. For the maintenance task, we are working on Aruco marker tracking system that will be used to detect and locate the Aruco markers. In the test drives, we have driven the UA3 arm manually using the UI and acquired knowledge and precautions to follow while operating the arm.
This is the ITV Mars Rover team from Mumbai, India, a student initiative to build rover prototype for all-terrain autonomous traversal, perform stress tasks with an onboard robotic arm, and conduct onboard tests for biosignature identification.
The team consists of multidisciplinary undergraduate students spanning all years of study. The team is broadly divided into the Electrical and Software, Mechanical and Biosciences division. The Electrical and Software division has the autonomous hardware and IP subsystems, while the Mechanical division has the suspension, robotic arm, and wheels and chassis subsystem. All subdivisions work in tandem to bring the rover to life. To prepare for the challenge, we went over multiple papers, had extensive discussions, and significant code refactoring to meet the challenge requirements. To test our developed software stack, we formulated a 3-step approach. First, we ensured all the corner cases were ironed out via gazebo simulations. Second, we developed an in-house GUI to simulate the Freedom Robotics interface and gain proficiency in web-based operations. Lastly, we performed field trials and tested the autonomous and manual functionality on our own rover.
This year in the science plan, we will analyze Mars yard images and 3D elevation data to extract geological features. We will be using JMAR software to locate a safe landing site with interesting features. With the data available, we will be making a hypothesis about the formation history of the region while referring to the region of Elysium and Utopia Planitia. Based on that, path traversal would be decided in the science and navigation task for efficient travel with sufficient time for scientific exploration with image processing techniques.
To prepare for the navigation task, we decided upon a two-pronged approach with a mix of autonomous and manual navigation.
We used the Moon-based package for efficient path planning based on the A-star algorithm. A real-time appearance-based mapping algorithm is used for 3D mapping and localization, along with an extended Kalman filter for sensor fusion and odometry. Using the ARTrack Alvar package enables real-time Alvartech detection and tracking. All these are integrated within a custom Python script for autonomous waypoint navigation, which can be adapted to various rover configurations. Similar to the navigation task, we developed both autonomous and manual mastery for the maintenance task. At the heart of the autonomous algorithm for the maintenance task lies the MoveIt package, which implements state-of-the-art algorithms. A custom pre-processing script processes the Aruko markers using the OpenCV package and enables the maintenance task to be performed autonomously. To ensure we are ready for any situation, we have spent countless hours training and ensure both the drive and arm can be smoothly controlled from a web-like interface.
We have spent months preparing for this competition and are hoping for a good performance. This sums up our video submission for the remote edition of ERC 2023.
We are Mars Rover Manipal from Manipal Academy of Higher Education, a team of passionate undergraduates developing rovers capable of Mars exploration. The team has been competing in various rover challenges since 2016 and has won laurels on multiple occasions. The European Rover Challenge, with its unique focus on automation and ingenuity, motivates us to learn and enhance our skills, thus encouraging us to grow as a team. The remote edition format not only makes it easier for teams to engage with the competition by reducing costs incurred, but also broadens the scope of interaction and raises the level of competition by allowing teams with weaker financial backgrounds to participate at the global level. The team is divided into subsystems based on their respective tasks, namely the maintenance, navigation, and science subsystems. New members of the team are put through a training phase where the recruits are given a series of tasks designed to prepare them for the challenges presented by the competition. Over the last 3 months, the team has been meticulously preparing for each task. The science subsystem has been working on creating relevant databases and practicing the analysis of previous year's Mars yards. The maintenance subsystem has been designing search pattern algorithms along with scripting motion plans for the UR3 arm, while the navigation subsystem has been optimizing various efficient planning algorithms and fusing sensor data using an unscented Kalman filter.
The maintenance task is initiated by executing a custom search pattern algorithm to scan the Aruko tags and estimate the corresponding pose of each tag. The Aruko detect package and dynamic transforms are used to estimate poses. The quaternions obtained from Aruko tag ID 10 are used to determine the end effector's link angle for picking up and attaching the IME module. The panel's inspection takes place in a similar fashion, utilizing the poses stored on the ROS param server. The ID of the hidden button is stored before closing the panel. The actuation of the hidden button takes place using Cartesian path planning. Task completion is marked by return to the home position.
To automate the rover's traversal for the navigation task, we have used the Blender file provided and converted it into a point cloud, which is then parameterized to produce an optimal 2D map. AR tags are used alongside a UKF from the robot localization package to determine the pose of the rover. Dijkstra's algorithm has been implemented using the move-based package. The rover uses a preset cost map to find an optimal path for autonomous traversal. Recovery behaviors like cost map clearing and rotate recovery are also implemented. Point cloud data from the Z2 camera is processed using the point cloud library to eliminate the ground plane and detect obstacles. The detected obstacle is used to generate a local cost map and then a local path is planned.
The goal of the science task is to carry out a thorough geological analysis of the Mars yard, which we achieve by conducting a topographical evaluation of the region. This, along with our database of Martian landforms with information about their formation and characteristics, will be used for relative aging. It will also be used to verify a falsifiable hypothesis. Our extensive rock and soil database simplify the process of identification and analyze by filtering their physical description to narrow down possibilities. To select a landing site, we examine the region enclosed by the provided coordinates using JMARS and HiRISE. This enabled us to identify a region with significant research potential that also met the engineering constraints.
Hello, we are Mind the Cloud. We are representing Alexandria University Faculty of Engineering from Egypt in ERC competition. Our team is divided into 3 sub-teams: Science, Navigation, and Maintenance. Being on a Mars mission makes it increasingly motivating and unique. We learned so much through our journey, and we continue to do so every day.
Regarding the maintenance task and the panel objectives, we were able to locate our Ryuko markers, which is reference to the gripper, and using dimensions between tags and buttons listed in the freeze guide, the switch's positions are known. We are working on traverse the whole station while detect all markers to save their IDs and positions in message created by our own, then go back to home position to start main objectives. For pressing the 4 buttons in required order, a script is used to search for the required switches positions with assistance of our message. For any picking up required objective like IMU or box cover, we made decision to do it manually. For instance, in the box objective, we are attempting to achieve it semi-autonomous by putting the cover in the storage area to identify the hidden marker manually and press autonomously the switch that has been detected in the box. And for IMU objectives, we are attempting to do it manually.
Hello, this is Asir Muhammad, a navigation software specialist at MindCloud. Our biggest challenge in the navigation task was the uneven terrain navigation. We use the RTAB map for the RGBD SLAM, so it provides us with a projection map for the move base along with global obstacle detections. But this wasn't enough to make the rover safe from minor obstacle collision and moving up or down steep slopes, so we applied a new approach for local planning. First, we flattened the base link to overcome some of the move base 2D limitations, and used the point cloud filter that iterates points and filters slopes using 2 predetermined parameters. So the rover avoids going up or down steep slopes like hills or cliffs, and avoid risking of falling or flipping. Also, we've been working on fusing the Z2 odometry with wheels, IMU, and AR tags for optimum localization and waypoint navigation. And lastly, we've been improving our Python script for easy pilot control and sending of goals.
Now I'm going to talk about the science part. First, we're going to choose the map of the best landing site and interesting features to analyze it geologically by choosing an image from Google Earth Pro. Second, we're going to use ArcGIS in order to form a layout well-positioned map with a legend and outline features. Third, all visible general features on the map of the yard will be outlined and studied according to their lithology, topography, and geomorphology. And so we can interpret their type, either they can be volcanic features, craters, or sand dunes, and how the rover can be affected by them. Also, we will interpret the interesting objects which can be found. Based on that, geologic history and order of events can be predicted in order to build our hypothesis that we are going to prove during the rover path in the yard.
Project Red was born in 2019. We take part to both ERC competitions, and this is the second year in which we take part to the remote one. We have learned a lot from last year's experience and mistakes, so we have reorganized our team and our approach to the tasks. Our purpose as Modena and Reggio Emilia University team is to give to those students who are passionate in robotics and aerospace the possibility to improve their skills and love for these topics. We give a great importance also to transversal skills, such as teamwork, collaboration and management ability, because of the complexity of our project.
Today the team is composed by 60 students from different faculties. Members are divided into 5 divisions: business, robotics, mobility, system and science, each one coordinated by 1 or 2 division leaders. The team works and develops its studies writing space provided by the university and the sponsor companies, where the members can both hold meetings and work on available platforms.
Robotics division is the core of the remote competition. Our mission is to develop control algorithms for both navigation and maintenance tasks, aiming for the highest automation possible. The implemented software is extensively tested in simulations, but we also consider tests on real hardware to be fundamental. For this purpose, we are testing our solutions for the maintenance task on a robotic arm provided by our university, while navigation task software is tested on a real mobile platform specifically designed by the members of the mobility division.
Our approach to perform the navigation task is to plan a global path to reach the provided waypoints and points of interest. For the science task, we are implementing obstacle avoidance algorithms along with a localization system based on visual odometry and the recognition of landmarks placed in known positions. This allows us to use the autonomous navigation to perform the traversal.
Our intention for the maintenance task is to get a complete mapping of the environment by recognizing fiducial markers. Then we will exploit the calculated positions to execute automated routines, to perform pick-and-place operations, and to interact with the environment. In order to achieve high automation, we are developing fault-tolerant solutions, implementing security checks, and backup operations.
The task of the science division is the characterization of the landing site and surrounding areas from a geological, geomorphological, chemical and mineralogical point of view, recognizing and interpreting the origin of the landforms and their chronostratigraphic succession. Moreover, the science division can prepare the laboratory tests that can be carried out in the rover's internal laboratory and analyze properties like grain size or the material of the terrain samples. In this way, with the support of photos taken during the traverse, we will be also able to set up scientific hypotheses on the nature of certain objects detected along the rover's path during the navigation task.
This year we have the possibility to meet in person without limitation due to pandemics, but we also keep taking advantage of change to remotely connect with each other. We will provide information courses for new members, both in person and online, in order to provide the basic knowledge required for the competition task. The whole team is following the agile methodology based on frequent meetings and activity replanning, in order to be flexible and rapidly adapt to unforeseen circumstances.
We, Team Aurora, are a group of 30 undergraduate students from BSc Institute of Technology and Applied Research, Coimbatore, India. We take this video as a privilege to introduce our team, explain our work progress and our preparation strategy for the upcoming European Rover Challenge 2022 Remote Edition.
Our team comprises of 5 subsystems along with the help of a faculty advisor. For ERC Remote Edition, 6 members, 4 from circuit branches and 2 others from non-circuital branches look into navigation, maintenance and science tasks respectively.
The motto of our team is to motivate the best brains to develop and get familiarized with the next-gen technologies in the fields of robotics and space exploration in order to make us compete in the largest robotics competition on Earth. The ERC competition makes a huge impact by providing us the opportunity to exploit our technical and non-technical know-how like software proficiencies, controlling methodologies, research analysis techniques for creating our hypothesis, work, time, project management and financial and developmental skills which are required to exhibit in such world-class competitions.
The preparation for ERC 2022 started way back in 2021, where we restructured our team and added few members to compete in ERC 2022. We utilized this time to excel in the field of ROS and to learn a number of software such as QGIS, JMOS and MATLAB. Competitions were conducted within the team to brainstorm and solve problem statements, to increase the learning efficiency and to build a competitive mindset.
For the navigation task, the major tasks are AR tag detection, localization and probe deployment. In the first 2 test drives, the rover was operated manually on the Mars yard for familiarization of control. Firstly, we are using RTAB map to generate map of the environment on Orbis. When it comes to AR tag detection, the AR track Albert package is used. The position and orientation of the rover is determined using the data obtained from the internal IMU sensor. The rover is navigated towards the closest waypoint, avoiding the obstacles. After reaching the landmark, the probe is deployed.
Science task of the team focuses on feature reduction along with the analysis required for selection of correct landing site and hypothesis required to prove during the final field trials. For feature detection, we use web-based mapping software JMOS. JMOS can load and process raw numeric rasters which help in contour mapping, grouping of layers, plot creation for thermal initial sampling and other surface properties. It also turns pixel data from JMOS to numeric elevation map in ArcGIS. The rocks and their abundances in the site can also be detected from a sample image by image segmentation and thresholding with OpenCV2.
For the maintenance task, the contouring of arm is done both manually and autonomously, and we have performed all the tasks mentioned in the documentation by manual mode during the test drives. For moving the robot autonomously, we are using the Move It and Gazebo environment. Marker detection and button actuation is done using separate Python files that get launched together. The markers are saved as a CSV file and act as pathfinders to explore and navigate the arm in the given environment.
Hello, we are Team Shunya from India and we are participating in the remote edition of the ERC 2022. Our team is divided into management, software, science, mechanical and electronics divisions. The management division looks into project planning, organization of resources and recruitment. Specific members of the team are made responsible for various tasks of the challenge to ensure smooth workflow, increased productivity and high quality solutions. The science division plays an active role in research, geological mapping and development of a scientific hypothesis. Software solutions are tested on prototypes developed by the mechanical and electronics divisions.
Participation in the ERC provides us with a platform to fuel our interest in robotics and develop skills in it. We are exposed to the latest technologies and get to test them on standard hardware. Competing with teams from all over the world requires us to work with people from diverse backgrounds and helps us develop technical and managerial skills. The recognition at an international level will open the doors for us to explore various opportunities in the field of robotics. We have been preparing for the challenge for 1 year and held team discussions during the pandemic. Project management software ClickUp was used to track track the team progress and status, of regularly communicate with judges over matter most and clarify our doubts. On campus, we have a spacious workplace where the entire team works together, holds discussions, test solutions on hardware, and bring ideas to life. We are grateful as we have extremely supportive mentors to guide us. As part of the preparation, we have developed multiple prototypes for testing purposes. We also indulge in recreational activities to keep ourselves physically and mentally fit.
For the science task, extensive research and analysis was carried out. For planning, GMR software was used. Various layers of properties such as rock abundance, minerals, thermal inertia were added to understand the mass yard. Using drone images and 3D map amongst other materials provided helped us identify different geological features, determining how they are formed and their relative ages. With all the relevant information collected, we conclude our hypothesis, which can then be tested and verified on Mars yard. During the competition, unknown objects of interest in the surroundings will be observed and documented.
For the navigation task, we have three separate approaches, namely manual, semi-autonomous, and fully autonomous. Odometry TF from Z camera is used to track rover's position. The AR Track Alver package is used to detect AR tags. A text user interface is used to monitor the rover's location. We have set up Freedom Robotics for teleoperation and added key metrics to monitor important data feeds. The ArtaMap ROS package is used for 3D mapping and generating 2D occupancy grid map. The map is then utilized by MoveBase package for autonomous navigation. An alternative approach prepared is using SLAM along with AMCL technique.
In maintenance tasks, for the manual teleoperation, we are practicing using our custom keyboard teleoperation program, which functions similar to the GUI provided during the competition. Manual mode is just a backup for us, as we are strongly focusing on autonomous mode of operation. Currently, we have completed the code for most of the tasks, and some of them are under testing. The robotic arm scans all the Aruko markers and stores them. Here, the collision objects have been added from the stored marker data to avoid collision with the panel. Again, with marker location, by creating collision objects in place of IMU box, we are able to pick the IMU box and position the IMU box.
We are Team Interplanetar from Bangladesh University of Engineering and Technology participating in European Rover Challenge 2022 remote edition. We have divided our team into three sub-teams: software, science planning, outreach and video production. I am Shiham, team leader of Team Interplanetar. I am responsible for collaborating between all the sub-teams. I also work in software development extensively. We can see some other members of our team here along with their roles. Saleh works on Leo Rover simulation and autonomous navigation. Apurva works on MoveIt ARM software. Fahad is responsible for science planning. Shorup and Sani are responsible for outreach and video making. Here are all the team members. We are an interdisciplinary student team, so we have students from electrical, computer, mechanical and other engineering departments. Past successes of our team motivated and inspired us to take part in this year's challenge. In ERC 2021, our team was placed 11th position. In ERC 2020, the first ever remote edition of ERC, we are placed 13th. This year, we want to utilize our experience to achieve better rank than before. Participation in this competition have resulted in a positive impact on our team. We got to control and program Leo Rover on a URC arm remotely. We got ourselves familiarized with Freedom Robotics platform. We were able to apply our ROS landing practically outside simulation. We also learned how to write detailed engineering reports and projects. At the start of the competition, our team members extensively researched the rule books so that we can get a better understanding of the overall competition. Then we set up a timeline for our work and divided the work amongst the team. Those who had experience in previous year's remote ERC trained the new members how to use ROS and the simulations. Parallelly, the science team started researching on important regions of Mars and learned how to draw maps using CorelDRAW and color code them. We developed our software using the simulations. Then we performed test drives using our own software. Later, we analyzed the ROSBAC files and recordings and finalized our software. Now, we will present our planned approach to science task.
For the science task, we need to create a geological map of the Mars yard. We will be using CorelDRAW to create the map with proper legend and color coding all the geological features. As we have previous year's DEM files and drone images, it will help preparing ourselves. We will also research about the northern Elysium region of Mars, which is the selected regions for this year's elections.
To prepare for the navigation task, we developed our autonomous navigation software using the provided simulation. Here we can see the rover is able to drive autonomously, avoid obstacles and detect landmarks. During the test drives, we used our own software to drive Leo rover autonomously. Here we are using RVs from visualization station to send position goals. The rover is moving to the position autonomously. Finally, we analyzed the ROSBACs and finalized our software. To prepare for the maintenance task, we used MoveIt for motion planning of the arm to perform various tasks in simulation.
Hi, we are AGA Space Systems from AGH University of Science and Technology in Krakow, Poland. Our rover Kalman is a product of over 5 years of development, and today we would like to give you a sneak peek of what we have prepared for the biggest space robotics events in Europe, ERC 2022. Our team is made of 24 members, representing a wide variety of majors and faculties. We are divided to 4 subteams: mechanics, electronics, software and science.
The science team collaborates closely with the engineers to ensure that our rover can perform well in the science task. 2 main areas of focus have been the vision system and the ground station app.
7 onboard cameras provide operators with live video feedback, allowing us to orientate ourselves in the field and search for objects of interest. 2 additional cameras provide a high-quality offline recording, so we can retrieve good images for the science report. Even more, an ultra-zoom camera is mounted on the gripper to provide close-up shots of rocks found in the field. Ground Station app includes several features dedicated for science tasks. Photos are captured with a click of a button, while rover localization and traversal path are visualized live on top of a Mars Yard map.
One of the main advantages of our rover is its maneuverability. Each of the 4 wheels is independently turned and propelled. This is useful in all of the ERC tasks, not only for avoiding obstacles found on the Mars Yard, but also to quickly scan the environment for points of interest in the science task, or to position the rover in front of the maintenance panel. We use predefined trajectories to automate repeatable movement of the manipulator, such as picking up probes from the container or caching soil samples. A special shape of the grippers and effector allows us to manipulate probes and collect soil in one mission. We tested many iterations to find the optimal design. The detachable module features 4 sealable containers. The rotating design allows us to always position the container in the same spot, convenient for dropping soil.
The new 6 degrees of freedom manipulator features harmonic gears, BLDC motors and a decentralized control system. IK algorithms greatly speed up its operation. The new, more ergonomical and powerful robotic gripper is in an advanced stage of development. The previously used, proven in battle 5DOF arm is still being maintained and improved and can be easily leveraged in case the new arm fails.
Our autonomous navigation is based on ROS packages that were modified and adjusted for our outdoor environments. The localization algorithm is based on IMU, visual odometry from T265 camera, as well as AR tag detection. Data from the sensors is then merged by extended Kalman filter. For mapping purposes, we use an IR-based stereo camera to generate a slope-sensitive cost map. We test the autonomous traversal on a weekly basis in a variety of difficult and real-life environments to make sure that our system works irrespective of terrain type or weather and lighting conditions. We also make extensive use of gazebo simulations. A continuous integration system significantly speeds up development by reporting most bugs before the software is deployed on the robot.
None of this would be possible without support from our university, Ministry of Education and Science, and private sponsors. Thank you. Now you may wonder, why are we doing all of this? There are plenty of reasons, but we would like to focus on just 3 of them. First, it allows us to become better engineers. What's really cool is that ERC judges always take the time to actually give us detailed feedback, so we get priceless advice from people with years of experience in the industry. The second reason is that we want to inspire others, especially kids, to follow their passion for science and technology. ERC is very unique because you get to compete in front of a live audience. And last, but definitely not least, is that it's just a lot of fun. Working all year on your very own Mars rover with a bunch of friends, and then meeting other teams from all over the world who do the same, is just quite an adventure. So if you haven't already, we deeply encourage you to assemble a team and become part of ERC. See you in space.
Hi, we are Team Diana from Politecnico di Torino. For this year's European Rover Challenge, we are proud to present a new and enhanced version of our rover Ardito. The team was born in 2008 together with Amalia, our first lunar rover developed to participate in the Google Lunar Prize competition. Since then, hundreds of students have participated with passion in the creation of lunar and Martian rovers.
Our team is arranged into 4 departments and 2 special purpose groups, with every department being further organized into groups. Then the team is managed by the leading board, which counts the department leaders, the project manager and the team leader. In order to enhance the decision-making process, this year we also introduced a new support board composed of expert team members and group coordinators.
ERC 2022 is a big opportunity for us. It is an occasion to challenge ourselves in a space-like project and to understand our collective and singular strengths and weaknesses. We also aim to achieve useful skills for our future work careers and to meet experienced people in the space industry.
Ardito is designed as a modular platform, capable of adapting to several operational scenarios. The basic configuration sees the mobility system, power and avionics, onboard data management and the robotic arm. In addition, the rover can host different payloads according to the mission needs. Thanks to a custom-made 35 Ah lithium-ion battery, Ardito has 3 hours of autonomy. The power is distributed to all electrical components through a team-designed power distribution unit, while a power controller board monitors and records system consumption. Avionics is distributed among several layers, including the main onboard computer, the main control units of the mobility, the robotic arm and the power. The mobility system and robotic arm, while being independent, implement a common architecture. The main control unit, which processes commands and feedback, is connected via CAN or serial bus to lower layer boards, which are interfaced directly with sensor and actuators.
The locomotion structure of Ardito consists of a rocker bogie terrain mobility system, equipped with 6 independent wheels, 4 of which are capable of steering. The wheels are made of spring steel, increasing grip on harsh terrain. The differential system connects the 2 rocker bogies and guarantees stability over uneven surfaces. A velocity controller, based on the Ackermann steering geometry, drives the mobility directly through velocity and angle. On a higher level, a position controller can be activated to autonomously drive the rover to the desired point.
System and environment safety is achieved through 3 defensive layers. The first one is software implemented and acts on 2 levels. A remotely triggered abort command can halt communication to the system control units. Instead, a timeout inside the mobility and arm control units stops any system movement if the connection with the onboard computer is lost. The second layer is our custom-designed power distribution unit that monitors system power consumption and can directly cut power to a single faulty component. The third and final layer is directly connected to the power source and acts directly on the batteries. Its activation, either automatic or manual via the emergency stop button, cuts the power to the entire rover, immediately stopping any movement.
Ardito is able to interact with the surroundings thanks to a 6 degrees of freedom robotic arm. The end effector, placed on the top of the arm, is equipped with modular fingertips that can be interchanged for different tasks and integrated with external tools. Thanks to a camera, force and proximity sensor, the end effector can be manipulated with high accuracy. A controlling algorithm, based on the inverse kinematics, permits the autonomous movement of the arm just by giving it the desired coordinates.
Onboard data handling is performed by a Linux-based NVIDIA Jetson Xavier. This software, running on the rover, is divided into layers of abstraction, with each level taking advantage of the one below. All of the abstraction stack is fully developed by the computer science department. The operator and the video software can sense the surroundings due to several cameras. A stereo camera placed on the front of the rover retrieves the point cloud map of the surroundings and the position of the rover, while a USB camera, placed on the robotic arm, provides visual feedback to the operator. Ardito is connected to the base station console thanks to a Wi-Fi access point over the 2.4 and 5 GHz frequencies. All rover modules are connected via Ethernet and can communicate via the MQTT protocol. The ground segment is mainly composed of a computer. The human-machine interaction happens there on a standalone web app, where we developed modules to control the rover and monitor data elaborated on board.
This year, the scientific group chose to study the winds that blow in the Mars yard. We will first study rock deterioration to assess past winds, that from a preliminary study they should be coming from southwest, and compare them to nowadays winds to better understand the story behind this Mars region. This study is important for future colonization of the Red Planet, as knowing the winds will be a stepping stone to use wind power as a power generator, alongside others such as solar and nuclear.
The sampling system is a standalone unit designed to collect continuous and undisturbed subsurface samples of soil. It is composed of 3 subsystems: sampler, percussion system and lifting system, each one equipped with dedicated sensors. Every subsystem has been tested and designed in order to maximize the recovery rate of the sampler in a soil simulating the Martian regolith with different degrees of consolidation.
We are very proud and happy of our work this year more than ever. Thanks for this opportunity. We can't wait to meet you and all the other teams in Kielce. Stay Diana, stay Mambo.
Hey there, and welcome to EPFL. Today, I am proud to introduce the EPFL Explore Rover team and our rover Astra for the European Rover Challenge 2022. As a space robotics project, our goal is to develop robotic platforms capable of navigating complex terrains and performing scientific experiments thanks to a robotic arm and a science compartment. To achieve this goal, we subdivided the team into multiple subsystems. A management team composed of the president, the project manager, and 3 systems engineers, 8 technical subsystems and 2 non-technical subsystems. Working with a team of more than 70 members can be challenging, which is why interface meetings were organized to keep everyone informed in addition to weekly team meetings and working sessions. Several general reviews also helped in keeping the members and our partners updated and prepared for the competition's presentation task. For us, the European Rover Challenge is the opportunity to work with passionate people from all backgrounds on a single project, and this is an amazing experience. Space exploration being one of the most ambitious endeavors of our time, we are extremely excited to participate in the challenge, which requires and allows us to develop intelligent systems that may serve as concept ideas for future space missions. In addition to that, the numerous management and organizational skills that come with the development of this multidisciplinary project prepare us every day for future professional careers, whether it is in the space industry or related domains. Let's now get into the technical aspect of the project. Rovers are complex robotic systems, and as such, they rely on numerous electrical components functioning under specific power needs. To ensure the safety of our Astra rover, we designed a safety circuit entirely made of commercial off-the-shelf components. The power, drawn from the batteries, has to go through a battery management system before entering the safety circuit made of a circuit breaker, an automotive relay, and an emergency stop button. A student-designed power supply is then used to output the proper voltages through the electronic systems.
This year, we decided to go for a design with 4 drivable wheels to increase the mobility and smoothen the control of the rover. It can move forward, make turns, climb obstacles, rotate on itself, and go backwards. Thanks to the diameter of the wheels and the lightweight, the rover can cross obstacles of up to 15 centimeters high and engage in slopes of up to 25 degrees. There are 3 cameras on the chassis that help for manual control of the rover, and 2 on the handling device for that same purpose, as well as for AR tags detection during the maintenance task and the autonomous navigation task. In case of a dangerous problem, there is a safety off button in the back that will cut all power from electronic components and shut down the rover immediately. The rover is controlled with a gamepad programmed with 3 different modes, one for the manual navigation, one for the handling device direct kinematics, and one for the handling device inverse kinematics. To complete the navigation task, the rover will perform a mapping of the Mars yard in order to plan its path to attain its objective. For this, it will use several sensors, for example, the LiDAR, inertial measurement units, potentiometers on the chassis, and cameras for image analysis of the surroundings. The process is monitored on the control station. The desired goals are sent to the rover, which will try to reach them in order. It will then reply with the appropriate feedback upon success or failure.
A brand new 6 degrees of freedom robotic arm, along with an improved whipper, was designed and built by the team in order to resolve the challenge tasks. The arm, composed of a combination of machined metal, plastic parts, and an in-house custom-built carbon fiber structure, allows us to improve rigidity while minimizing the weight of the arm. This in turn enables us to have very high accuracy and precision in various control modes. We are currently implementing an inverse kinematics algorithm that allows us to very intuitively manipulate the end effector to a desired position and orientation. Furthermore, thanks to the use of multiple cameras on the arm, our detection software is capable of detecting the AR tags present on the control panel and the surrounding objects, making it capable of autonomously interacting with the control panel elements. The arm is capable of performing all necessary tasks, such as pressing buttons and switches, plugging in Ethernet ports, and measuring voltage from a power source. The modularity of Agrippa makes it possible for us to easily swap its configuration based on the necessary task at hand. The specially designed scoops can manipulate the probes, with the arm capable of picking them up from our onboard container, located at the back of the rover, and planting it at the desired location on the Mars yard, as well as collecting it later during the task. Finally, as part of the sampling and science tasks, the arm is also designed to perform surface sampling by collecting the soil and storing it in the system's science bay for further analysis. Once the soil is collected, the sampling tube is sealed and various measurements such as mass, volume, and humidity are performed in situ, helping us better understand the surrounding environment. In addition, thanks to our 6 onboard cameras, we are capable of efficiently exploring the terrain and observing interesting features, as well as taking pictures of sampling and probing locations and transmitting all the information to our control station in real time.
As for most rovers, Astra's main role is to perform scientific experiments in order to gain a better understanding of the environment. That's where the Science Bay comes in. By storing and studying soil samples retrieved from the Mars yard, our main objective is to find evidence of water presence on the terrain. This will allow us to form hypotheses on the past geological activity of the Mars yard and establish the viability of future Mars colonies. Another objective is to study the geological diversity of the land by observing the topology and by extracting soil at locations of interest. The Science Bay includes several onboard experiments which are all remotely semi-automated by the control station. Those experiments consist of humidity, particle size measurements, volume, mass, and density measurements, as well as color analysis. This data is measured using sensors and an onboard camera. Once the extracted soil sample is gathered by the aluminium alloy scoops attached to the handling device, it is then deposited into one of our 3 containers by passing through the remote control door and funnel. To limit any cross-contamination and spillage, we have developed a caching system that opens the container individually before sample acquisition and closes them after reception. By rotating the containers, we move them to different positions in the bay, such as soil reception, caching, and soil analysis. After the science task, the containers can be collected via the manual opening. By interpreting the gathered information, our geologists will formulate hypotheses on the water presence and geological diversity.
Project Red is a student team born in 2019 within the University of Modena and Reggio Emilia. This is our first year in the on-site competition, and in this video we will show you our rover Prosperous. We are a group of 60 students. Most of them are mechatronics engineers dealing with the mechanical and software design, but our team also involves management engineers for the business area, as well as geologists and chemists working on scientific analysis. Our team is supervised by 4 faculty advisors from our university, assisting us with both technical and bureaucratic aspects. Members are all divided into 5 divisions: business, robotics, mobility, science and systems, each one coordinated by a division leader, who plans the activities and supports members in technical aspects. We also have a team leader and a team manager, coordinating each division in order to design and develop the final product. The whole team is following the Agile methodology, based on frequent meetings and activity replanning, in order to be flexible and rapidly adapt to unforeseen circumstances. The team's main goal is to create an hub in the area for university students who are passionate about aerospace and robotics. Here students can practice collaboration and teamwork in order to take part in the European Rover Challenge. Working on a multidisciplinary and large-scale project such as this one gives students the opportunity to gain experience in fields of mechanical, electronic and control design, but also gives the possibility to practice transversal skills such as teamwork, collaboration and the ability to manage complex projects.
The safety system must disconnect the battery from the rest of the rover in emergency. To do this, you can press one of the 2 emergency buttons on the rover that allow you to switch off the power instantly via contactor, while to restart the rover you must first rotate the emergency button and then press the green star button. To protect the lines and the main components, we have put special blade fuses. Battery is also connected to a BMS, which has the purpose of protecting the battery from over voltage and over temperature and constantly monitors the main parameters: battery temperature, voltage of each cell, instantaneous current and the percentage of charge. These data can be derived via CAN or UART communication to then generate consumption reports. An additional safety system is given by the light tower, which indicates possible danger to humans. When a green color is on, it means that the rover is stationary, so you can get close. When a yellow light is on, it means that the rover is about to start up and will do so within the next 5 seconds, so you need to move away from the rover. Finally, if the red light is on, it means that the rover is moving, so you can't get close.
The rover control can be performed with a joystick or a keyboard, which communicate with the rover using a Wi-Fi network. We also implemented a low-frequency network, exploiting the LoRa protocol in order to provide a wide-range communication. Over this network, the rover will send telemetry data to be visualized on the ground station and simultaneously receive from us elementary commands to operate on the onboard systems. With this kind of commands, we implemented the activation of the probe deployment system for the probing task and the possibility to save pictures from the cameras for the science and probing collection task. Moreover, we also implemented security commands like resetting or powering on or off the main computational unit. To perform each task with the rover, a localization system is mandatory and it should be the most accurate possible. While performing each task, we won't have the possibility to visually drive the rover through the Mars yard. In addition, in the navigation task, we won't even receive a live feedback from the cameras mounted on board, so the position estimated from the computational unit is the only way for us to reach the points of interest. Our localization system is based on data coming from different sources, like the tracking camera and the visual odometry algorithm, which elaborates images and point clouds coming from the cameras to estimate the position of the rover. Moreover, a particle filter calculates the position from the detection and relative localization of landmarks placed in known positions. Finally, all this data is fused, exploiting a Kalman filter to have an overall pose estimation. Another fundamental feature is the obstacle detection, achieved through the elaboration of the received images. Exploiting the point cloud generated by the stereo camera, our algorithm is capable of detecting obstacles and areas with excessive slopes that we should avoid. To perform the probing task, we realized an easy and efficient system to release the probes. Each one is stored in an opposite slot inside the cache. A predefined signal is sent from the ground station or autonomously generated when the release point is reached, which activates the rotation, pushing one of the probes in a larger slot that makes it falling on the ground.
The task of the Science Division is the characterization of the landing site from a geological, geomorphological and chemical point of view, interpreting the origin of the landforms and their chronostratigraphy. The Science Division can prepare the laboratory test in the rover's internal laboratory and analyzes properties like grain size or the material of the terrain samples. In this way, with the support of photos taken during the traverse, we will be also able to set up scientific hypotheses on the nature of certain objects detected along the rover's path. In particular, we will analyze the landing site through aerial photographs in order to recognize the chronological succession of the geological events. After identifying landforms like dunes, canyons or big lava flows that can be obstacles for the rover, it will be easier to select the most suitable path. Moreover, the material of the terrains can be an important marker to underline the possibility to cover that path.
Here you're close to the most interesting tourist attractions. The land where Polish rulers and their families lived, and which 6,000 years ago was mined for precious flint. Today the mines are a UNESCO site. Wild nature is within your grasp, and active recreation routes stretch to the horizon. Nearby is a gem of Renaissance architecture. All that in one region. Come and see. Świętokrzyskie, close by.
Welcome back after a break at the European Rover Challenge 2022. Let's start the second part of the second day of the biggest robotic and space event in Europe. It's my pleasure to welcome Stefan de May from European Space Agency, who will join us online and tell us about the new generation of space stations. Stefan, can you hear us well? But we cannot hear you, I'm afraid. Can we do something with that? No, we still cannot hear you. You are unmuted, I guess, right?
I'm unmuted.
Oh,
yeah.
Now it's perfect. Thank you. So the virtual stage is yours. Thank you.
Thank you very much. I'm very pleased to get this opportunity to present actually what we will be doing in the future, in the near term, but also what we plan for the long term. And long term, I mean after 2030. I will try to share my screen. And I hope can you see my screen?
I guess.
Okay. I hear quite an echo as well. I'll try to ignore that. Right, I'll start talking already. So at the European Space Agency, we have a program for exploration, which is Terra Novae. We have 3 destinations: low Earth orbit, the Moon, and Mars. And our intention is to expand human presence in the solar system. For this, we have astronauts, and here you see a lineup of our astronauts who have been flying last year, Thomas Pesquet and Matthias Maurer. Currently, we have Samantha Cristoforetti on board the International Space Station, and Andreas Mogensen is our next in line. He will fly in 23 next year. This is our current class of astronauts, but we're already recruiting the next class, the class 22. And by the end of the year, we will recruit 4 to 6 new astronauts and also a pool of about 20 reserve astronauts that may fly in future. They fly to the International Space Station in low Earth orbit. In low Earth orbit, we want to stay there, therefore continuity. But we want to go further, and the ambition is to have the first European astronaut on the moon's surface by 2030. So that's a clear ambition set by the ESA Director General, with the vision, and that brings us to Mars, to have by the early 2040s Europeans on Mars. And then you see also a 4th box on the slide, inspiration, and that is something I will touch base on at the end of my presentation. It's about the question, how does it come that Europe has astronauts in space, but has not yet the capability of launching them ourselves? But let's start in low Earth orbit, 400 kilometers above the surface of Earth, so really not very far away. We are there in the International Space Station. We prepare exploration to the next destinations, Moon, Mars, in the International Space Station. But I would like to mention here as well that the space station is not the only low Earth orbit, low gravity facility. We have a lot of analog facilities on ground: sounding rockets, parabolic flight, drop towers, Antarctic missions, bed rest studies are some of the examples. The International Space Station is currently there, and we don't plan to give that up very soon. The operations are planned at least until 2030. The infrastructure has been built up over the past 20 years, And for the coming 10 years, 8 years, if you wish, we're upgrading our facilities, and especially also the Columbus laboratory, with new computer systems, new payloads, and new instruments. We already contributed to the space station. This is the big window cupola is a European-built infrastructure. We have a lot of outfitting equipment, freezers, life support systems, air quality monitoring systems. We have a robotic arm, very recently launched, and that's the European robotic arm. And we also started commercialization. And that brings me to the post-ISS area. Once ISS will not be there, the plan is not to have a space agency owned infrastructure anymore, like the International Space Station, but to allow industry to provide services in low Earth orbit to our needs. And to prepare industry for that, we already started a program with partnerships with industry. And currently we have 3 such partnerships on the International Space Station, where private companies are running a service, and anyone in Europe or in the world can go to that company and order a service to run experiments on the International Space Station without the need to pass through the agencies. Fully commercial. And then for the long term, after 2030, once the space station is not any longer there, we would like to have grown that small capability currently into a fully end-to-end commercial service. Obviously, this is a very big endeavor for the commercial parties, and probably Europe will not be able to do that on its own. In the United States, there are already quite some actors building on commercial stations. So what we also envisage is that there will be a close cooperation internationally between those commercial companies. The next destination is the moon. Sometimes we call it the 8th continent, and the surface of the moon, you can compare it to the surface of Africa. And I always say we've never discovered the moon, explored the moon, and I don't say we didn't went there. Apollo missions have been there, but we never explored. There are only a handful of people that have visited a handful of places, very limited on such a big continent. If you imagine 5 people visiting 5 spots in Africa, you don't have seen Africa. So we have all reasons to go back there. And the clear ambition of Europe, as I said, is to have a European on the surface by the end of this decade. How will we do that? The first step is the Orion capsule, Artemis missions from NASA. This is a capsule that will be launched on the SLS rocket and will bring astronauts in orbit around the moon. And what is fantastic in this system for Europe is that this time, contrary to Apollo, we are part of this endeavor. The Orion capsule is propelled into space by a European service module, powered also with the European solar panels, a life support system, everything the astronauts need to survive on their trip to the moon. Now, the trip to the moon is one thing, orbiting the moon is another thing, and the Artemis 1 mission that is currently planned to be launched probably at the end of this month now, will do an uncrewed test flight to then have in 24 a crewed test flight, and then the system will be operational. And then we need a destination. The surface is the destination, but to get there on a sustainable and regular basis, we also plan to build a small space station around the moon. And we call that space station the gateway, because it will be the gateway to the surface and possibly also to other destinations beyond the moon. And here again, fantastic for Europe is that we are fully part of this endeavor. More than 50% of the modules of that space station will be ESA or built by European companies. Because the first habitation module that will be launched, the American Halo module, actually is bought from a European company and actually built in Turin in Italy. ESA will contribute two modules, the International Habitation module, which is the biggest habitation module on that station, and also the Esprit module, and that's a module that has a refueling key, but also, for instance, a window, and that's a very interesting capability as well. I have a small animation showing how, I hope it starts playing. It doesn't want. Then we skip the animation and we go to post 2030. Going to the moon is one thing, to the surface is another thing, and our NASA colleagues in the Artemis program are already contracting SpaceX to bring the astronauts to the surface. But in this international campaign, Europe has also a vision to contribute, and our contribution we foresee is the Large Logistic Lander, EL3. We call it also the Argonaut. This is not a one-off mission, but a capability we plan to complement the Artemis missions for logistics, to serve the astronauts on the surface, obviously, to bring instruments, to bring infrastructure, energy. But at the same time, it's also a capability that allows Europe to take a leading role in self-standing European-led science missions. And on this visual here, you see a possible surface scenario where a lander is unloaded by the astronauts. You see a pressurized rover bringing the astronauts from the human landing site. And in the back, you see another lander who is doing some space resources processing, producing oxygen from lunar regolith. To explore the moon, to explore any destination, you need communication, you need navigation, and it happens that Europe is very strong in that area. So another option we have, and we're working on, is building a communication and navigation network around the moon. The first step is the Lunar Pathfinder, and that's a collaboration with, again, a private company in a partnership. And this Lunar Pathfinder is a satellite which will be launched in 2 years from now and will demonstrate and give the first communication services. And building on that, our plan, and that is something which will go to the Ministerial Council at the end of this year, we plan to have a constellation of communication and navigation satellites around the moon on a commercial basis to be provided to all international partners, commercial players traveling to the moon. And then that brings us to our last destination, Mars. Our vision for Mars is to continue what we are doing now, and that is the search for life. And at the same time, in our roadmap, we want to secure for Europe an independent access to the surface. We are already around Mars with our Trace-class orbiter. That's a satellite launched in 2016, scientific satellite. Does excellent science, sniffing the atmosphere for molecules that can have an indication of life, taking very high resolution images of the surface, looking for water, and already published a lot of scientific results which are helping us preparing the next steps. This is part of the ExoMars mission, and the second part of that mission is the ExoMars Rosalind Franklin rover. Now, you all know that this rover was planned to be launched actually around this time on a Russian rocket, and this is of course not possible anymore. We stopped that cooperation. But this shows that Europe is missing something. We have a fantastic rover with the best scientific capabilities. We would be able, as a first to drill 2 meters below the surface of Mars, with the only caveat that we're stuck on Earth because we're not capable of launching it. So that is something we want to avoid in the future. I will say a few words on that a bit later. What I can say is that we're working very hard to work out a proposal for our ESA member states to launch Rosalind Franklin on a different launcher with different partners. It's something we're working out now, and we will bring to the Ministerial Council for decision in November. It will mean that we will have to develop our own landing capability. That's very challenging, but it's something Europe needs to have, because otherwise we risk to end up in similar situations in the future again. While we're trying to have our Rosalind Franklin rover again on track, we're also working on the next real history-making science mission, and it's the NASA ESA Mars sample return campaign. Samples are currently collected by NASA, and to bring them back, we're building various systems, and ESA is contributing 2 elements: a sample transfer arm and the Earth return orbiter. The sample transfer arm is a 2.5 meter long robotic arm. It will land on Mars to retrieve the sample tubes that the NASA Perseverance rover is currently collecting from the surface. So we will identify, pick up, and transfer the tubes in the first rocket built by NASA to be fired off another planet. And that rocket from NASA will bring it from the Mars surface into Mars orbit. It's kind of football size sample container. You see it on this image. And here you see also the Earth return orbiter, who will go hundreds of kilometers from Earth, searching for that little object, sniff it up, and bring it back to Earth. This satellite is actually the biggest ever satellite going to Mars, and as a first, also the first one returning to Earth. And you see it has a very big solar panels, because it has 42 kilowatts needed for the thrusters bringing it back. And the way back is 4 days with 4 electric thrusters. The end goal is to fly to Mars with humans. Obviously, that's not for tomorrow. It's also not for 2030. But our aim now, we're working against, is the early 2040s. And obviously, that's a very big endeavor, which Europe will not do alone. We'll do it in partnership, like we have the partnership on the Artemis missions. But we have to look for a European contribution that makes sense, that is visible, that is meaningful, and of interest to us. And currently, what we envisage, building on our past experience with the shuttle flight, with Columbus Space Lab before that, with the gateway, all the habitation modules Europe is building, what we envisage is to build the Mars Transit Habitation Module. That is the module where the astronauts will be traveling in from Earth to Mars. And in the overall Mars surface scenario, we would then bring the astronauts to the Mars orbit, and then NASA will take them from Mars orbit to the surface. And that brings me to what I mentioned at the very start of my presentation. In all these exploration scenarios, Europe is lacking something, lacking autonomy to bring their own astronauts into orbit. If you would do a search on the internet on astronaut seats, you only have 3 options: the Crew Dragon, Orion, and very soon also the Starliner from Boeing. But why does Europe doesn't have it? Because imagine launching European astronauts on a European rocket from a European launch pad. That's one thing. And is it because we're not able? That's not true. European industry across Europe has been involved in space exploration for 20 years and has built the capabilities. It's just a matter of political will and opportunity to do it. We have the heritage. We have Ariane, we have the Vega rockets, we have had Space Lab, ATV, ISS, Columbus. We have our astronauts. We have ESA programs in space transportation. Space Rider will be flying very soon. We will have a new launcher, Ariane 6, Vega 6. We have Boost program, Prometheus. And then we have Terra Nova, our exploration program. We have the European service modules. We're building the gateway. We will have new astronauts, post-ISS LEO platforms. We have all elements to build on a new European project, which we call the Inspirator. And currently, this is not decided. This is a proposal to look into. And we're very fortunate that at the end of, in February this year, there was a European Space Summit led by President Macron from France, who have looked into this question, and they ordered a high-level advisory group to look into this and to report back at the end of 23 with their conclusions. So now at ESA, we're supporting this high-level advisory group to look into this question and to come with a proposal or a recommendation at the end of next year. So that's something we're really looking forward to work on, and hopefully we will be able to come with a very good proposal to the ministers so that they can consider it and take a decision for Europe. Because we think that exploration, I didn't put any slides on that, but exploration, it's not a nice to have. In the first place, exploration requires developing technologies in robotics, and obviously I don't need to explain robotics to the audience here, which are extremely relevant also for terrestrial applications. The technologies to survive in space, circular systems, recycling, are more than ever important on our planet as well. Energy solutions, they are more than ever important for citizens and for countries. And on top of all this, the inspiration and the outlook that exploration gives to this and the next generation, to give them a yes, we can mentality, and to have a bright outlook to the future, this is extremely important. And that's why we explore. And with this message, I would like to end my intervention here. Thank you very much.
Thank you, Stefan, for a very inspiring talk and sharing with us the plans and the future programs of European Space Agency and your view on the next space stations, as we say. So it was a pleasure to have you here in a virtual form, and hopefully to see you in person maybe next year on the next edition of European Rover Challenge. Thank you.
At your service. Thank you very much.
So now let's move smoothly to the debate that we are waiting. The debate that is entitled Art and Living in Space. So let me invite here on stage Professor Thais Russomano from Innova Space and Javier Rodriguez Gonzalez from CDTI Per Aspera, Mateusz Józefowicz from European Space Foundation, and also our guests joining us in a virtual form. So I have a bit longer list that we have here, but Dr. Dolly Daw from Food Design Lab, Dr. Nhi Shaw from working on space communication, Andrea Merlo from Thales Alenia Space, and Ben Haldeman from LifeShip. Did I miss someone? No, I think we are all here. So, yeah. So I was sitting at this side. So pleasure to Oh, maybe I'll just move it here a bit to make it more symmetric. It's a very interdisciplinary team that we are hosting now. Are we fine with the technical way? Everything? Can we discuss? Okay, I think we have some cameras issues, so okay, so we can start then. So some of you are already have been here at the stage. Those guys that we have online not, and also Mateusz was not here. But I wanted to ask all of you, just for a short, even those of you who already answered that question. So what's your connection to space, in the sense that, could you please introduce yourself and say in one sentence or two sentences, what happened that you are here, and what's your connection to space? So maybe we can start with Mateusz, since he haven't been talking before.
Thank you. Welcome. Very nice to meet you and to see you here. My name is Mateusz. I've been involved in organizing of robotics event and running a robotics company for some years. Generally, my background is not in engineering, but I'm a child of Star Wars generation. So and yeah, here we are. So I think this is very relevant to talk about art and space. They are interconnected. I'm not an active artist, but I always find it an important counterpart, and I'm happy that we are able to talk also about the more, not only about the hard technology, but also about art. It's interconnected. So yeah, but I'm running also space project, R&D space projects. So I think you can connect it.
Thank you.
My name is Thais Somano. I'm a medical doctor, so my connection with space is through medicine. So space medicine, space physiology, in academia, teaching, researching, publishing, and also in the private sector. Now I have a company called Innov Space that also does research, innovation, teaching, education, and outreach.
Javier?
Hi, hello everybody. I'm Javier Rodriguez. I work at CTI. That, for the people that don't know, is until the next year in 2023 that we are going to establish the Spanish Space Agency. CTI is doing like all the work that a normal space agency is doing. I'm an engineer, robotics and automation, but also I love art. So when I see the title of this debate was, okay, this is really interesting, something different that are going to be able to motivate. And I think that is something really, really nice to listen.
Thank you. So, and our guests online, Dolly, maybe?
Yes, thank you for the invitation. I can hear echo. Is my voice okay?
Yeah, we can hear you very well.
Great. So my connection to the space and art, I'm a food design expert. And I was introduced to the outer space actually by Thais, who are missing being in Poland with her and with Anna. And I'm also the chair of New Eating Habit at Cumulus Association, which is the largest design association for design education association in the world. So Thais invited me to actually publish a blog on her Innov Space business webpage titled Inhabiting the Red Planet. And from an interior design perspective and food design perspective, how would we inhabit Mars?
Yeah, maybe Neve.
So good morning. It's 4:30, 5:30 where I am, so excuse me if I'm a little bit boggle-eyed. Yeah, I'm an educator and communicator. I have a background in engineering and science, and I'm kind of on a sort of a lifelong experiment, and that's sort of the art of what I'm trying to do. I'm very interested in the stories we tell ourselves, and particularly for people who have a difficulty around science and STEM. So I've set myself a task to see if I can get to space to communicate it and also to educate on it. So that's one part in it. But then I have a company based at the International Space University in Strasbourg, which deals exclusively with communication and education around the topic of using space to engage people more in the subjects of science, technology, engineering, and maths. I really care about space, I always have, and just like Matthews, I'm a Star Wars baby, and I always found that there's something deeply philosophical about space. No matter who I speak to, whether it's a young child or an adult, I can always find a way in to bring the human aspect of space to them whenever we talk about what they believe the moon to represent, or maybe they saw a launch, or maybe they're a science fiction fan. So I think artistically, there's definitely an overlap between science and technology and art whenever we mention space to people.
Thank you. Andrea?
Hello everybody, Andrea Merlo from Thales Alenia Space Italia Turin plant. And well, I'm an engineer. I worked on most of the projects that were presented by Stefan a few minutes ago. And well, personally, I'm connected to art, so I'm very happy to be here and glad to be here. So thanks for the invitation.
Thank you. And Ben?
Hello, I'm Ben Haldeman. I'm founder of LifeShip. We're saving the DNA of all different species from Earth and humanity to send in capsules to, one's on the International Space Station, we're on 2 rockets to the moon, and the big vision is to send the code of Earth to the stars. And we're also saving a cultural archive of humanity, and that includes art and music and all the incredible things we humans create. So we're saving a forever record of Earth and humanity in space.
That's really a really wide range of interests of our speakers. Thank you. Well, one of the images that comes to many people's mind when we think about space is a pale blue dot. It's our planet seen from space, that if we go further, is just like a little dot. So we are talking here a lot about space explorations. Yesterday about Mars, today more about Moon, and we are coming closer and closer to our planet Earth. I wanted to ask an open question to all of you, how we can make living on the Earth better by using space exploration. So how space exploration can contribute to that, because it's all about Earth at the end, right? If any of you would like to answer, I'm happy to listen your answers.
Well, I can start then. In terms of my area, medicine and life science in general, everything that you learn outside, wherever you are, could be in Earth's orbit or on the moon, and one day maybe on Mars, it will for sure give us enough or more knowledge about humans here on Earth, and can help with our understanding of our physiology and diseases, clinical expression of diseases. On top of that, telemedicine did not start, it's very important to, to make it clear, did not start with the first flight to Gagarin in 1961. It was really boosted by that. It was very clear that in space we would need telemedicine. And here on Earth, we also need telemedicine, digital health, in many situations, in wars, in natural disasters, or even to help populations that live remotely, in poor conditions sometimes. So I think that there are the knowledge that can come from knowing more about human beings in a different environment, plus all the technology, medical devices or digital health, telemedicine that we develop to help these people in the exploration of space, and that can be transferred to Earth very easily.
Yeah, please. Andrea?
I think there is a huge possibility of technological transfer from space to ground. At the end, we have every day to face very difficult challenges with completely different means in space. So usually we resolve problems in a different way with respect to ground application. And this is why probably part of the technologies that we develop in space are will be very beneficial for ground. You know, even for life sustainability on a space station, we have to find, I would say, tricks to reuse everything and don't bust anything. So that is the main concept of creating a space station. So this is one of an example, but there are a lot of technologies that we develop for space that at the end they spin out to ground applications.
Please, Dolly.
I'll chime in. Oh, sorry. Were you going to say something, Dolly? Go ahead.
Thank you. I was actually going to talk about from an interior design point of view. So we've become like a consumer society where we consume without thinking about the purpose, about the size, about the planet Earth, whether it's furniture, it's food, architecture. So I think I was reading an article about IKEA and how they're adapting their furniture to fit on the on Mars. And I think there's a lesson to be learned there about adaptation, about purpose, downscaling our lives so we would not be using a lot of resources from Earth. Because IKEA has to do that in order to transport the furniture from Earth to Mars. Maybe we can start doing that on Earth before, learning our lesson of how we're going to live in Mars.
Yeah. I think for me, I'm going to take my headphones out because I can sort of hear myself. The big thing I think about space when we talk about the topic, it allows us a chance to look outside of ourselves, because I think as a species, we always think we're in charge or we're in control somehow, that, we're not on this planet it's orbiting about a star, and I think to have the ability to step back and reflect on that is important. And it's easy to say that when you're in the thick of the business, but for a lot of people who feel that science or space isn't for them, they don't get that moment to reflect. And I think when you see yourself differently and you develop a different relationship with the planet, which is where I think ultimately sustainability and taking responsibility for taking care of our planet really begins. So how do we get 8 billion people to see that perspective without them actually leaving Earth? Because I think if everybody saw what we hear astronauts describe as the overview effect, this moment when they see the Earth in its entirety for the very first time, that all of them talk about this seismic shift in perception about the bigger picture, about what it's all about. We are just one species on this beautiful planet that has given us everything we need, the oxygen that we breathe, the water that we drink, things that we completely take for granted. So if we can kind of see ourselves outside of that, I think we develop a much more nurturing and grateful relationship with the planet.
If I may, I totally agree. But if you live in a house and your roof is leaking, you do not fix it from inside. You have to go outside and to see the bigger picture. And I think that we are leaking, unfortunately, right now. Our roof is not really safe anymore. So we really have to look from the outside. But we can also have some good examples and lots of things to learn, not only about space resources, as we've been talking during this conference a lot. So not to gain new resources, but to learn to use the resources efficiently. We cannot learn it on Earth. We know that. We do not have enough discipline to build a fully closed circuit economy on Earth, because there are always connections to other ecosystems, and it's interconnected. If you go to space and try to build a self-sustainable habitation system or any closed circuit system, this is the only way to survive there. So we can learn, and we can either move to other planets in a better model, or just transfer it back to Earth. For hopefully it can be adapted to our problems.
So if we smoothly move to the theme, the topic of art, so we can easily imagine that art benefits from space and from space exploration. So we have a lot of inspirations coming from space, pictures and everything coming to art. How does it work, in your opinion, otherwise? So can art contribute to new discoveries? Can it inspire the discoveries, especially in terms of space exploration?
I can start again.
Yeah, please.
So I love art in general. You know, all expressions of art, from dance to music to paintings and sculptures and so on. So I was connecting, let's say, space with art for the first time in my life when I was invited to give a module about space and design in a university in Finland, Aalto University. And my goal there was to show how much our art and design and architecture and so on are really based on gravity. You know, we do everything, we design everything here. A chair, a sofa, anything is based on gravity. And my goal there was to break this idea from the students' mind. They were artists and designers, much better than me for sure. And then the idea was to exercise how we can create some objects or furniture or anything, in fact, that can be used in space without gravity or with less gravity and so on. So if you look at paintings, for example, the way that you start painting something it follows gravity. Everything somehow is dictated by gravity. We take it for granted. It designs us, our mind, and our art. So I think that for this new moment that we are having, space tourism with new space stations, hotels, and so on, possibly a habitat on the moon very soon, and then one day on Mars, we are going to need this adaptation, let's say, of art, these new expressions of art. And then I went further, and I have a colleague in Finland, and he used his skills, his math, his very advanced math, to take the sound of a star, of the magnitude of the light of a star. And then he sent that to me, and we, with colleagues from the area of art and artists, we created, let's say, an expression, a dance for that stellar music. So I think that there is a huge relationship that can be expressed in many different ways for art, design, architecture, and related fields. And thanks to that, Anna, here present, and Dolly, not here present, but virtually here present, and a friend of us from Finland, Eija, we have a group, a working group called Space Art, Design, and Architecture under Innov Space that promotes this type of discussion and different artistic expression, let's say.
That's cool. Thank you.
Okay, if I can. Sure. If we understand if are going to improve exploration in the way of science, I don't think so. But one thing that is clear is when we arrive to Mars, for example, we are going to be in a really hostile environment, and art could help a lot to make us part of us and make us easier to live there and survive. For example, in the ESA, they have been doing projects with the rovers to do like kind of Zen garden. that at the end was similar to the to Mars surface. Is if we use art to create something that will making us feeling like we are at home when we are on Mars and we as part of the planet, will be much more easy to live there. And also, art in general is exploding the creativity, is helping us to express the feelings. So also all the music, the painting is helping our mind to overpass a little bit all the problem that we have with the insulation. So that's the point that I see the art for the exploration, because at the end it's helping us to live better and make like Mars or the place that we are going to be able to live comfortable there and suffer less all the problem that we will have from insulation to being an hostile planet and all this point.
Yeah, please. Maybe you can start with Ben. Yeah.
Yeah. So space is a domain of dreamers, of imagination, of wonder, of awe, and art brings all that to life. It brings the power of creation into a person's hands, and the power of an imagination, and so it brings this futuristic, disconnected, far away, immense thing to life, and it also connects a person to their dreams and connects to an inspiring future. And so art really connects people with space and brings out people's imagination and brings it to life.
Please, Dolly.
To me, I think art is connected to architecture, of course, and to design. And as a designer, life without art would be boring, of course. Especially if we're going to start a new colony on Mars, we have to start with the process of creativity, which is about experimentation and which allows us to expand our way of thinking our lives. I bring like one example by Hugh Barrington Architects, and who basically collaborated with local artists to create this inflated Martian house in Bristol. And it's an experimentation about inhabiting Mars. So they have hydroponic plants, they have experimentation living. But I can't imagine architecture doing this on its own without collaborating with artists to bring in the creativity of experimentation and experimental living, really. And this is the time to do it in Mars. And I do apologize if I'm sounding really robotic for the thing. It's just that I've got a delay in the voice, so that's why my speech is a bit delayed.
Oh, but we can hear you very well here. Andrea wanted to add something, right?
Yeah. So to me, the idea is art is thinking out of the box, while engineering is really try to find a solution to a problem. So sometimes when you have a problem that is too difficult, engineers cannot solve it because you really have to think out of the box. So sometimes you see scientific exploration mission in which there are ideas that are just crazy, and they come from a completely different environment with respect to the engineering and the people who use to work in space. So this is to me the main benefit that you can get from a different, I would say, discipline to the engineering world.
Please, Neve.
And if there's time, I think it's a really interesting question, because there was a time when there was very little distinction made between art and science. If we go back to Greek and Roman times where we sat around and we discussed philosophy and science in the same room at the same time. The Renaissance occurred because, around Paris, scientists and philosophers and artists were meeting and discussing together, and they were all inspiring each other. And so I think art inspires science, and science also inspires art. If you look at the movie 2001: A Space Odyssey, I mean, that's a perfect example of, you've Arthur C. Clarke writing and bringing in his scientific expertise about space, and you've got Stanley Kubrick at the same time imagining, but both of them actually inspiring each other. And the book was being written while the movie was being made. So we all have the capacity to be creative and artistic and scientific and logical. And I think something has changed in the last kind of couple of 100 years where people try to box you in and say you are one or you are the other. And that has led to some idea that innovation isn't creative, design isn't creative, it's not art. I think all art and all good art is where you take two types of thought or a number of types of thought and you present them in a new way, and in a way that makes complete sense to us because it's filtered and it's really clear. But isn't that a really good idea? Isn't that like a really successful mission or a really beautiful robot or whatever? So art is constantly contributing to science, but it's manifesting itself as an engineer who comes up with an amazing new concept, or as an architect who comes up with a fabulous new habitat, or somebody who designs something completely off the cuff from something that they're reading or that they're watching or that they're having a conversation with. So I think the sooner we bring these two worlds closer together and just let them be and let them coalesce, I think the more we will just naturally go back to this idea that philosophy, art, science, that it's all creative, it's all about curiosity, and it's all about coming up with new ideas. So always art inspires science and science inspires art, in my opinion.
And I think that sometimes I completely agree. Oh, thank you very much. I think that it is nowadays we can see the evolution of that. Now, I think that it was very well said that art and science were together in the past. And it's evolving somehow nowadays to artificial intelligence creation of, for example, Mars habitats. So you have the technology, you have the science, and you have this artistic representation that in the past was basically given by, we still know artists designing something, an artistic representation of habitat on Mars. And now you have the software, sophisticated softwares with the artificial intelligence that can create and express very colorful, very sophisticated, very creative habitats on Mars that might serve science in terms of, let's say, as an example, as a suggestion of what we could have or can have on Mars one day.
One type of art is actually picturing of the discoveries and picturing of the reality that is created by engineers or by scientists. And this has always been connected to space as an outreach tool, but also we even know Alan Bean, who was an astronaut that became a painter. From Apollo program, and we have two hemispheres of a brain, and the best results if we use them both, so the artistic and the realistic. So it's just the trick to learn this balance and to optimize. But anyway, an artist can create a reality, a space reality or Earth reality in apparently easier way, not necessarily that easy. They wouldn't agree probably. It's pains, but it appears that they can create it individually, while engineers always have to work in a team. It's a team effort. It's embodiment of this vision. But in fact, if you look at our last 100 or so years, all the inventions and all this technological stuff that we are using today has not been invented by engineers. It has been invented by writers, actually. So they are the first seed, and if they've written it a bit differently, the soil, so the stuff, the pool of the ideas that the scientists and engineers draw would be a bit different, because I guess it's not the only way. So we have different paths, and the artists always are able to show the path and inspire, and then it becomes natural. So they are a part of a process, I would say.
And on top of that, I think that we have to agree that the spacesuits have evolved with this combination of engineering, technology, and designers. No, because if you look at the spacesuits nowadays of SpaceX, for example, crew, it looks much better. No? It has a better appealing to the eyes, and it's now technology, science, and art working together again. Design working together. No.
Also, same with the capsules, right? And
same with the capsules, and of course, yeah, it's the environment itself is much better now. No, it is. It evolved, of course, for many different reasons, but even the design of the environment, and it affects the person. I think that it was shown here just before this session, the cupola of the ISS, which is a place where you can go there and have your moment of privacy and take pictures of Earth and listen to music. So, and it was basically designed for that. You know? So you have 6 windows there facing Earth. So it is, I like very much this very inter and multidisciplinary approach of human space exploration, and art, design, architecture definitely must be included there.
Please, Deli.
I 100% agree with Thijs. I mean, the perfect example is we're talking about engineering. The helicopter was invented by the United Nations. And we can't talk about inhabitation without talking about the human body and the anatomy and the art of living, the philosophy of actually living on the red planet, on Mars, without thinking about gravity, about architecture, how we're going to build the structures, how we're going to sleep, how we're going to move. And a perfect example of this collaboration is what we're doing with Thijs, for example, Anna and Oya. This combination of design and science, where I'm thinking kind of about interior design, about food design, and then Thijs is thinking about anatomy, and Anna is thinking about the outer space, the mission, all that. So we live an example of our business.
So if we think a bit more about the future, we talked about art, and we know art is more and more, even nowadays, it's somehow connected also to artificial intelligence. And we see many aspects of using artificial intelligence in space exploration. So in your opinion, or in the background that you have in the field of your expertise, how the AI will change the space exploration, and where are the borders also?
I think that we are going to rely a lot on AI in terms of for medical care and monitorization of the health of astronauts, their well-being. I think that it is mandatory to have very sophisticated AI there with lots of medical knowledge, because we need to make the crew very autonomous in terms of many aspects, but especially healthcare. If we go to Mars one day, we discussed that in this meeting before, but we are going to have a delay in communication that could range from 3 minutes each way to about 24 minutes each way, plus all the other aspects related to not just communication, but to the delivery of healthcare in a very, in another world, in another planet. So I believe that for the exploration of space, human exploration of space, AI will be it will be our ally. It will be very important for prevention of diseases, treatment of diseases, incidents, accidents, and things related to the environment of the habitat or the spacecraft. So I think that is very, very, very important.
Okay, if I can say something. In the future, artificial intelligence are going to be everywhere. It's true that the main part are going to be in all the operation that could be in danger for the humans. So that will be done by artificial intelligence. But also now we are already using artificial intelligence for all the training of many expert systems to analyze many of the information and the data that we are receiving. Already for Mars, like we have this big communication delay, the rovers are using artificial intelligence to avoid all the obstacles. Also, like we cannot have the operator always supervising the rover, we have also investigating opportunistic science, that is autonomously the rover are going to take picture of the interesting rock. Analysis could be interesting from the scientific point of view, and if it's interesting, they will send the picture to the command center, but are going to be everywhere. Also, for example, now that we are analyzing all the debris around Earth, soon all the satellites will be able to autonomously avoid all the debris. Also, for managing this big constellation that we have now, all the operation that the positioning between the different satellites all will be done by artificial intelligence, analyzing all the information that we have from Earth observation, all is artificial intelligence. So artificial intelligence are going to be everywhere in the future.
Andrea?
Yeah, I think Javier got the point, because at the end, this is what is growing as a complete revolution on Earth. So we are slowly accepting the role of the artificial intelligence in our world. And as soon as we will be ready to accept it, something that is a computer that thinks like us and decide instead of us, then it will be the big change and boost both on ground and on space. We already see easy things. There is a ramp up. As I said, in space, there is, let's say, a sort of autonomy that is easy autonomy that is implemented by rover spacecraft because of delays that we cannot overcome, and so we cannot operate. But that is just the first seed of the artificial intelligence. And on Earth is already growing, like, for example, the Google car, just to take an example, or the metro that is going autonomously down our cities. So it's growing, and it's probably going to be the big element of revolution in the next 20 years.
But that doesn't necessarily mean it's all good, right? So I'm going to throw a spanner into the works, because this is where I feel like where art can really help people understand the potency of something like artificial intelligence. As an educator and a communicator, I love space, absolutely love space, but sometimes things happen at a pace that the everyday person just can't keep up with. So if we have a society in 10, 20 years' time who don't fully understand the power and the potency of something like artificial intelligence, and don't really understand the reasons behind why it's being used, we're kind of going to be in a position where, you know, there's a saying in English, you know, the tail is wagging the dog, you know. So it's not my area of expertise, but I'm always, when I hear about artificial intelligence, I'm always a little bit cautious about its use, because it's so powerful. When we set it free, we have to be sure that we understand the parameters of what we're using it for, and that we have a say ethically in where it goes moving forward, because it can have profound effect on us as a species. So it's like, for me to feel to feel comfortable about artificial intelligence, I feel like 8 billion people have to understand what it's about. And it goes back to me, to the point of education and why I do what I do. So we just have to be really, really careful when we talk about artificial intelligence, and that we have to always make sure that we're in charge, because it is, you saw there a few weeks ago on Twitter, I think it was an employee from Google left because he realized that this computer that he was working on was sentient. This artificial intelligence system was sentient. So what does that say? And when you look at movies like Her, which I absolutely love with Joaquin Phoenix, what's to say that we don't get to that point where we create almost another species of computer systems who feel and who think and who have a consciousness? We look at science fiction movies, we look at like Blade Runner, which is essentially that whole notion, like, with replicants who have souls or who feel they have souls, and robots, even today's robot challenge, so where is the line? And so the future of AI is extremely potent, but without an engaged society that really understands the technology and of where we're going and what we aspire to be, we need to be really careful. That would be my take on it.
We have recently seen that AI can be a good artist as well, because of the music or painting that is being created or co-created by AI. But this art is indeed different. There is certain feeling in reception that makes the audience feel that it's not been created by a human, and this is really interesting. For now, it's only very synthetic, but in the future, it may become perfect. But speaking of AI's role in space exploration, every decent spaceship has a hull on board or mother, and so there is this overseeing system that is intelligent. Except Dune, where they actually expelled all the computers. So there are two visions. I think that the vision of Dune is more utopian, because we cannot I cannot see how it can be expelled, and this is a danger right now, because even very simple systems can be considered intelligent to some extent, or leading to intelligence if they grow or become dispersed. So the line between intelligent and non-intelligent system is not clear, and we have to be careful. Indeed, I agree.
So, oh yeah, Ben.
Yeah, AI is a huge accelerator, and it'll accelerate our ability to care for our planet. And it'll accelerate our ability to spread life and consciousness in the galaxy. And I believe those are two of the big roles of humanity and our prodigy, which is likely AI, which follows us. And so I think there are huge consequences and tremendous challenges and tremendous ethical questions, and I feel AI can be a huge accelerator in doing good and expanding us outwards.
So, taking all of the things that we talked about into account, how, in your opinion, the world will look like in 50 years? Our Earth and things which are going on around the Earth and a bit further. So in 2072, you wake up and what?
I won't wake up because I'll be dead in 50 years' time. But I believe that it's very difficult to predict now. I mean, that I don't know if 50 years ago someone could predict what is happening now. So it's very hypothetical. But let's say ideally we are a more, let's say, peaceful world, more mature as society, more civilized. Maybe that's a huge dream. And I believe that we will be living and exploring the moon for sure, possibly Mars, and we will become more like a cosmic species. But I don't think that we should be really very proud of our civilization now. I think that we have lots of very, I would call, I don't know if the right word, but still very primitive type of issues. So with all this technology that we are discussing, exploration of space and AI and so on and so forth, and we are still very, in terms of society, in terms of organization and society, we are still very primitive in many aspects. And so it's very difficult to say. I hope we are still here on Earth in terms. I won't see it, as I said, but I hope that for the young generation that's here present, that you'll be old by then. Believe me, it's going to pass. Life is going to pass, and I hope you will have a better Earth to live on.
Please, Dolly.
Yeah, I do agree with Thais. I think the way that the civilization is going, I would like to be optimistic about the future, but if we keep going like this, I don't think we're going to have much of a healthy Earth. Having said that, I know that probably in about 2 or 3 years there are missions to be sending humans to settle on Mars, and architects have been already, commissioned to design habitat the Martian homes, if you like. So we will have 2 planets to inhabit in about 50 years' time, but it's very difficult to see what the state of the two planets will be. So I do hope that we will not repeat the same mistakes we've done on Earth. We'll repeat them. We'll take our problems with us and our mistakes to us.
Okay, for sure. It's really difficult to imagine how are going to be life in 15 years, and probably we are not going to be. All the Star Wars generation are not going to be alive, but also is not. I will say, life in 50 years are not going as we are thinking. Are going to be as the young generation are thinking. Luckily, she was saying that the society is still primitive. I will say that we have failed. If we see the Earth now, there is many problems everywhere. But luckily, the young generation, they are growing and studying, knowing all the things that we have done wrong. So I would like to hope that in 50 years, they will create an Earth that is worth living, that will solve all the problems, that there are going to be a balance, and we are not going to destroy the Earth. We are going to be still there, and we are not need to escape to moon of Mars to anything, because still we can solve all the problem, and I hope that the new generation will be able to create the solution that we need.
After listening to this wonderful discussion, I kind of feel optimistic. Despite the problems, I think that we as a space community or technological community are in the best possible moment. Because when space becomes routine in 50 years, it may happen that it will be consumed by those primitive problems that we have in our daily lives. So I hope that we can prevent it and keep the frontier vivid at all time. But I think that still, like we want to have a beautiful car today or a nice car, we want to have a beautiful spaceship. So the aesthetics and design will be the part of the game, not only the efficiency. This is of course, art, but this also brings some differences in status and things that are unnecessary, just to that we will be spending money not for exploring and technology, but for making our life in space more easy or lazier. These are the things that can happen. I don't know if this is gonna happen, but there is a danger that it can happen. But anyway, right now I think we are at the best moment where we can shape, and we have the problem, but we have also opportunity to solve it, and this is the opportunity to make it right this time.
I think we're at a stage. We just heard the previous presentation about ESA's plans and us having a European astronaut on the moon. That will definitely, all things going well, happen in the next 50 years. And if we think about how so many people were inspired by the first time we saw humans on the moon, I would hope that would help people see ourselves as a species differently. I think certainly having the first woman on the moon finally as a woman is something that gives me a great sense of hope for the next generation of women that come behind us. 50 years isn't a very long time in terms of space exploration, but I hope from my own personal priorities, I hope that thanks to space and thanks to these constellations of satellites, that maybe education will be more equal. Maybe we will have a society that is more equitable, where there is a better sharing of information and education, and that people are more engaged in science and art around the world, and that as a consequence of that we develop a better relationship with our planet, that we can take better care of it. But I am an optimist and it is what fuels me. So I think that's quite ideological of me, but I hope that we will achieve maybe even 25% of that wish list in the next 50 years.
We live in such an incredible moment, such an incredible decade, and the next 50 years are exponential. And we have so many visionaries that are building incredible technologies that will have global impact on all the challenges on Earth, on the democratic systems, on governance, on how we care for each other. And we live in this massive awakening of people coming into their hearts and learning to care for each other and for our planet. And then the space technologies are exponential and just about to enable a multi-planetary civilization. And so all this will happen quicker than we can imagine. We're rebirthing our new planetary civilization, and we're on our way to be an incredible galactic species and galactic civilization, and care for Earth and spread life in the universe.
So, thank you. Well, it's super exciting to discuss with you all these topics, and especially if we have some young people also here in the audience and watching our broadcast live, although the time is running and this is something that we cannot overcome yet. So thank you very much for the discussion, and thank you for joining us from many time zones that we represent here. So we wish you a fruitful day or night or afternoon, and we get back to our Rover challenge here in Kielce, Poland, and sending you a lot of greetings. Thank you.
Here you're close to the most interesting tourist attractions. The land where Polish rulers and their families lived, and which 6,000 years ago was mined for precious flint. Today the mines are a UNESCO site. Wild nature is within your grasp, and active recreation routes stretch to the horizon. Nearby is a gem of Renaissance architecture. All that in one region. Come and see. Świętokrzyskie, close by. Here is where big business happens. Nearby, professional science and research facilities continue to grow. Well-educated staff is easily available. Nearby, you can take care of your health and restore your vital powers. Just a step away from active tourism destinations and the oldest mountain range in Europe, the Świętokrzyskie Mountains. All that in one region.
Okay, well, thank you very much for that introduction about the topic today. We are going to talk about careers in space. And as you've heard from Maria Antonietta earlier, there are many options for careers in space. And to talk further about that topic, we have with us here one of our keynote speakers. So thank you, Artemis, for joining us. We've been talking about careers in space with the teams, with some of the specialists. There doesn't seem any better time in space for careers in space than now. What is your opinion on that?
Oh, that's certainly true. I mean, and the thing is also what people need to remember, if you want to build rockets, then yeah, being a rocket engineer is probably a good idea. But if you want to be in space, then actually you could be a secretary, you could be an historian like I am, you could be an instrument maker, fine mechanics, a lawyer. We need lawyers too, not just space law, just, contract lawyers. And, maintenance people for the buildings that we're working in. There's so many things different than just being a rocket engineer. And all these jobs are there to be had. As far as I can tell, the space industry is booming all over Europe. And probably all over the world.
Is that the same in every country in the world?
Well, what I see is that almost all countries trying to, grab hold of this new economy. And so whether you're Luxembourg or Portugal or, Spain or Italy, whether you're big or small, Poland as well, you try to be part of this. And so, yes, there are jobs everywhere.
Very good. And as you say, we need people from any background because really space is maybe less romantic than what people imagine it to be, that if you can't be an astronaut, that everybody in space is an astronaut. But space is, in essence, a business as any other business, isn't it?
Well, in the essence, yes, but with the nice bonus that you actually will be meeting astronauts. I can vouch for that. You might not be an astronaut yourself, but you will meet the people that are doing that. And you'll find most of them very nice.
And it's true because the space industry, at least as it is right now, is still relatively small compared to many other industries. So it is a bit like a family, isn't it?
It is, and it always, it shows today. You meet many people from which you've met someplace else, and sometimes I have to think, who are you, because of that. But yes, it's a small group. And it also means that if you are in the space industry in this company and you want to have a career move and it isn't possible in this company, there very probably is someone in another company and you will know people in that company. So, hopping to a new career, hopping to, the next level is possible. So there is not just, a job. There is a career path possible.
That's very true. I mean, I know that, you know that, many people in the industry know that. But it always helps to prepare yourself for a career in space. What can students or even pupils in primary and secondary education do to prepare themselves for that career?
Well, what I would say is follow what's happening. And again, you don't need to be able to build that rocket, but at least know that the rockets are built, know what type of rockets there are, know what type of missions are flying, know what we're doing with satellites around Earth. Because it isn't just space exploration to Venus or Mars or Jupiter. It's also all these small and big, satellites that we're building that might be just helping us to grow food.
True, and we do focus a lot in this perspective, again, on the romantic side of space, which is the rockets, the satellites, the hardware. But is that really where most of the jobs are?
I would think not. And, to be honest, I think it's pretty romantic to be able to pinpoint where the pirate ships are if you're a ship's captain somewhere, around Africa. And there are many other uses that I think are pretty nifty, even isn't, these big missions to Mars.
So working with satellite data is probably an even bigger industry than building rockets.
Yeah, and again, then you could be just an app builder. Because, we in Europe...
I wouldn't know how to do that.
No, but I mean that you don't need to be a mechanical engineer. You could be just good at software because, Europe, we are providing the satellites with all the data, which are for free for anyone on this planet. And if you can develop an app that will help the farmer or the fisherman to find the fish and the farmer to know how much water to give its plants, then, you're in business.
So really what you're saying is there's not just opportunities for people who are looking for a job, but also for aspiring entrepreneurs.
Absolutely. You've seen many, and to be honest, the European Space Agency, but also universities will help you with business incubation centers. So, even if you might have a good idea, but for the rest have not a good idea how to build a company, they will help you with that.
Well, that's a good thing, I guess, about the space sector, is there is a lot of help for aspiring entrepreneurs, especially those working with data to provide those, or to develop those applications for use here on Earth, because most of the money that is spent in the industry is not really spent up there.
No, it's salaries. It's salary cost compared to how much the salaries were to build the thing. It's salaries.
Exactly. So all the money spent in the space industry is actually spent on one planet only, isn't it?
Yes, exactly. That's one of the reasons why Noordwijk is very happy with Aztec, because all the people working there are getting their vegetables around the area.
Yeah, exactly. So in that sense, space is like any other business. It is part of the local communities where they are. There are space campuses all around the world where people live and people work. So again, coming back to my question about how young people can prepare for a career in space, having an interest in space and following what's going on is one thing, but can they take a more active approach as well?
Yeah, well, I bet wherever you live, there must be space societies, whatever their name is. Become a member, a youth member, a member. Go to the space museums, read up on it, and join our family of space jobs.
Exactly, and that family is available from young ages onwards. There for
Absolutely.
students, there is our organizations like US and UK in India, Sept. There's the Space Generation Advisory Council. There's loads of organizations for young people to get introduced to the industry and find things like mentors.
Oh yes, and the nice thing about a small industry, because space industry is, like you said, still a small family, is that we are willing to give you a leg up. Because we do believe that when we old geezers are going to retire, we need you to take over. So please come and join us, and we will help you get on your career path.
Didn't Joseph Aschbacher, the Director General of ESA, say recently that a quarter of the European Space Agency workforce is retiring in the next 4 years? So, yeah, lots of people need it.
Yes.
Absolutely. A question specifically I know you're interested in. Are these opportunities equally distributed?
Oh yes, I believe that if I look into space industry, more and more in Europe, I find, there's like at least 40% of the workforce is females now. And the same, by the way, in many of the fields that you can study, whether that's fine mechanics or aerojet, rockets, same thing. You can get there and you won't be the only women doing it. So yes, there is equal opportunity. And of course there is. I mean, it's European money, it's tax money. I think we all have laws that say there should be equal opportunity.
Yeah. We talk about Europe, but how about other parts of the world? How about our viewers in Latin America, in Africa, in Asia perhaps? How are their chances? What can they do to find themselves a space?
There is this hubris, this idea that we in the Western world, and now I'm saying Canada, America, Europe, are, the leaders. I wonder. One, if I look at India and all the young people that come from their schools and universities, certainly not. If I look at Africa, how many new businesses that are in space, how many countries in Africa are now realizing there's a job opportunity there, there's an economic growth opportunity there. Same in South America. So thinking that this is only possible when you move to France, no. Okay. Stay where you are and help your government build your space industry.
I think that's a very powerful message, and especially in the entrepreneurial area, now that space technology has become so accessible, that space data has become so accessible, these opportunities are much better now than they were 10 years ago.
Absolutely. And like I said, governments realize that. And governments also realize that from space industry comes innovation for all the rest of the industry. Because it's not contained. It's not because we learn how to do something really nifty and difficult in space that we will not tell the rest of the industry. On the contrary, we will sell or we will give away those ideas to the rest of the industry to make sure that our society as a whole, modernizes, innovates. So, yeah, definitely.
Exactly. So, chances for everyone in this exciting world of space, really, whether you're looking for a job, whether you're looking for an opportunity to build a business, whether you're looking to study something in space, there are opportunities for everyone.
And there's one thing I would like to add. I cannot predict what job will be available or what kind of job will be needed 10 years from now. So if you're studying something that you think has nothing to do with space, check again and check again if you want to invest in this part of your career. You might find out that 10 years from now, you're actually needed.
Exactly. Well, let's close with that statement and let's move on to the next section of our little intermezzo here. So thank you very much, Artemis, for your insights. And we will be seeing you later around the European Rover Challenge.
Definitely.
Again, if you want to follow the story of the European Rover Challenge, of course, watch this live stream, but also follow us on all social media channels under hashtag ERC2022. So right now, we're joined by Emilia here.
Nice to meet you.
Thank you for joining us. Let's talk about your role. You're wearing the ERC uniform, so tell us a little bit about your role.
I'm a judge on the ERC Rover competition, and my main task actually up to now was navigation task. So all of the teams needed to reach 4 points which they've been assigned to them before the task. So then they could prepare for it. They got the GPS coordinates before, but during the navigation task itself, they couldn't use them anymore. So it was about all of the sensors that they could also only read the tags that were on the field, and by that they needed to reach. Most of the teams tried autonomy, and then they tried to reach only autonomously these points.
Okay.
It was really interesting.
So how do you judge that? How can the team score points in this navigation challenge?
Yeah. So in navigation, it's you get points. As many points as close are you to the designated point. That's one thing. So basically, the closer you are, the more points. Then if you do it autonomously, you get another point. And then if you actually prepare before a plan, how you're planning to do it, and then you really execute it properly, as you really plan it. So we check if you actually know what you're doing or you're just randomly driving around the Mars yard.
Okay, so sticking to your plan is really
exactly.
what you're looking for. Okay, well, thank you for that. Let's look a little bit about your background. You're here as a judge, but you also work in the space industry, don't you? Tell us a little bit about your background.
Yes, so at the moment I'm working AVS UK, and my actually main task at the moment is ISRO-related project, which was related more to another task on URC, so more like excavation of the regolith, but unfortunately not on Mars, but on Moon.
Well, unfortunately.
That's close enough, let's put it this way, as to be a judge in the competition. So my main task recently was just to design the scope to basically accumulate the regolith from the Moon, and then so it's being sieved. So all of the large particles leave on the Moon, and only we can take smaller ones. And then the whole subsystem transports it. There are a lot of processes which happen, but ultimately you want to get oxygen actually out of it.
Okay. Oh, that's interesting. But you used a few acronyms, and we have lots of acronyms in this.
Okay.
You say ISRO.
Yes.
What's ISRO?
ISRO's in situ research, in principle, so all of the excavation all of the working with regolith on Mars as well. So all of these activities which are somehow related.
And that's the other difficult word. What is regolith?
That's all of the ground, if you can call it this way, on the moon or on Mars, on another celestial bodies.
So it's basically the sand and dust. The surface of the planet is called regolith.
Can be also stones, actually, because that also, although this we might call more like a gravel, but in principle it also is similar, composition as.
Okay, so you're basically designing a scoop to scoop up the surface of the moon in this case.
Yes.
What project are you working on? Because you say you work for AVS UK, but what is AVS UK involved in?
AVS UK actually main occupation is doing a lot of propulsion-related activities. So a lot of electric thrusters, mostly small ones, so mostly for CubeSat. But another thing is, for example, I'm also working on the thruster pointing mechanism. So basically very, very small mechanism which will just point the thruster in order to keep well orbit and all of these maneuvers when you're on.
So you work on lots of cool stuff. You work on thrusters, you work on scoops, on the moon.
That's that's the benefit of working in a small company. If you're in a big company, you just do very small thing, and if you like more smaller, you need to be able to do a lot of interesting stuff.
Okay, so tell us a little bit about your path towards this job. How did you end up in the space sector? Why did you end up in the space sector?
I mean, I've been actually one of the students on this competition when I was at university.
Seriously?
So when I was in Ska Robotics. In fact, I was the coordinator of Ska Robotics. So
from the Warsaw...
from University of Technology, yes. Yeah. So I was at the time when we actually set up the Ska Robotics. We were one of the first teams in European Rover competition, so that was one of the things. Then I actually worked a bit in Central Poland as a student. Then I've been in mechanism section in ESA. And then I moved to UK and been in Storage Space Center, worked on some isolation systems, and now I'm in AVS UK.
Okay, wow, that's a real cool story.
Very different things. But
and again, it is something that I think is interesting for our audience, that if you participate in this Rover Challenge, it really is a very good preparation for a career in space. So
actually, I'm basing a lot of my ideas, what I'm doing now about ISRO, so about the scoop, what I was doing as a student working in this competition. So I think that's really cool.
Yes, really. Because rovers here have scoops as well to sample, to excavate things and sample. That's really a great story, and that's the nice thing about many of your colleagues, I guess. With a background in either the competition or in space?
Yeah, a lot of my colleagues from the team actually now also work in the space industry in different fields, so a lot of electronics, software actually, engineering as well, depends.
Brilliant. So again, a great example of where participating in this competition can lead to. So,
I can definitely recommend it.
So thank you very much for sharing that. There's one question I have to finish off with. You're Polish, you went to university in Warsaw.
Yes.
But now you live in the UK. Are there no opportunities here in Poland?
I mean, they are, but actually after I moved to Netherlands when I was in ESA, I had the opportunity to work on the interesting project in UK, and then I just stayed there. Because there were other opportunities, so I could definitely go back if I wanted, but for now I'm quite happy. So.
But I think that's an important message, that you don't have to leave your country
no, definitely
to work in the space field. And it's kind of what Artemis said before you, is the opportunities exist everywhere. So you're a good example of that, and the fact that you're in the UK. I actually live and work in the UK as well, and I'm not from the UK
I think
originally.
I saw you once in Harwell, actually.
Very possible, yes. So yes, I work in Harwell, so so we live in the same part of the world.
Because AVS was in Harwell before. So
okay, well there you go. So a little personal story. So thank you very much, Emilia, for sharing that. And with that, I'd like to hand over the microphone to Magda. So welcome, Magda.
Hello.
Can you tell us a little bit about yourself? You're a member of the jury here as well?
Yes, I am a member of the science jury. I judge all the contests about how they created the geological history about our Mars yard and what they are planning to research there along the science task.
So is that in the presentation part of the competition?
They are doing reports after the science task, and then we have to grade them in order to find out who was the best.
Okay.
Who was the best mapping and the research plan.
Okay. Okay, very cool. So tell us a little bit about how that relates to what you do in real life. I'd almost say this is real, but in your professional life.
Right now, I'm still studying geology in Poznań, but I was a part of the Panga and Caves team as my internship, and this is the program where they teach astronauts geology and make basic tools that can help them research planets in the future.
So hang on, you were a geology student and you worked with astronauts?
Yes,
that
I
sounds
used to
pretty
for
cool.
a few months, yes.
And those people you worked with are now working on board the International Space Station then?
Not right now, but some of them were on the space station. Right?
Or even better, they might be the first Europeans on the moon then?
Probably yes.
Probably even?
Yes.
Wow, that's quite an amazing
Yeah.
story to tell your friends back at home, I guess. So,
Yeah, it's really pretty cool.
so how does a geology student end up working in the space field?
I mean, about planets, geology, I think it's the first thing about the planets. So you always need a geologist to find more about the planet. And I was just searching careers at ESA, and that's how I found out that they have this special program, and they need some geologists to focus on the minerals and the rocks that you can find on the moon or on the Mars, and that was my job.
Wow, that's pretty cool. So again, a good example of someone with a study. You're not a rocket scientist, but with a different field that found a job in space. So what are you hoping to do after your university?
I'm still hoping that I will find something new about the geology in space. So that's my main focus in the future.
Okay, wow, excellent. That's a really nice story. Thank you for sharing that with us, Magda, and good luck with your judging. We're going to go back to Maria Antonietta now, who will tell us a little bit about careers in space from her point of view, from the point of view of what we call one of the big system integrators at Thales Alenia, giving her view on what's happening with opportunities in space. So over to Maria Antonietta. So welcome again, Maria Antonietta, in the European Rover Challenge. And in this block, we're going to talk about, maybe something different, but something that many viewers will be very interested in, and that is careers. So we know that humanity is preparing on going back to the moon and later on to Mars, and probably the first person to walk on Mars is already among us, and we know him or her already. So this will create new inspiration for lots of people who are looking for a career in space, and when we move to the moon and Mars, we'll need a lot more people in the space industry. So how do you think that this new exploration is going to change the labor market for space?
Well, in fact, the labor market is changing continuously at a very immense pace in the last years. In all the possible fields, in particular in the space field, type of professional skills that are needed are enlarging. For sure, what I learned in these many years being working in space is that a space mission requires a sort of interdisciplinary approach. It's not just the output of a very specific activity on a very specific aspect. So, for sure, to keep exploring Moon and Mars and asteroids, we need engineers, we need technical guys, we need mathematical skills, we need for all the payload development, we need people with a strong physics understanding, but not only technical professional people. We need people with a solid background in business and management, people with a solid understanding in legal aspect, people, because this future mission will involve humans, we need a medical doctor, we need a psychologist. Can you imagine a crew of 6 people traveling to Mars for a mission that will last between 1 and 3 years, according to the type of mission that we select. And so you have these 6 people in a confined environment for, let's say, 3 years, leaving our planet for a challenging trip. So one of the critical aspects will be the psychological well-being of these people. So the selection of the proper team for sure is the beginning of the adventure. But then all along the mission, we will need a supporting team on Earth, on ground, to accompany the crew along the trip. And also another huge challenge for missions in deep space. So as soon as we leave our planet, the protection of the Van Allen belt, we are surrounded by an environment that is beautiful to be seen, but also very dangerous because of, for example, because of the radiations. And so medical doctors that can advance our understanding with respect to these problems are key for these missions. So the good news for all the young people that are listening as Renko today is that in fact the universe is huge and there is room for everybody. So if any of you guys and girls listening this mission, this program, if any of you is interested in living every day to advance our steps in the universe, just consider to work in this field is an amazing adventure every day. Go for it.
Excellent. Well, thank you very much. I think that's a very strong message. Basically, there's a place in space for everyone, and that will only be more and better in the future. So thank you very much again for your contribution, Maria Antonietta, and thank you very much for your role in this year's European Rover Challenge. And we're really looking forward to seeing you again in our next mission next year. So again.
Always a pleasure, Renko. Easy with you. Thank you for joining me today. Ciao.
Thank you. So we are back with our friend Neil Armstrong here with Justina Redelkiewicz, if I say it correctly, of USPA. You're one of the big supporters of the European Rover Challenge. So tell us a little bit about why USPA is here supporting this event.
Thank you. Yes, I'm a big supporter of European Rover Challenge, not only because it happens in my own country, but also because it brings here a lot of interesting people from the space sector. And USPA is the coordinator of the use of space data on Earth. So for us, the most inspiring is the day number 3, which is tomorrow, that we will be opening with my keynote. And we are really interested to explain how you can make business with space data here on Earth.
Okay, because let's explain that to our viewers. Tomorrow the theme is Earth. So the first day the theme was Mars. Today we talk about, well, Neil's place, the moon, but tomorrow the focus will be on Earth. And that's really where the space business, where the money is in a way, isn't it?
Exactly, because in the end the space infrastructure was maybe built to explore the universe, but in reality we discovered that it brings a lot of benefits for us, for citizens, for businesses. And today it is really difficult to imagine an application where space data cannot be used. And one day I was thinking to organize a competition actually to invent an industry or part of the economy where space data cannot be used, because we really find every day new applications.
Exactly, because that industry probably doesn't exist, does it?
That's true. So here we are also announcing a lot of activities of USPA. So tomorrow I will be launching our new competition for startups. So we are really encouraging if there are some entrepreneurs listening to us to check our website and apply to our My EU Space competition with new ideas on the use of space data on Earth.
Okay, and that really connects to the theme that we've been talking about for the last 45 minutes, is career opportunities in space. We talked about the jobs that are available. We also talked about entrepreneurial opportunities that exist. So tell us a little bit about how USPA supports aspiring entrepreneurs who may have an idea or who may have the wish to become an entrepreneur. How can USPA help these people make a viable business out of their idea?
Yeah, sure. Actually, I think it's the best time ever to be a space entrepreneur, because 1 year ago we launched together with European Commission a new program that is called Cassini, and this is a 1 billion initiative. So there is really plenty of support actions, not only financial support, but also like technical support, business support that all the entrepreneurs can profit from. So I really encourage everyone to look at cassini.eu. There we are announcing constantly new actions. So starting from hackathons where you can just invent a new idea, then business acceleration, competitions like My EU Space, several programs of a few months where you can really build your product or solution with us, and then last but not least, support to get access to finance.
Wow, and that's obviously the biggest challenge that entrepreneurs have, is how do I finance my business, especially in the startup phase? So €1 billion, you say?
Exactly. So there is a new fund called Cassini Growth Facility that is implemented in cooperation with European Investment Fund. And the VCs can apply to get this budget in their own funds and then support entrepreneurs.
Okay, so even venture capitalists, investors can benefit from this fund.
For sure.
Not just the entrepreneurs. So there's basically money for everyone?
That's true. I mean, still you need to have a really good business model.
I knew there was a catch.
Yeah, because I would like to say that, okay, there is a lot of programs and money available, but what we do a bit differently at USPA is that we also support to generate the demand. So this is our main mission, to speak to different corporates at different industries, you know, to pharmaceutical companies, to telecom companies, to insurance companies, and to tell them, look, you have to start using space data because there is a business model behind. And so we are kind of making the way that then the entrepreneurs can follow, because it's quite difficult these days to, you know, like get real access to big customers in Europe.
So you don't only provide the funding money, you also provide the launch customers, to use a space term.
Indeed. And I really encourage all entrepreneurs to come directly to us. So you can, of course, consult the website, but contact us. You can find USPA on LinkedIn, and we are at the moment providing really like one-to-one support. We are really eager to listen to interesting pitches, talk to companies, and help them in customized way.
Okay, so when we talk about applications of the space data that USPA obviously manages, what type of applications should I think about?
Well, actually, the best source to consult is our market report. It's a 200 pages publication available for free on our website. where we describe more than 140 applications of space across 17 industries. So we are speaking about agriculture, infrastructures, maritime, autonomous cars, drones. Really, that's just a few examples, but it's, I mean, limitless.
Okay, so even people with, say, an agriculture background or a smart mobility background or forestry or geology. We had a geologist here in this little studio a few minutes ago. If they can find a way to use space data, they can go to USPA for your support.
Definitely, space data and space services, because let's not forget, apart from Earth observation, we have also navigation. So today everybody has already a space receiver because we have a smartphone, we have a car, so we are connected to Galileo satellites. And also Galileo is providing very accurate time. So also, for example, time stamping of transactions, so implementations in banks, in stock exchanges. Really, there is, I think that everyone can start thinking about how can I use space data.
Really everyone. Again, there is no industry that can't benefit from space.
Exactly.
So I think that's a really good message. Now repeat again, where can people find all this information?
So either to go to USPA website, so uspaeuropa.eu or cassini.eu.
Okay, brilliant. And of course, you can follow USPA on all social media channels, something that I always like to highlight. You can follow USPA, you can follow what's going on here, hashtag ERC 2022. So with that, we'll go back to the teams.
Thank you.
Thank you, Justin. That was really good. Back and welcome to the Team Zone. This is the room where all the teams prepare for all their different missions, and we're going to show you a few teams today. We're here with Team Interplanetar, and it is like you almost had an interplanetary journey to come here. Can you quickly introduce yourself and tell me where did you come from?
Okay, so I am Farsa Kausa Choudhury. I am currently a science sub-team member of Team Interplanetar, and we have come here from Bangladesh.
Seriously, you came all the way from Bangladesh to participate in the Rover Challenge?
Yes, it was a 13-hour plane journey, really an exhausting one, but finally we were able to come here today.
Excellent. Well, congratulations about being qualified, because I know that getting qualified is already not easy. But tell us a little bit about the rover. Why will this rover win the competition?
So we think this rover will win the competition just because of the arm. So you see, our arm has a 6 degrees of freedom. We currently not attached the arm gripper yet, but we have the elbow and joints with our arm. And another best thing about our rover is the tires, the wheels of our arm, of our rover. And you see the wheels are pretty much lightweight, and we efficiently use the system that is available in our country, and we design the wheel so that it gets high friction rate when we traverse on the Mars yard.
Okay, let me tell you one thing about this. In South Asian countries, the manufacturing facility is not quite advanced like the European countries. So we had to manage all the stuffs from the household materials, from the local materials, and we had to machine and manufacture it by our own. So it was really difficult from the other teams for us to compete here and make this fully operable, actually.
Okay, but you did an extra great job qualifying then. So how's the competition been so far?
Yeah, the competition been so far good, but the rain just rescheduled our tasks here. If the rain hadn't available, we could have done the tasks already earlier, and we could have done the tasks been better. We could have done better. Due to the rain, we have to reschedule the tasks at night. So at night, you see that there's low light. We can't figure it out where is the canals, where is the works. So it's been tough at the night, to run the rover,
Yes,
but it's good in the day.
Due to rain and due to lack of light, it's very difficult to trace the scientific objects and to perform the scientific analysis. So this was the thing we have faced till now, the issue. Otherwise, it was great.
Okay, now tell me a little bit about your team. I always ask the teams about their backgrounds and how many are there in your team to start with?
We have almost 48 to 50 members in our team, and we are actually from Bangladesh University of Engineering and Technology, where most of our team members are from Electrical Engineering Department, Mechanical Engineering Department, and Biomedical Engineering Department. But to Poland, we have come, only 9 of our members have come here to compete, but we are also participating in the remote edition, and they are performing from Bangladesh to that.
Okay, so you're performing in both the on-site and the remote one with the same team, or is it like two separate teams?
This team is performing the on-site tasks, and we have another subdivision of our team which is performing the remote tasks from our country.
Okay, wow. Now tell me a little bit about the software that is driving this rover. That is all self-developed as well. Do you have software engineers doing the software side of it?
We have a team leader and our software sub-team leader, so you can ask about the software and other stuffs from him.
So tell me a little bit about the smart software that you built in, and how autonomous is this rover?
The rover has autonomous capabilities. So we are using ROS, robot operating software, that has some libraries, and also we have a real-sense depth camera that can use to detect obstacles on the Mars yard, and we can use that to autonomously travel with our rover.
Okay. Have you been using that autonomous option in the competition?
Yeah, we tried to use it, but there were some issues with the autonomy when it was in the field.
Okay, but you have a manual override in that case?
Yeah, we also have a user interface, manual user interface that we can see right here.
Okay, let's just step over here then, if that's okay, and if the camera can see. So tell us a little bit about this.
Yeah, so there is a camera feed over here, and then there is an arm control mechanism, and there the science module mechanism that controls the entire rover in just this one software. Also, there are other controls like the camera feed, there is feed, and there is the battery status that can note the power consumption of a rover.
Wow, and that's all through the remote control. You control it from here, or do you bring it to the Mars yard outside?
I bring this, and there is the antenna. This is our base antenna. We bring the intercept of the Mars yard, and then our rover can operate here. We also have an antenna of the rover. You can see that here. There are 2 antennas right here.
Okay. Oh yeah. Very good. To close off, is this the first time that your team participates in the challenge?
The team has been participating in this challenge for 3 to 4 years, and before us, one team have come to Poland to compete in the finals, and we have been participating in this for 3 years.
Wow, so you're sort of experienced already, so that probably gives you a little bit of an edge as well.
Our seniors did the part of the previous competitions, and we are currently new members joining and going. As they graduate, they became the advisor of the team.
Okay, excellent. So you're passing your knowledge on to the next generation.
We have to keep the team fresh, because every time it is a huge budget coming here.
Yeah.
So we want every single possible member of our team to experience this.
That makes sense. So thank you very much for your introduction to your rover, and well, good luck, Team Interplanetar.
Thank you so much for the interview. Thank you.
So we're here with the next team, and the next team is actually in the competition, as you can hopefully see behind us here. I'm here with Nina of the AGH Rover team. Nina, can you introduce us to your team and your rover?
Sure. Our team is AGH Space Systems. We are from AGH University of Science and Technology in Krakow, and we are here with our rover Kalban. We are competing already for the 6th time in the competition, and currently our rover is doing the panel task. So during this task he has to switch the switches and plug some things in the panel. So it's a big test for the manipulator of the rover.
Okay, so we've seen the AGH rover in action on the Mars yard as well. What is special about this rover? Why is this rover going to win the competition?
Okay, so we've introduced a lot of better subsystems to the rover this year. First of all, he has a manipulator that has 6 degrees of freedom, so it's really good for performing the complicated tasks that he has to do. Second, we have analog vision, which don't have a lot of delays. So the man that is operating the rover can see in real time the vision from the cameras and just perform all these complicated operations. Well, what's more, we have a great team that is working really hard all the time, all the year on the rover, and they're motivated and they have checklists for everything, and they just trained really hard for this competition. They know how to do everything here.
Okay, so tell us a little bit about the team. How big is this team? How many people are involved in getting this rover here and making sure that it wins?
Okay, so all our organization, our association has 70 members, but these are 3 sections: section of rover team, of sounding rockets, and of marketing. So rover section has 24 members currently. There are several sub-teams, so there is a sub-team of mechanic, of electronics, of software, and science. Well, the first version of this rover was created in 2016, and since this time we're developing the rover constantly.
Okay, so I guess you're all robotics engineers then, and you're on these 28 people?
No. There are many members from various fields, so we have people that are specialists in software, in computer science, we have specialists in electronics, in mechanics, and we have specialists in geology and biology, because one of the tasks during the competition is performing some geological tests and searching for traces of life in soil samples. So we have also people that plan these tests and the whole mission.
Okay, excellent. Well, thank you very much for this introduction to your team, and looks like it's going quite well.
Yeah,
so fingers crossed, and good luck in the rest of the competition. Thank you very much.
Thank you very much.
Okay, and here we are with the third team in our little round of teams. We're talking to the SKA robotics team from Warsaw, and please tell us a little bit about who you are and about your team.
Yeah, okay. So I am Tomasz from SKA Robotics. I've been in our Students' Space Association for about 10 years now, since the beginning of my studies, and now I'm finishing my PhD, so it's, well, 1/3 of my life already. Our association actually in around 2008 began building first rovers in Poland. We built a couple of them. Of course, the team later was renewed many times, and here we have about 4th generation. Yeah, it's about the 4th one of the next rover and the next team that competes within the ERC. We've been competing in all of the ERC editions.
All 7 of them?
Yes, since 2014, and in many URC University Rover challenges as well. and twice in Indian Rover Challenge and Anatolian Rover Challenge.
Okay, so you guys are among the most experienced rover teams here. So tell me why this rover is going to win the competition here at ERC 2022 then?
Well, I think because we rely on our engineering skills that are growing because we are students, but we aim to design something that is exceptional, something that is not very often seen among such designs like rovers. We do not copy designs that already exist. We try to invent something new. We have a completely new calculated spatial 3D frame and copper beryllium suspension, which is a huge innovation because nobody has ever done anything like this. So yeah, we do aim for design challenges that are not trivial, design challenges that help us to grow and present ourselves as future space engineers. And actually for all our entire association, and the robotics is just a part of it, there are many more parts, balloons, rockets, satellites. Many of our alumni do start working in space industry, in ESA or in other companies that are private companies. So yes, the things that we do here, the things that we design here are very valuable for us, as it's a very precious, very important learning by doing.
Okay, so it's an important thing that you say that many of the students that have competed in the past are now working in the space industry. So this is really a good jumping board, if you like, for the space industry. So tell me a little bit about how that works.
Well, when you start competing in such challenges, when you enter such projects, you automatically start to learn the very basics of space industry, beginning with the documentation, all the procedures needed to fulfill the tasks and to be successful. Later on, after rovers, you may get involved in more specified, more difficult projects like stratospheric campaigns among the Rexus-Bexus program, which our roboteers often do after finishing with the rover, maybe because they're fed up with the robotics, but also they're getting more and more skilled, and they can put this into execution in something which requires a little bit more elaborated analysis, more elaborated science. And of course the documentation needs to be kept at a proper level. So this is like a multi-step springboard towards a fully qualified space industry, I must say. And actually many of our alumni told us that by learning in such projects, for example, how to do documentation, made their work very, very much simpler because they already knew everything how to do it.
Yeah, exactly.
It is simplified naturally because it's a student competition, but the very basics are the same. So learning and being successful here is a huge springboard towards a space career.
Wow, I think that's a very valuable message and a great message to close this interview with. So if you're watching the live stream now with the ambition to have a career in space as an engineer, but also as a non-engineer, you must have non-engineers on your team as well, then getting involved in the European Rover Challenge or in rover building in general at student rover teams or rocketry clubs or any other clubs related to space, then by all means do so. This is a great jumping board for your career. And what you do in miniature here, you do in big at the big space companies. So thank you very much, Tomasz, for your time. And we will move to our next subject right now. Right, and here we are in the heat of the remote competition right now. It's very quiet in here because this is one of the robot arms that is manipulated by our remote teams. As you know, there's an on-site rovers that are here, but also a remote competition where teams from all over the world operate rovers here in the Mars Yard, but also this robotic arm. So I'm here with Jakub, one of the jury members. Jakub, can you tell us what's going on here?
Yes, so basically, as you said, teams are connecting from all around the world, and they have specific tasks to do here. So they knew how these modules are going to look like, and based on the Aruco markers, they are supposed to detect them either autonomously or by simply moving the robot manually and press the buttons. That's one of the easiest tasks. I think the second most easiest one, actually it's not easy, but the less hard one, is to grab the sensor positions on the left side. I can show it to you. It's a little box that sends a wireless signal to the graphical user interface that we'll show you in a bit. And you can see its orientation in three-dimensional space. And the task is to attach it to this left Velcro panel here in a specific orientation. Now, what's the most important, the hardest part here is on the right side. You have an inspection window where you simply lift up the lid, place it here, and look for the marker that's hidden inside. It's hard because the position of the robot where you can see what's inside here is a very steep angle inside in order to hide the marker. It's very difficult to get into that position, even in manual mode.
How can teams see what's going on? Can they see it at all? Yeah. Is there a camera on this thing?
Cameras here. We have 3 cameras. One's on the gripper, one's above the panels, and the third camera we can move it as depending on the situation. It's either on the right side here or on the left side when you manage the IMU unit.
Now we talked for the on-site teams about operating the rover manually or autonomously. Is that the same here? Can they pre-program it to do all the tasks autonomously, or is it controlled by sort of a user interface?
Yeah, you can control it manually with the interface that we prepared especially for this competition, but also a solution that we encourage is to send your own software, and then we will launch it depending on which objective you want to perform at the time.
So again, more points for creativity and thinking a few steps ahead.
Exactly.
Okay. So we're in the middle of the competition now. There is a team operating this arm from, well, I don't really know where in the world. It doesn't really matter. How have the teams done so far?
So far, one would think that the autonomous solutions where we have double the points for the objective would bring the most benefit. But actually, as it turns out, we give penalty points for collisions. And if you code a robot in such a manner that you are pretty close, or maybe there's a bigger danger of hitting something, and you actually hit it, sometimes the outcome of hitting can outperform the bonus points that you get for autonomy. So actually right now, a team that's on the lead did all the tasks, not all of them, but they didn't do any autonomous solutions. So they did everything by hand, and they are currently on the lead.
Okay, well that's good information to know, and we'll learn tomorrow on Sunday which team wins. Just for our information, because we can't really see the teams, how many teams are competing in the remote competition?
This year we have 11 teams, which is not a very, very large number of teams. We had more teams before the qualification, because it's good to remember that we have finals over here, and there were many more teams who didn't manage to qualify for it.
I see, and where are the teams from? Are they literally from all over the world, or does it focus on Europe?
Yeah, we have European teams also, but there are many teams from Asia, from Africa, so almost every continent, I think.
Okay, and again, this is a great opportunity for university teams who may not be able to build a rover and bring it to Poland to participate in this challenge. And really, wherever in the world you are, participate. So you can follow the competition and everything else that's going on here at the European Rover Challenge, of course, through this live stream. I hope you're all watching. Those who are not watching right now, please turn on the live stream. But you can follow us through social media, #ERC2022. And tomorrow we will reveal the winning teams, both in the on-site and the remote competition. So thank you very much, Jakub, for this explanation, and good luck with judging the 11 remote teams.
Thank you very much.
Here you're close to big business, both Polish and international. Contacts with various industries are within your grasp. Nearby, professional research laboratories are growing. Here, science supports development of the newest technologies. Well-educated specialists are easily available. All that in one region. Come and invest here. Świętokrzyskie, close by.
The second day of the European Rover Challenge 2022 comes to its end. We have learned a lot about the moon, new generation of space stations, art and living in space. We also joined the ERC competitions teams and cheered them up during completing the tasks at the Mars yard. Let me thank the organizers of the meeting, partners of the event, especially the Polish Space Agency that was responsible for the Lunar Day, participants of the competition, and our broad audience for making this day very special. Let's meet here tomorrow at 10 a.m. to start the Earth Day and the last day of ERC 2022. Have a good time and see you soon.
Here is a place where you can start your company. Here you will also establish professional contacts and develop your business. Attractive conditions await your business. Land for investment and infrastructure offer unlimited possibilities. Here business meets the world of science and technology. Young inventors conduct projects on a cosmic scale. All that in one region. Come and invest here. Świętokrzyskie, close by.
Have you ever wondered how much space missions helped our everyday lives? Solar panels, water purification, inch-precise GPS, laser eye correction, artificial limbs, home insulation, Teflon, cordless vacuum cleaners, timber foam. All of these allow us to be more comfortable, and there's one thing that all of them have in common. They were all created during the space programs. If you have a challenge so large, margin for error so small, and with so many great talents combined, it's not a surprise that they find solutions that move humanity forward. You may wonder, what does this have to do with me? Well, now you can become a part of it. Get inspired, meet new partners, engage with the world's best engineering, programming, and scientific talents, strengthen the employer's brand, and support a cause that can shape the world. You can become a part of the ERC, the biggest space and robotics event in Europe since 2014. A place that connects ambition, innovation, and space. As space gets more popular, thanks to Elon Musk and Jeff Bezos, the event popularity is growing every year, even despite COVID-19. It consists of two parts. The first is the Challenge Zone. Just like hackathons solve important IT challenges, the Challenge Zone solves important space exploration challenges. Young teams receive tasks based on real Mars missions executed by NASA or the European Space Agency. They combine the power of robotics, AI, and autonomous vehicles to complete the missions and win the prize.
I think the most important thing that you're doing here is educating young people, giving them that kind of experience.
The solutions they invent are later used not only in space, but also in businesses, such as mines and factories. The European Rover Challenge has already welcomed more than 2,500 competitors from 6 continents. The second part is the Innovation Zone. We hold inspiring international debates about innovations, trends, and future.
The Apollo program that I participated in was primarily a program of young people.
Thousands of people listen, discuss, and experiment. New organizations, projects, and startups get formed. The event has hosted almost 200 speakers so far, many of them from our partners. How can you engage? You can deliver a speech or take part in a panel to show how your brand facilitates innovation and the future. Present an award to encourage best technology talents to keep up the great work. Organize a workshop to teach them and build closer relations as an employer. Meet top people from the space industry and form strategic partnerships. Want to learn more? Visit roverchallenge.eu.
We should go to Mars.
We should go to Mars.
We should go to Mars.
Because it's human nature to keep exploring.
Because we want to discover intelligent life in our solar system.
Because establishing a presence out there is a huge stepping stone to limitless possibilities.
Because we can.
Because our ambitions exceed this world.
Because humanity has unlimited curiosity and is destined to conquer the universe for good.
We should go to Mars because it's been long enough.
Because it helps to develop new technologies that are also very useful on Earth.
Because look at Mars could improve the way we look at our Earth.
Because Mars exploration is a huge milestone to extend our vision and discover a new home.
To play sports in low gravity.
And to define past, present and future of our planet.
It opens doors of opportunities for developing talents like us who wish to explore newer horizons and decide for the unimaginable.
We should go to Mars because the sky is no longer the limit.
Before the pandemic, we were around 20 people and we didn't really have
we were just playing around with an old, it's what was essentially an RC car, and then we were still working on stuff, but then the pandemic hit, and then we all went back to our homes and we started working from home, and motivation just dropped. And I mean, honestly, not even me, I was just, living day to day, confined, and nothing really motivated us. When we got back to school after a bunch of months, the dynamic just kept going like this. In December, we were very, very close to just calling the mission off and disbanding and just leaving each of us on their own paths and whatnot, until one of my teammates just sent me a link, and it was the European Rover Challenge, and we had a meeting to discuss it, and we just said, well, let's try. Worse than what it is right now, it cannot be. So we just tried, and we applied with a proposal. We started doing some work. People started showing interest and starting to work, because all of a sudden we had a clear goal, a clear deadline, and honestly an exciting project, because I think that going from having an RC car and just saying, okay, we can do this task, but when is it for? Well, when it's done, and you have no clear deadlines, and the purpose and the objective is just so intangible that you depend a lot on your own passion, and if at any point you lose a little bit of it, it's over. We presented our preliminary design report without many hopes, because honestly at that point the project, we considered it to be at a very immature point. We didn't have much, to be honest, but since we had help from very talented people, and a master's student did her thesis with us, it was good enough to qualify. And so that's when the craziness began, because it was the beginning of summer, and we had some things. We had the structure, more or less. We 3D printed, because we also wanted to use this opportunity to learn new techniques and stuff that we didn't know. But that was basically it. And we started working quite heavily during summer, and all the subsystems started coming together. We started getting very, very excited about the competition. Our main problems that we had this year was, first off, problems that we inherited from a long time ago. For example, the engines that we had were inappropriate for the drivers that we had for those engines, and other stuff like the materials that we used for the robotic arm were also maybe not ideal, because some parts broke on the way to Poland. One of the biggest issues we had was logistical issues. Once we were there, our entire rover was dead on arrival. So it was certainly a scary situation, because we had worked so hard to get to where we were at that point, and it didn't work. So we just got to the place we had rented and tried turning it on and performing all the health checks, and it was dead. So at that point it was a bit difficult for the team to accept. It was a challenging moment. But then the next day, someone in the programming team tried to program one of the engines with the camera processor. So what we had to do was, first off, we tested it and it worked. And then what we decided to do was to reprogram all the subsystems and bring them to the camera processor. And we spent our days there doing this, essentially. We had to forfeit the maintenance task because the arm was not ready. Our control scheme was busted, and it worked for a bit, and then it started spazzing out and acting erratically, and we decided to, for the better health of the the jury and ourselves and the maintenance board and everything, we went there and we said, hey, it's not working. I'm sorry, but we will not be able to participate. And the jury was very accepting and very helpful, because they told us that we might be able to try if we fixed it in the long run, and also gave us some tips, like maybe ask this team or this other team. And so both the jury and the other teams were really, really helpful in this aspect. When we got to the navigation task, our camera processing software was running at the same time that everything else was running, so it was too slow, and in the end we were essentially blind for the navigation task. We did not know where we were. That was also a challenging moment because you're in front of the jury, and all the teams are there, and they saw everything, and the jury was asking, well, do you know where you are? We didn't know. For the probing task, our probes were to be placed by the arm, which was not working as before. So, problems start, cascading down, and the tasks start kind of falling apart. But still, compared to what we had the first day of the competition, it was still, for me, it was still a satisfying result considering the situation, because for the probing task, they told us that we could, take pictures of the probing places before placing the probe, and then essentially not placing the probe because we couldn't, but that picture could still count as points. And especially to perform the science task, which we didn't really have many science experiments on board because we had no resources or knowledge, to be honest. The science capabilities of our rover were limited. And we did everything we could, and we took all the pictures that we needed, and then we finished all the tasks and went to present the pictures, and we found out that our picture taking scheme, or the software that took the pictures and saved them all with the same name. So from all the pictures that we had taken, we only had the last one, essentially. I mean, it was to be expected because we had slept very little and we had worked a lot, and we had essentially reprogrammed the entire rover in 2 days. And honestly, at that point, it had to happen, and it is what it is. That was our competition, When we applied for the European Rover Challenge, we didn't really believe we would get much far, because the team was demotivated. We had nothing. We barely knew how to control the rover in January when we applied. So we said, okay, our main focus will be 2022, but we will apply to 2021 to see just what they ask for and what they require of us, and to know what we know and what we don't know. It was a bit emotional for me, because once we got back, we decided that, well, we had worked a lot during summer, so we would take like a month of vacation, and just to relax, take everything in. I planned to talk to multiple teachers, and to go to the university where there are workshops where you can machine pieces and you can build stuff there, talking to electronics teachers and software teachers to have their help, essentially, when we need it, and to explain to them what we had done and what we lacked, and to ask for help, essentially. So in like a year's time, we went from not doing anything and just wanting to stop doing anything and just go our separate ways and just everybody go home and do whatever you want with your free time, to, well, I want to go again. We know what we missed, and we had some stupid mistakes that we could have avoided, and we want to make it better for next year. And we started to do a lot of more publicity in the university, start talking in different classes, and start talking to different teachers and getting more students on board. And this big snowball has started rolling, and it still hasn't stopped. And it was essentially thanks to the European Rover Challenge and the team and the rest the rest of the competitors, which also gave us so many good ideas, and who essentially taught us how to ask for help. Because when we had prior contacted other people in our university and other businesses around us during summer, nobody really paid much attention to us. And it was mainly because our approach was flawed. We asked them if they would help us without knowing essentially how they would help us, and without having a cooperation plan, and without saying, okay, if you help us, you will have this, your logo will be in this part of the rover, or your logo will be on our website, on our social media, etc. We did none of that. We just went and asked, hey, we qualified for this, please help. And not many people answered, and we started changing our approach in this aspect, and it's worked. There's multiple master's thesis and student thesis that are essentially subsystems of the rover, because it's not the same to make a thesis that just a concept or a simulation in the computer, but if I can build it with my own hands and then test it on an international competition, it's much more rewarding for the student. I'm very excited for this year because I mean, compared to last year at this point we barely even knew what we had to put on the preliminary design report, and this year we have already designed all the parts, we have an inventory of all the components, and we have a much clearer concept, and we are working a lot more focused on it. I hope that we can show our work next September in Poland. Why the European Rover Challenge? Well, I mean, it was one of the competitions we found. Mainly it was because a teammate found the link and sent it to us, and we saw that it was an exciting project. There are plenty of, you know, technical or like polytechnic universities in Spain, and so far the UPC has been the only one, which I also found surprising because, you know, being from Europe, such a project is very enticing, I think, to robotics teams from you know, Europe, and I don't really know why. Last year our main objective was to survive, which we barely did, and this year's goal is to, you know, last year we got 10th place, and this year our goal is to get higher than 10th place. Basically, my goal for this year is to achieve a good baseline, because last year we also tried to do a lot of stuff, you know. So this year what we're going for is we have already, you know, except, okay, for example, in the maintenance task, when you have to connect an Ethernet cable, we know it's a very complicated thing. If we have time at the end, we will try, but we are not preparing for it for this year because we want to achieve a good baseline, so that next year they can grab that baseline and iterate upon it and make it better. And maybe next year, you know, just build a better ground station, or maybe put even more subsystems or improve the subsystems that are already there. But this year, what we want to do is have something with which we can go to the competition and achieve a decent result, higher than last year, and try to at least finish every task. We are not going for perfection in every task, but we want to finish every task. And once we know we can finish every task with what we have, we can then start working to improve it for next year, for example. And that's our goal for this year. And I hope that if we can achieve it, then next year's we'll see the team reaching even higher and learning even more, because one of the goals of our association has always been two things. First, to put to use the knowledge and skill we learned during the degree, and also to transmit knowledge from older generations to newer ones. I am on the very end of my education. I'm finishing my master's degree, and then I'm leaving. Before I left, I wanted to have, you know, the younger generations that were motivated to work with us. The other team leader is much younger than me. It's like three or 4 years younger. You know, almost an entire degree of difference in time. And we chose him because we saw that he was very young, and he could learn from us, because there's a bunch of older guys, and they can learn from us. And then when they are in our position, they can teach people like him now, younger than him, and so that this knowledge can keep being imparted. And I think that if we achieve a good baseline for this year, we can use that baseline to teach the new members how to do it, essentially. And so if we achieve a good baseline, we think that next generations of students that come to this team will be insanely much more prepared than us. Make sure to be a bit realistic on your assumptions, you know. For example, us this year, we are not going for example, automation stuff. There's some tasks which give a lot of points to automation if the robot does it in an autonomous manner. But we know that with our knowledge and with what we have right now, it might be biting off more than we can chew. You So I think it's very important to be realistic. You don't need to go for all the points in every task. It's not, I mean, if you want to win and be the top number one, I mean, sure, okay, go for it. All the power to you. But I think it's important to have this mentality that you're not going there to compete against others. You are competing against yourself. The goal for the European Rover Challenge, I think, is to challenge yourself to something and to achieve it the best you can. And if you go with a mentality that, oh, we're going to be better than this team, or we're going to be better than that team, or we are going to win in this task or whatever, that's the path to disappointment. And after disappointment, of course you can bounce back and start working again. Obviously, we were also disappointed last year, but since our goal was not to win this task or to get X amount of points, I think it was easier for us to bounce back after it, because our goal was to beat ourselves, and our own flaws and our own limitations, and break through and just do the best we can.